BAS.201.
Hey Brian, what's up?
Hey Adam.
Oh, what's this?
Adam, what are you doing? Adam!
No!
Hey everyone, Jason here. We've tried to find someone to do the Kahoot. You know what though? We could just try and bring him back. I happen to have this. So we'll see what happens.
Hey everybody, good morning. It is Mega Mondays. My hair got really long after I got snapped away. It just, I don't know. Can everyone hear and see me on these Mega Mondays? How is everyone doing? I've got coconut Red Bull, so it's a good morning. Mega Mondays, jumping right into it. We got to see that Mega Man again. You know what's happening. Oh, where'd he go? Really? Mega Man, you don't want to say hey to us? Where you at, Mega Man? Loud and clear. Love it. Love it. Glad you guys are here loud and clear. Awesome. I've got my volume turned up a good bit. Let me go one more notch higher. You guys ever just feel free to tell me too loud, too quiet. You know how it goes. Just making sure, everything is under control. Looks like we're doing good on the volume. So that has it. The test. Now the test, there's two parts to the test, and I hope I didn't cause confusion. I noticed that we talked about this last week, and I had a date in there. I think I had it set for Thursday, so we could, let's see here. We're going to set a vote right now. We're going to do a vote in the class. You ready? And Streamlabs, someone give a check on. Good morning, Stevenson. Good to see you here. Let's give a check on Streamlabs. If Streamlabs is awake, then we might do a Streamlabs check right here and see what everyone thinks. Good. Streamlabs is awake. Let's do a Streamlabs check. Okay. So we will take a vote, and we're going to vote to have the test be due on Wednesday or Thursday, because I did have Thursday on there, and I don't want to cause confusion. I had said Wednesday in class. And people are already voting for it right now. I'm going to open it up here in the vote in a moment. But I don't want to cause confusion because I can see how something written out, like if you were to look on Canvas and see something and think that, wait a minute, I thought I was due on this day. And so Wednesday is W and Thursday is R because T is already taken by Tuesday. And so I'm putting it out there. People might already be voting. But so the vote is right there. Remember, vote exclamation. Whichever vote wins. So vote R or vote W. Oh, it's looking like a lance. Well, we'll see. Here we go. 2 seconds. So all the wrong way. Where's my... I am back now. Well, it looks like it's going to be a landslide. There we go. Is this a vote for the lockdown part? This is the respondus. Yep, this is the respondus part, Ryan. This is the respondus part of your test. This is the respondus part of your test. It looks like, yes. And it looks like, unless you vote if you haven't yet, but it would take a lot to overturn this. Here, I'm going to close the poll. Well, I will have it due on Thursday then. Let me change that. Sorry if I've told people. I have told some people it is due Wednesday. Let me change that right now as we're talking, lest people be like, wait a minute here. But how is everyone doing this morning? Tag someone in the chat here while I'm making this quick change to this. I changed it yesterday. I'm going to change it back. And I was just thinking over it. I was like, I know I've said this in class like 3 times, but I know that it can cause confusion. And you don't want confusion over stuff. You want people to be very clear. And if you're here in class, then you know what's going on. And so you'd be like, oh, well, he said we're going to put it on Thursday. Let me go do that. And I'm covering the wrong thing. But tag someone in chat for 20 points on these Mega Mondays right here. Ask them how they're doing. It's time to wake up. And there we go. Thursday. And we are not putting, you probably saw via the announcement, we're not putting, there we go. Everything should be changed now. So it should be showing up just due on Thursday. Good. Oh, everyone's tagging one. That's awesome. We'll be, I can make it available on Wednesday. Let's do that. It'll be available. Sorry. Swallow the wrong way. Great idea. It'll be available on Wednesday, so I'll have it up Wednesday starting. That also, lets people who want to take it on Wednesday take it on Wednesday, which I think is great. Does that work well for you, Casey, that you'll be able to take it on Wednesday? Please tell me if there is an issue with this. I know some people maybe had planned to do it on a certain day, but hopefully this allows for both Wednesday and Thursday. The max will be 200 today, 200 mega points. So the data was just the Google form, correct. We have a respondents test on Thursday, the second part, correct. Alex, everything you said for 20 points right there is correct. That the and some people have already finished it. The take home portion, which is now, don't remember, you can only ask for clarifying questions. Don't ask people the best way to not cheat on the take home is to literally not talk to anybody about it. To be like, oh man, number 9, I'm just stuck on. I just can't figure out the code. And they're like, oh well, you should type, associate or LM, or you should try this. Just don't. The best thing to do. Oh, you guys are awesome. All of you guys tagging everybody. The best thing to do is just don't talk to anybody about it. Awesome. You're welcome, Casey. So it will be out for you. Number 1 rule of Fight Club, don't talk about it. Yeah. The take home is Fight Club. Good to see you, Andrew. And so, I spent a lot of yesterday. I got the practice tests going. They're a little bit short. The practice tests are not worth anything. Can you clarify how to start it? Like, how do we put it? Yeah. Let me do that. That's a great question right there. 20 points, Sylvia, right there. What about the RMD file for the take home? Just keep it. You don't collect the data. That is correct. And so we do for 474, but not for 320. Respondents is due Thursday. That is correct. Ryan, respondents due Thursday. Take home is due Friday. That is correct. Ryan, 100% right there. You are correct. And so let me jump over to, let's go to the assignments. Okay. Is it going to load? Are we looking at it? There we go. And so now we are pulling up let's pull up the take home. Let's get it started a little bit here. Like, I can show you how to start it. That's perfectly good question to ask. Take home midterm right here. And you see right here, now there's a lot to read through. This is like literally the long instructions. I broke it up into sections. You're uploading your answers. You do not need to knit this file. So please, it's all right if you want to try and knit it, but you don't need to. Don't try to knit anything. Just, if it works, it works. If it doesn't, it doesn't. You're just uploading your answers. You need this right here. This is how to do it, and start early. Do not wait till the night's due. I expect it to take 3 hours. I talked to one person, took them 1 hour. So who's excited about that? Who's looked at this so far and given it a try? Who's tried any of the take home? Anyone tried any of it? And how is it? Now you can't say answers obviously, but you can. I'll let you say these right now. Like, this is me asking you a question, which you can put out. You've completed it. There you go. Alex, how long did it take you? How long did it, Neil? You can say how long it took you too if you want. And Casey, how long did it take you? You can say how long it took you. I'll let you say that. You can say, sorry, don't worry. If I ask you a question directly, like, don't just say things like, man, number 45 minutes. Dang, I should have made it harder. It's a trap. Well, give them 474s. Yeah, 474s. Woo! That one's going to need a curve probably. 474 has a bit of a longer one. They have a 20 question one, and they've got 4 loops in theirs. They've got a nested 4 loop, probably an hour. Yep. There's no time limit. You're right, Ben. No time limit. Oh man, Alex, I could send it to you maybe if you want. Alex, if you want I could send you it. Let you see it and see what. I'm not joking. If you want to give it a shot, I'll let you take a look at it, play around with it, see what you do, and maybe even send me your answers, and I'll tell you how you do if you want. I'm always up for people who want to, how much harder is the 474s version? I would say your guys, for your class and where you're at, this one's like a 4 or 5. I should have made it more difficult. Theirs is like a 7 or 8. Theirs is pretty tough. But there will be people, email me about it, definitely. There will be people, same thing. And theirs just goes, it has 4 loops. It's got functions. They have to write 4 loops. They have to write functions. They have to use like while statements. So there's some easy ones on theirs. Maybe I'll show you theirs too. I'll be talking more about them with theirs. Submit your answers here. You just go to the Google form. You type in your answers. So like your name. Make sure to put your name in this way. Some people even reverse it, even though I'm like, put your name in this way. And then student ID, and then 10 questions, each worth 10 points. And we go right here. Let's load up this. Now, what this file is, and I think it'll open, this is an RDAT file. And an RDAT file is basically like me sending you a package. So if I send you a package, it could have a lot of different things in it. And it's opening up inside of R. We don't want that. So this is not how you open it. I can change this under my file allocations. I haven't done it on this computer yet. It's on my Mac. If I click one of those on my Mac, it opens up inside of R. So right now, this is not doing what we want, but we can fix it. So you're welcome, Ryan. No, this is, as we always say, it's a conversation here. Like, I work with you guys. Like, that's why I'm always like, let's make a plan. I know there's a lot. This week is a big week, as we keep saying. So I really appreciate everyone, talking to me. I'll get things in my review like, doesn't care, doesn't listen to it. I'm like, what? I always want to listen to you guys. Okay, let me explain what I'm doing right now. I'm going here to this window. Once again, you can always slow down the window. You're welcome, Connor and Ryan. I appreciate that. 20 points, both of you guys right there. You're tearing me up, man. No, you're not. I just scratched my eye. So this right here is the load files for your global environment. And you know how the global environment is like the brain of R? Like, this is the brain of R. This is where you do work. This is where you send your work. This is like your multi-window. When you load something in the global environment, you're going to load things into the brain. So we're going to go here to where I just downloads. I think I downloaded downloads, and right here, this. So this is the RDAT file I just downloaded, which is an environment. So the environment's like a package. It's going to have stuff. You ready? Boom, we click it, and there it is, make midterm. Now what the make midterm is it's going to make your midterm. That's what it is. It's a function. Now what you don't want to do is some people will do this. Now you don't want to do that. Don't do that. So don't worry, if you did that, you're not alone. A lot of people do that. What that does is it lets you see the function. I mean, you can take a look at the function. You can see how the function creates all the data. If you edit it and do something, then you won't get in trouble. It will just wreck your midterm because, whatever you do inside of here will change what it does. So don't do that. Don't do that. That's, okay. I think don't do that. So we're going to go to make midterm. And once you go to make midterm, you type in your ID. Now, don't type in the number I typed in. You can type the zeros or not type the zeros. Either way, it doesn't matter. You'll get the same version either way. We're going to hit Control-Enter, send it down to the bottom, and look at this. Now, I'm going to remake it here real quick, and I'll tell you why. I cleared the bottom console, which I think I tell you to do in the instructions. Yes. These instructions right here is what I'm doing right now. One, I've downloaded this. Okay, so I currently have it downloaded. Now I'm going to clear the bottom console. So if you're wondering what does that mean, it means this button right here. This clears the bottom console. So if you have stuff down here like this, you click this button and you clear the bottom console. Now why are we doing that? We're doing that because, okay, good, it's good. Make sure it wasn't on insert. How do you grade this? Do you have a function? Yep, you bet. Definitely. Got a function that goes through. All I do is download your answers, and then I run the randomness, and then I can get all the answers like that. So, but everyone's is randomly generated because here we go. Watch this. This will generate the same exam. So the exam I just got right here, this exam is going to be the same exam every time. Now what I'm going to do is I'm going to grab this. Which do I say to do that? Run this. Okay, so I just ran that. Open a new R script or RMD if you prefer, which I'm currently in. I'm in a new RMD script. I mean, a new R script, excuse me. This is a new R script. And then I'm going to take this and paste the output. So this is this step right here. We're going to grab this output. We're going to go right here. We're going to copy, and we're going to paste. I tried to clean it up, make it look really nice for you guys. So you can see right here, there's all the questions, and then they're commented out. So you can go and you can see, here's my ID. Really? There we go. And then you can go right here, the first question. Copy paste in the Google form, the value in row 85 for promotion, for column promotion, data 1. So there's data 1, and there's column promotion, there's data 2, and there's other stuff. So when you run the function, it creates all these things inside of here. You've got, you still got the function, you've got a start number and an end number I created. You've got Q10, Q9, which are vectors of numbers. Sorry, I got the hiccups. And you've got data 1 and data 2, which are data frames. So you've got 2 data frames, two values in the data, 2 values, and then 2 vectors. So you get 6 things when you run this function. Well, I mean, the data frames have more than 6 in them. Does everyone understand what's going on right here? And these are the questions you'll be answering, and you'll put your answers into the Google form. Does this all make like sense? How's it looking on this? Does it make sense what to do? It's in the video now. Awesome. Let's see. I'll show you 474s. 474s, we can take a quick peek at theirs. Let's go to dashboard. And the grader has been doing it. Please tell me if you didn't get your bonus points or anything. I have a few people have emailed me that they didn't get their bonus points. Please make sure you get your bonus points. Look over your grading. You could come to me at the end of the semester and be like, Brian, I never got my bonus points on these things, but look at your grades as soon as possible. The grader's been doing an excellent job. They graded a lot of assignments this weekend. They've been really, I know this is like 3 days old right now, but they're both, thank you, Alex. I'm going to tell them that Alex and others are saying grader's the best. Well, no, only one person said grader's the best, but I count as 2 maybe. So they've been grading 320 and 474. Oh, that's 474 that hasn't had theirs graded yet. So you guys are up to date. And also one thing I want to point out, well, we got to go there. I'll show you their take-home midterm real quick, and then we'll go back to being serious here. Where's theirs? Programming midterm. Here we go. They have, and I said 4 hours for theirs. And if you notice, their instructions are virtually identical to yours. They do have some differences, like they have this section right here, how to store answers. So they actually send me their answers. So they have a different section right here on how to store answers. And then their tips for submitting are also a good bit different. So I wrote up these really good instructions, or we'd kind of written instructions that kind of altered them and made them better for what we have and then made them clearer. And they have this right here, BAS 474. Oh, I see. Well, now it's downloaded. We got it. And we're going to do this. We're going to clear this out from our that. We're going to clear this out. And then we're going to go over here to new file. New file. And my gosh, you can click this button. There we go. This button right here is the same thing as going to file new, but it's just a little bit bigger because I can't click buttons. We're going to go here to load. And this is 474. So don't worry if you're like, wait a minute, what's wrong here? We're going to go to the 474 midterm. This one is going to take a moment to load in. It's a much bigger file. It's crazy. It's really awesome. Warning messages. Okay, hopefully that doesn't break everything. And good, we have the make midterm. We're going to clear the bottom console right here. We're going to go to make mid new. Where are you at? Make my exam. There it is. Make my exam. We type in some numbers. Type in your ID. Uh-oh. Okay, there, it worked. Sorry. And I was thinking it was the 321. Okay, good. So 23432. So exam 234. There it is. Okay. So they create this right here, and they'll have to save theirs to their computer. So this is their exam right here. But one thing, I got to fix these lines, but it prints out. Maybe if I do this. This is their exam right here, and it's got all these questions. So we just type our answers in the Google form. Yep, the Google form. That's how you graded the Google form. This is theirs. So you see they got video game stuff. They have 20 questions, and theirs is a bit longer. Theirs, like I said, is much more challenging, but overall, I mean, very doable. And as I told them, there will be a curve. If you look at where theirs starts out, left arrow into Q1, element of answers, a vector of length 2, whose first element is the number of rows in games, and whose second element is the number of columns. 320, who thinks they could do this question right here? Let me zoom in on it. Who thinks they could do this question right here where you have to have a vector of length 2 where the first element is the rows in a data frame and the second element is the columns in the data frame? The answer would be, who thinks they could do this question? Who's like, I could do that. You have to just find out how many rows, how many columns, store that into a vector of length 2. There you go right there. Answers 474. So he's like, I got that one. I did that one. And make sure this is like their specific exam. And yeah, so I don't think this is too bad. And then if the grades are bad, like let's say the average is a 60, I'll curve it. So no matter what, you're being graded, if like Andrew's listening who's 474, you'll be graded against your peers. Not like against, but I mean like if your grade's an 80 and you're the highest grade in the class, you'll get 100. So I want it to be as fair as possible. So, and just don't, like tell people answers. Yeah, Connor. What Connor's doing, 20 points Connor right there, and Grant for asking questions. Connor is exactly right. Put your answers in the sheet and then upload them later. So that's got it. I think we know what's going on. Everyone's having a good day. That we are good. Out of all the tests, which one is the hardest for 320? The conceptuals are the harder, but now I'm putting the conceptuals online, so we'll see how the grades are. Usually the coding gets like an 85, 90 average. Like the coding averages are very high, because I don't think it's that hard in 320. Like the requirements for coding skills is like basic coding skills. And then it gets way harder for 474. Oh, I should show this off. Here, I'll show it off at the start of the next class probably. And then the conceptual exams usually have averages in like the low 70s. So that's kind of what I expect is like for the coding, I expect like 85 average, and then the conceptual I expect like 72 average. So usually those pull down grades. Not that I try to do that, but it's just where we see the gaps in knowledge. But I mean, lots of people make A's, lots of people make B's. I'd say 40, 50% of the class makes an A or B. Like maybe 25, 30% A, 25% B, and then you got 45% of the class that makes C's, D's, F's. So for 320, it's just just the answers to the Google Sheet. 320 is just the answer to the Google Sheet. Yeah, coding exam is definitely easier, as Ryan's pointing out. Any other last questions? I'm going to learn how to drink drinks. Connor, 20 points. Thanks for helping out, Connor. Love you guys having the conversation right here. That's what we do. We help each other out. What's up, back? I'm trying to make it like 50 questions, and it's tough because I have to make like 120 questions. I'm trying to make like, because your questions are randomly selected. Now the practice test, which has no due date, has questions that will be on the test. So you will get to see some questions that are on the test by taking the practice test. So go ahead and take it. It's not worth any grade. Also, please, please, please follow my instructions. You will show your cheat sheet. And then you don't have a pen out or anything. It's because you don't want to be writing stuff down during the test. So you can't like write down questions. I mean, I'm not saying you would do that, but you're meant to, there should be a Kahoot tomorrow. Yep. Is there specific practice tests that are best to look at? All of them. Yeah. And it's kind of harder since that's why I'm putting out the practice tests I do have a practice test posted, I believe. It's in the modules. And I'm putting out the practice test for you guys. I'm going to try to put out another one. But since this is like, we're doing it now online, you don't want to put out online practice tests. So that's probably my best advice there is like you can go through the practice tests I've posted, fun fact cheat sheet, written, handwritten, or typed, either or, and then just don't write down during the test. And yeah. Any other last questions? Good questions about the test and everything. So we know what's going on with the world. We good at. Also, I've put due dates for every assignment. I hope to not move them. I think we'll be good. There's a lot of material, but we're good. We got this. You're fine. You got this, Andrew. You got this. I was literally yesterday teaching my brother about regression. He and I were going through, and I was like, this is exactly what we're doing in 320 right now. My brother is a pharmacist, and he's taking a statistics course right now for his MBA. Yeah, you're welcome, Connor. And please, if you're like, hey, Brian, I really want to know when things are due, because if people had said that to me, like, hey, it really helped me plan out my life. So then I spent some time, sat down, and reworked it a few times, and got to where I'm pretty sure we'll be able to maintain it. And people ask, and I try to do. Just always ask. Never hurts. And I have said no to people. Some people are like, can you do this? I'm like, no, can't do that. And so it happens. Can the cheat sheet be a whole piece of paper? Yes, it's just standard paper. Don't pull some craziness where you have like a poster behind you. It's standard paper. It's your usual sheet of paper. What do you mean? What do you mean usual? 8x11 is it? No, I'm gonna be off, and it's like a paper's like a 6x10, and someone's gonna get an 8x11. But you know what I mean by sheet of paper? It's like sheet of paper cheat sheet. Yeah, when you show your paper, it should be a sheet of paper. 9x13. You have to cut off the 13. You have to cut it down to 11. So exact. If it's a centimeter off, you're cheating. No, I'm just kidding. Just don't be. If you read over the cheat sheet stuff, read over the guidelines. Don't talk to people during the test. Don't talk to yourself during the test. Don't have people in the room during the test. If all of a sudden, and I have seen this, someone's dog starts barking, try to make sure your animals are safe and sound and doing well before the exam. But let's say in the background we hear a loud crash, and you hear the dog start. I would go take care of my dog. Dog starts whimpering, or you can tell the dog's having problems. Just say, there was an accident in my house. I have to go take care of this. Yeah, exactly. So that's the thing. Yeah, I understand. Some people have already emailed me about that. So yeah, don't talk to yourselves. I know it sounds crazy, but someone could be cheating because you could have your phone in your pocket recording yourself, and you could like record the exam. You could be like 2 equals 2. So you could record the whole exam by just talking to yourself, or someone could be sitting outside the room, and it's everything up to simple linear regression. It's everything up to this Ben right here. It's everything. We're not including this at all. So it's everything except simple linear regression. And so I'm not saying everyone who talks to themselves is cheating. We just can't tell the difference between someone who's talking to themselves and someone who's trying to cheat by doing that. So there's no noticeable difference. Like if someone's sitting outside the room, we're not going to know. If your phone in your pocket's recording, because what do we then say? Okay, you have to like show your pockets are empty. You have to like, I mean, it'd get insane. So the best way we can do is say, just don't talk to yourself. Like pretend you're in an exam room. So it's really tough, and I understand. I'm sure I might. I mean, if you all don't freak out. If you're like 2 and you're like, oh, I just talked to myself, just don't do it. And if you happen to do it, it's gonna flag you for like 1 second. It'll be like, student was talking, and then I'll see you talk for like 3 seconds. You're like, I don't know. I mean, there's a difference. Just try not to talk to yourself. There's a difference between you being like, what's the answer? Oh man, or like 2 equals 2. What is that true or false? Like there's everyone No, it's all right. I didn't say that, Ben. Like that's why we're trying to, and we're developing this as a Haslam College. We're developing like a student code of conduct for online test taking. So we're trying to be more clear in our expectations. That's why I sent this to you beforehand. So that way you're not like, whoa, wait a minute. And right now I would just I'd bring you in for like, I would test you myself to make sure you have the knowledge. But we just want to have secure online tests, which is a hard thing to do. So thank you for your understanding, and we're just trying to be as fair and even as across the possible board. Can I put a sign on my wall that says that is acceptable? Yeah, it is acceptable. I definitely, you'll crack me up if I don't know. I watch some videos, especially I go through the flags on videos, but imagine if I watched everyone's video for the whole video. Oh my gosh, I'd spend whole days just watching videos of people taking tests. It'd be boring. But I go through the flags. Like it shows us flags on like the important events, like student was talking, student left room, student shouted answer out loud. It doesn't say that. We are good to go, I think. We know what's going on with the world today. It is time. You guys are cracking me up. Sylvia, 20 points. Ben, 20 points. Connor, 20 points. Dennis, 20 points. Brad, 20 points. Steven, 20 points. Everyone was on the screen right there. We just gave 20 points to. Remember, it's easy. It's easy. We got to do it one more time here. Mega Man knows what's up. I'm going to drink some Red Bull. We are good to go. Get that coconut Red Bull. It's awesome. Okay. Let's do this. I should buy it. I should do it today. I should just buy it. Should I buy Crab Rave? Yes or no's in the chat. Y's or N's? Should I just go out and buy? Should I just go buy Crab Rave? It'd be $5 a month. Maybe I'll go do that today. I'm always afraid entering in credit cards like sites like that, even though it's like Monster Cat's a real site. I'm like, what are they gonna do with that? Okay, here we go. Okay, so the regression equation. One of these days I might have I don't know if UT would want me to have a Patreon. So here we go. It is time. It's time to get serious here. Let's make this happen. You ready? Let's do this. I know we need to make our own. So the regression equation has, you guys are cracking me up. The regression equation has 2 parts to it. It has the B0 and the B1. Now these are betas. These are beta 0 and beta. These are beta 0s and beta 1. Beta 0 and beta 1s. Does this make sense? Beta 0 and beta 1. With beta 0 and beta 1, beta 0 is the coefficient of the intercept. Beta 1 is the coefficient of the slope. Does that make sense? Beta 0 is the coefficient of the intercept. Beta 1 is the coefficient of the slope. So with this right here, we get the regression equation. These will be numbers. I think this confused me for the longest time when I was doing this because I didn't understand these will just be numbers. What are these numbers right here? Just visually, they're this. Does that make sense? Visually, this number, beta 0, is the mark where when x is equal to 0, y is equal to beta 0. When x is equal to 0, y is equal to beta 0. We rarely care about the intercept. The intercept's like not too big of a deal, but What we really care about is the slope. Now, this is the one you really need to know how to interpret. So this will be on the final, but what we want to do is we want it for linear relationships. Oh, I should do that, Alex. Alex, remind me about that, Alex. So that way I can do that. I should do that. I think a lot of my YouTube, like people I watch, like, I don't know, I shouldn't mention any, like, you watch that person? Like Jenna Marbles, she talks about privacy.com all the time. she doesn't do that. Jenna Marbles talks about Kermit and why can't I think? Kermit and Mr. Marbles and Pish. And now, can't think of the new dog's name. Can't think of what is their new dog's name? Bunny, that's their new dog's name. Just haven't seen enough new videos. It's totally Peach and Bunny. Yes, there we go. 20 points, Mila right there. Known some Jenna Marble pets. Pish. So water, the Pish. So, right here, the slope, this is huge. And you're exactly right. It's like y equals mx plus b. What of the y equals mx plus b is this? And let's make sure we know why we use this notation. What of the y equals mx plus b? 20 points in the chat. Go ahead and put it in the chat. What of the y equals mx plus b is this right here? What of the y equals mx plus b is this right here? You're seeing it. It's the m. It's just the m. It's just the m. It's just the m. That's the, because y equals mx, this is the x right here of it. So you can see it right there. There's the x, and this is the b. Now, a lot of people keep saying, like, okay, why'd you mess with our equation? Why'd you do that? Why'd you do that? So here's why we did it. Here, if I can find my pen. You used to, back in the day, you knew y equals mx plus b. But think about this. When we do y hat, it means predicted y. b0 is when x is equal to 0, plus b1x. Sometimes we put a 1 next to this, but I want you to think about this. This is when x is equal to 0. This is not the interpretation, but this is basically for each 1 unit change in x. Now, change is a bad word because we're not saying things change, but it's like for each 1 unit difference. So if you see the 1 right here. But that's what we say instead to a 1, but I want to make it more clear. The reason this has a 1 next to it is because this is x1. And we alluded to this because we'll be doing this very soon by the middle of the week, that here we might have a second coefficient for a second x. So what does this really represent? The b1 represents the coefficient of the first x, and the b2 represents the coefficient of the second x. And that's why we use this notation. So you can say b1 is the coefficient of the first x. b2 is the coefficient of the second x. And when you do this as a formula, like when you're actually putting in numbers right here, you would get something like y hat, or we could do it in context. You could say price, predicted price, is equal to 400 plus, and we could go, we probably should do minus, because I'll tell you why here in a second. Minus, no, it's got to be more than 400 then. 4,000 minus 0.01 miles minus 100 year. So what does this mean right here? The predicted price of a car is equal, this is a used car like we're going to buy. The predicted price of a used car is equal to $4,000 minus 0.01 times how many miles it has minus 100 times how many years it has. So what would you need to ask someone to predict the price of their car right here? What would you need to ask someone to predict the price of their car? They're going to go out and buy a used car, and then you want to know, maybe this is how much they'll get for turn in value. Like when they turn in their car, like you'd have to ask them these two questions. And think about what it means that the coefficients are negative. Years and mileage, 20 points right there. How many miles? Exactly, Mila, Brandon, Brad. And I want you to think about the interpretation right here. If we let's put just mileage on here, because let's go back to simple linear regression again. Simple linear just means it's one variable. You might say, Brian, why is it simple linear? It just means it's one variable. So this is now simple linear. So this is simple linear regression. Does anyone know? I'll give you 1,000 points. First person to interpret this correctly gets 1,000 points. Who can interpret this correctly? 1,000 points. You'd have to listen really closely to Friday's lecture. I mean it. I give out a crazy 1,000 points when you do something that impresses me. I want you to interpret that coefficient very correctly for this class. This is very important, and it's in the notes. And but you have to interpret the full. It's a full sentence. I'll give you 20 points there, Connor. You have to give a full sentence. And it starts with 2 cars. This is on the assignment. And this is something I see a lot of people make mistakes on. I tell my graders to be very harsh on. Very close, Henry. Henry, I'm going to give 100 points for that. That's close. That's kind of like a stat 201 interpretation. Grant gets 100. Casey gets 100. Brad a little further away. Here, wait. We can show off a hint here. Let's show off a hint. Wait, Mila. 2 cars that differ by 1 close. This is Mila. That's so Mila. I think we're giving it to Mila. And wait. So remember, this is not movies. This is cars. Nicholas is really close too. And this is mileage. I think Mila's getting the points. So let's read Mila's answer right here. Mila, excellent work. Amazing work, Mila. That's what we want right here. It would just be miles though. 2 cars that differ by 1 mileage are expected to differ by 0.01 in price, where the car with more mileage is expected to sell for less. Does that make sense? 2 cars that differ by 0.01 and 2 cars that differ by 1 mile, 2 cars that differ by 1 mile are expected to differ by 0.01 in price, where the car that has more mileage is expected to sell for less. Does that make sense to everybody? That's key, and that's what the notes cover. Oh, don't worry. You were right on. And that's what we get right here. That's where the interpretation is right here in the notes. And this is key to know. That's key right there. Ben, awesome points. Remember, get to that 10,000, get some crazy points on it, add to your grade. So, 2 cars that differ by 1 mile will have an expected difference of 0.01 in price, where cars with more miles are expected to sell for less. Cars, and so not will sell for less, but are expected to sell for less. Does that all make sense? Alex, extra 100 points right there, Alex. That's basically it, are expected to sell for less. And you see right here the expected. So if B1 is negative, the entity with the larger is expected to have a smaller value of Y. If it's positive, the entity that's larger will expect to have a larger. So 2 entities that differ in X by 1 unit are expected to differ in Y by this many units. So these interpretations in the chat are literally doing this right now. And this is what you should practice. This will be on the final. And you have to be very, very careful in this interpretation. But Dr. Petrie purposely wrote this interpretation to be very exact. Like it's exact in what you mean. And it's literally talking about what we expect and predict from the mathematical equation. So we can change the units. That's one thing we can do right here. You can go like for 3 units. So you could say 2 individuals that differ by 3 units are expected to differ by 3 units in the Y. I don't do this that much. It is in the homework assignment. I think it's pretty easy to notice what's going on right here, where you could say, let's go back to our question right here. We could change it. 2 cars that differ by 100 miles are expected to differ by how much in their price. 2 cars that differ by 100 miles are expected to differ by how much in their price. Who knows? 100 points first person to answer. 2 cars that differ by 100 miles are expected to differ by how much in their price. But the car that has 100 miles more is expected to be whatever in its price. Yep, Henry. Boom. That's it. If you're wondering how Henry, Brennan also, and Jordan, let's give them all 100 points. 3 of you right there, 100 points. If you're wondering how they got that, they just times this by 100. That's what this slide right here is doing. That's all this slide means. Does it make sense what this slide wants you to know? We need to know, like, what's this slide want me to know? You can change the units, where you could say, like, 2 cars that differ by 1,000 miles are expected to differ by $10 in their price. 2 cars that differ by 10,000 miles are expected to differ by $100,000 in their price. I mean, oh my gosh, by $100 in their price. So all you're doing is just timesing the coefficient by how much it is. So you'd say 2 cars that differ by 100 miles are expected to differ by $1 in their price. 2 cars that differ by, I know, right? I think I made the coefficient a little bit off. So I just took a random guess at what the coefficient would be. So this model probably is not that accurate to reality. It probably needs to be like 0.1, but they probably have some sort of formula they run it through, just some sort of algorithm that predicts price or like says how much it should sell for. So here's the interpretations you don't want to do. You don't want to say things will change right here. Like you don't want to say like change. You don't want to say if X increases, Y will change by this. You just don't want to do it. These are like the bad interpretations. You don't want to do it. This right here is something Dr. Petrie like really thought out and was like, what does it mean? And it's what we expect to see in this model. And we can literally look. that the line is showing us what we expect. Like two things that differ by here, 2 units are expected to differ by this many units of y. Now look, these things, like look, I'll show you another point. This point right here is higher than all these points except for that one. And none of these points right here really have this difference. Like these only have, does everyone see these have 1 unit difference of x? The education is 7, the education's 8. We expect them to differ by this amount, and like none of them actually differ by that amount. Like some of them are lower, some of them are higher. This is not on this week's test. Correct, Sylvia, 20 points right there. And so none of these actually differ by what we expect them to differ by. So you can't say like a person who has more education will have a lower monthly salary. You would say a person with more education is expected to have a higher monthly salary. So 2 employees that differ in education by 1 year are expected to differ in their monthly salary by $85, where more education equals a higher salary. So this is what we expect. It's not what will happen. Does that make sense to everybody? This is saying, oh, we would expect the people here to have lower salaries than the people here, or the people here are expected to have an $85 difference between someone down here. Like if you take person B and person A, you'd expect person B to be $85. That's what you expect. It's not what will happen. Not that if you have more education, your salary will go up. And that talks about change. Now, one of my favorite models to do this with is the following. I have to show you this model because it really makes the point clear on why we don't use the stat to 1 interpretation anymore. Oh, wrong button. And I really need to change it in 201. I need to make the case that we need to throw away the 201 interpretation. It's just like in the book. And what do you do if it's in the book and you can't change the book. You can't change the book because the book's wrong. Sometimes the book's wrong. Someone wrote the book and they're not always right. Okay, so we're going to make a model right here predicting somebody's height from their weight. So this model right here is how we make a linear model. LM stands for linear model. We're storing it into an object. We're going to write height, tilde weight, comma data equals, survey 10, y tilde x, comma data equals. That makes the linear model. You can do a summary of the linear model. This will give you the coefficients. Here is your B1, here's your B0, and here's your B1. Here's your standard error, which is your uncertainty. Here's your t-values, which are basically z-scores. And here's your p-value for the intercept. And here's your p-value for the slope. And here's your p-value for the model, which is the same as the p-value for the slope. We'll go over this in more detail in a moment. The big thing I want to point out right here, let's say you have someone who wants to be taller. And let's use the stat tool 1 interpretation first. Oh, really? Plot? You want to look like that? No one's going to like you. There we go. Okay, so here's the stat tool 1 interpretation of this. Here's the weight coefficient. So I can't even think of the stat tool interpretation off the top of my head. So for each, there it is. For each 1 unit increase in somebody's weight, for each pound somebody gains, their height will increase by 0.07 inches. So what does that mean if you gain 100 pounds? If you gain 100 pounds, about how many inches taller would you be? If you gain 100 pounds, about how many inches taller would you be? According to this, for each 1 unit, this is not the good 7. Yep. So think about that. It's the stat 1 interpretation, which we will not use. And I need to say, hey, the book is wrong on this. Let's stop saying what the book says. Because it says for each 1 unit increase in weight, we would expect somebody's height to increase by 0.07 inches. So for each 100 unit gains in weight, we'd expect someone's height to increase by 7 inches. These are wrong interpretations. But let's try the 320 interpretation. 2 people who differ by 100 pounds are expected to differ in their height by how much? 2 people who differ by 100 pounds are expected to differ in their height by 7 inches, where the person who weighs more is expected to be taller. Does that sound like it makes sense right there when you say it? Like 2 people who differ by 100 pounds are expected to differ in their height by 7 inches, where the person who weighs more is expected to be taller. You're not saying they will be taller. You're just saying they have 2 people, they have a 100-pound difference. I would expect them to have a 7-inch height difference, like where the person who weighs more is expected to be taller. And it's not talking about what happens to someone if they change, like if they gain weight. It's talking about what we expect when we have 2 individuals in the model. And look, you could take 2 individuals to differ by 100 pounds. You could take this person, you could take that person. They differ by 100 pounds, and you would have expected them to differ by 7 inches in their height. Does this make sense while we use this interpretation right here? So we should add that we are no 95% confident yet. We'll do that here soon, but no 95% confident yet. We'll use that soon, but no 95% confident yet. If you want to do 95% confidence rolls, you can do them with this. Here's 95% confidence rolls, just like that for every individual in the model. And this is why I always say, like, in 320 and stuff, we don't have to worry about writing code by hand, because here's a 95% confidence roll for every individual in the model. And actually, these are for the mean. And predict. Was that not? Warning message. So that should be predict. Does it take prediction? Good, it does. Okay, that's right. Right code. I don't know what the warning message. Predictions on current data refer to future responses. Oh, might be a new warning message it gives. I haven't seen that one yet. So let's hop back. Here we are. So here's all of our interpretations. These slides are very, very helpful because we can see right here 2 employees who differ in their experience by 1 year. So here's their 1 unit different in X are expected to differ in their monthly salary by 10.4, where the person with more experience is expected to have a higher monthly salary. Very, very key right there that we interpret it these ways. And there's just more interpretations. 2 bills at a restaurant that differ, or 2 bills at a restaurant that differ by $1 in the bill amount are expected to differ by 0.23 in their tip percentage, where the bill that is higher is expected to have a lower tip percentage. Know how to interpret these. These are on your assignment. I tell my grader to be very harsh on these, but you just need to go to these. You just need to go to these slides. So when you see interpret the slope, I want you to write it. When you see interpret the slopes, what are you going to do? Where are you going to go? Where are you going to go to? The what's. When you see interpret the slope, where are you going to go? 20 points in the chat. Take a drink here while you guys. When you see interpret the slope, Dennis, you're right. Yep. Don't be like, nah, you know, when you see interpret the slope, don't be like, it's 0.23. No, I'll get answers like that. Go to the slides. Now that you've said it, you'll know it. So great job. 20 points, all those answers right there. When you see interpret the slope, go to the slides. Make sure you're doing it like these things right here, and just be very exact. So be like, how does it make sense in my problem? 200 is the max points, but some people broke it, like Mila broke it. I'll tell you if you like get crazy points. So there's another one. It's all these interpretations. Here's another one. And now we're on to least squares. Cool. So all that was just different interpretations, just more practice. So don't worry, more practice. Least squares. What the heck is this least squares things going on right here? So there's lots of lines we could fit through our data. Really interestingly, there's a line we could fit. We'll see here in a moment. That would just be a flat line. We could fit this line through our data. And this line would go through our data. It's the mean of y. So this line right here is the average value of y. And then truthfully, it looks like it'd be right there. All the lines should like teeter around it. So that would be the mean of y right there. And that line is a pretty bad line. And that line will be used here in a moment. So pay attention to what that line will be called. It's called the naive model. You'll see in the notes. So what is the best line? How do we know what the best line is? The best line is the one that is going to reduce the sums of squared error. So let's talk about what that is. What is the sums of squared error? Watch this. You ready? This is so cool. I can do this. Here is a squared error. What did I do? I took a residual and I whatted it. I took a residual and I made the what of it to make it a squared error. I just took a residual and turned it into a what. So what do I do to a residual to turn it into a squared error? I just literally take a residual and turn it into what it. Just think about this, 20 points, who knows? How did I turn a residual into a squared error? I took a residual and whatted it. No one knows in the chat. Oh no, what am I doing to my residuals? Squaring it, that's it. And then what do you think I'm going to do to get the sums of squared error? How will I get the sums of the squared error? What will I do after squaring it? 20 points, all those squared it. Who can, for 100 points, tell me, add them together. Yep, Ryan and Mila right there. And Mila, you can get a 1,200. Keep going, because you got the extra bonus 1,000. Add them together. Yep. So think about the word. Like, let's look at it. You ready? Watch this. You ready? Sum of squared error. What is the error in the sums of squared error, which I think we'll see on the next slide right here. There's the sums of squared error. This portion right here is just the what. What is the error part? What is the error for 100 points? The error is, yep, Mila, boom, nice job. Yep, and Brennan also throws moist. Great job. It's the residual. And then what are you doing to the residual? You see right there. I can't highlight it. It's so small. There we go. You're squaring it. You're taking the error, you're squaring it, and you're summing it up. It's the sum of squared error. And the error is the residual. You can see right here, here's a residual, actual minus predicted, and that's what's right here, actual minus predicted. So, and how do we know that? Well, remember residual wrap. Why do I say residual wrap? Residual equals actual minus predicted, or residual actual predicted, residual wrap, and it's just the difference. And so the sums of squared error doesn't care if it's positive or negative. It's just going to take this error and square it and sum them all up. So sum of squared error. Yes. So once again, this is what the sums of squared error is, and we want to reduce this. So our goal is to have as small possible sums of squared error that we can get. This slide I don't care about. You won't do these equations. So this is one of the good parts about coming to class. Just these are references. I've solved these equations in 201, but you don't need to solve them. We won't be solving them. So pretty easy part right here. We're about to get to the last few big things in here, but when it comes to statistical versus practical significance, our biggest thing that we're going to look for right here is going to be the slope. So what is the least significant value for the slope? The least possible significant value for the slope is 0. And so think about this. If the slope is 0, let's pull up our Word document in the background again right here. I think we'll do that. There we go. Okay. So if the slope is 0, our line is going to look like, perfect. We're going to have dots in here. We'll do dots in black. We'll do space pen. So if our slope is 0, we're going to get a model that looks like that right there. So if our slope is 0, we'll get a model that looks like this. And then what would the p-value be? If the slope is 0, the p-value would be what? For 100 points. There's 100 bonus points that you can put on top of your points. What would the p-value be for the least significant line there is? Jordan, you were quick. You got it. It's 1. Because I said least significant possible. Yep. Sylvie, Jordan, Brad, 100 points, all three of you right there. And Casey and Brennan being super nice. There we go. It'd be 1 because this is the least significant possible. 20 points if you're still answering. Great job. And so this is the least significant possible. And think about this. You can see it here in the equation that we have here that it'd be the intercept. And this is what I've been talking about. And this is when there is no relationship. So what you see right here with this model right here is a slope of 0. And we have here the y-intercept. This is the least significant possible. This is the least significant model. It would have the highest p-value. And so what do we want? Well, our goal is to get a model that is statistically significant to then talk about if it's practically significant. And this is a review for the test. You're like, wait a minute, Brian, this shouldn't be on the test. But these are things that we cover earlier on, that something needs to be statistically significant first, and then it can be practically significant. So we will evaluate the p-value of the slope. I can't make this clear enough, that the p-value of the slope is what we will look at. And you saw me do this earlier in the output when I was like, we care about the p-value of the slope. So the p-value of the slope, which can be seen, we're going to have to go to our output screen. The p-value of the slope can be seen right here. Let me zoom in a little bit. Here. Oh gosh, come on. Here is the p-value of the slope of the model. That is the p-value of the slope. I can change this pretty quickly. Here's the p-value of the slope right here. And that is the p-value of the model also. But this is what we care about. Even though this slope has a tiny, tiny coefficient, there is a statistically significant relationship right here. So this is the p-value of the slope, and it tells us that our model is statistically significant. So 2 individuals who differ by 1 pound are expected to differ by 0.0037 GPA points, where the person who weighs more is expected to have a lower GPA. And so it would be 2 people who differ by 100 pounds. So this is interesting a little bit, are expected to differ by 0.37 GPA points, where the person who weighs 100 pounds more is expected to have a lower GPA. So I might say this is practically significant because, and especially if you go to 200 pounds, 2 people who differ by 200 pounds are expected to have, and you times this by 200. So you can go right here and just times this by 200. Two individuals who differ by 200 pounds are expected to have basically 3/4 of a point difference in their GPA, are expected to, where the person who weighs 200 pounds more is expected to have a GPA that is this much lower. R square is kind of low. I don't know. This seems iffy on practical significance. It's definitely statistically significant. Does everyone see this? I can't point this out enough. This is the statistical significance of your model. More specifically of the X, but in the simple linear regression, it's the same thing. So these p-values are the same. You need to know this really well, that this is the significance of your model. No one really cares about the intercept. It's an arbitrary point. When X is equal to 0, we expect Y to equal to this, for when X is equal to 0 on average. Interpreting the intercept is oftentimes illogical, especially in multiple regression. So no one super cares about the intercept. Sorry, intercept. No one cares about you. But this would be the p-value of the intercept. It's got its own interpretation, but it's so rarely ever used. We really care about the XY relationship, and the XY relationship is the intercept or the slope. 20 points first, no, 100 points first person. It's the intercept or the slope. What is the XY relationship? You got intercept, you got slope. What is the XY relationship? Only first person. Who's got it? Which of these is the XY relationship? Slope. Mila right there. You got it. Great work. 20 points everyone else. It's going to be the XY relationship is the slope. Right there. The slope. Yep. So the slope is the XY relationship, and this is the slope. It doesn't say slope. It says the name of the X variable. This says intercept, so pretty clear that that's the intercept. This is the X variable name, and so that is the X variable. That is the X variable. So this right here is weight, at least in the model we were making up, and that's the coefficient of weight. The coefficient of weight is seen right here. This, I can't make this clear enough. This is B1. This is B1. This is B0. We'll talk more about these in a moment. So we have all of those good to go. Let's go back. And so this is going to show us what could happen by random chance right here. And this is really interesting because we're about to see the permutation procedure again. These are all random chance permutations. So this is everything that could happen by random chance. Which of these graphics shows something that is most likely by random chance? Graphic 1, 2, 3, or 4? Which of these graphics show the most likely thing by random chance? By random chance, what lines are most likely? Lines that have a strong slope or line? Yep. Perfect. 20 points, all those answers right there. Let's try to get everyone to 200. You can type the answer. The answer is 3. This is the most likely one by random chance. It has the weakest possible relationship. And I love taking questions out of your slides. Like I could put this on the final. I could say, which of these has the most likely relationship by random chance? And it's the one with the weakest slope because you wouldn't expect X and Y. Now, these all are created by random chance, but number 3 is what is most likely by random chance. So when we look at the sums of squared error, we have to have a comparison. So this is a big thing I was teaching my brother yesterday, is I was explaining to him the difference between the sums of squared error from the naive model and the sums of squared error from your regression model. So Philip, 100 points right there. Thank you for the note in the chat. So the naive model is the mean of Y. This is a huge note you need to have. The naive model is the mean of Y, which assumes that they're independent. Remember, this was the weakest possible relationship we could have. So the weakest possible relationship is that X and Y have no relationship. Does that make sense? They're just completely flat line. It's like 0 slope. That is the weakest possible relationship. And what do we have right here? We're going to find the sums of squares error, and this is often called the total. And this is from the naive model. So you literally take all of these errors, square them, and add them up. So you take all of these squared errors and add them up. Does that make sense? How to get the sums of squared error from these errors? Does everyone understand what I'm doing? I'm showing you like squared errors. We'd add them all up. You'd literally just go and get the square of all these errors and add them up. Does that make sense? The sums of squared error total, put this in the chat, first person gets 1,000 points. I'm serious. Sums of squared error total is found from the naive model's errors. Sums of squared errors total is found from the naive model's error. Sums of squared error total is found from the naive model's errors. Ben right there, 1,000, yep. The sums of squared errors total is found from the naive model's errors. Exactly. That's our starting off point. That's the total error there is. Everyone else, 100 points. Great job. And so now that's the total error that exists possible. It's like, this is like the worst we could do. Like the worst we could do is have this error. Does that make sense? This is the worst we could do. And then here is how we actually do. So these are the same points. You might be like, what's going on here? These points right here are the same points. You notice how right here you've got these 3 points going up, down, up? And then these 3 points right here are the same points over there. But this is the sums of squared error from our model. And look, that has like 0 error, 0 error. This one's got some error when you square it and everything. This one's a very, very tiny error. And right here. So you'd want this number right here to be very, very what? You'd want this number here to be very, very what? What's your goal with this number? You want it to be large or small? What do you want? You want this number here to be large. You want it to be very small. Jordan, 100 points. You're right. You want that to be as small as possible. How small could that be? What is the smallest value that could be? What is the smallest value that could be? The smallest value that could be 0. Jordan, oh, Jordan, great job. Another Jordan, 100 points. 0. Everyone, great job. Everyone answering 0, you got 200 points. I'll try to break some rules here. So the smallest it can be is 0, and you'd get something like this. If it was 0, great job following along these Mega Mondays. If it was 0, it would look like this, and you'd still have the naive model going through here, and this is the mean of y. So it's important to know the notation right here that you'd have all your predicted values, and that's this line right here. Those are the y hats. So you have your predictions, and there's 0 error. Can anyone tell me what r squared would be right now? What is r squared? Extra 100 points on top of your points. First person, what would r squared be for this model? What percent of the variation in y is explained by my model? And y would be the points. Brennan, extra 100 points to Brennan right there. Those are the y's. 100%. Yep. And so this right here is 100% of the variation in y is explained by the model. And so we would get an r squared of 100%. And the worst we could do to do the, well, we already got it showing. What is the r squared of this model? Because look, if we were to say this is the mean of y, this is the mean of y, and then this is our predictions. Yep. And does this make sense that we didn't do any better than the mean of y? We still have the same error. So our model doesn't reduce the sums of squared error. So this is the example where we reduce it 0. We don't reduce it in any way. And then this is the example where we reduce it 100%. And we'll see how that works mathematically here in a second. But this one has an r squared equal to 1. So r squared right here is equal to 1. And then this one right here has an r squared, really? Has an r squared equal to 0. So this one has an r squared equal to 0. And because we reduce it 0, we don't have any reduction in the sums of squared error. So let's take a look at what that means right here. Wait, is r squared the amount you reduce the sum square? It is. It's percent of variation explained, which the variation is the error. And we're trying to explain the error. We're trying to reduce the error. Jordan, 100 points, Jordan. Jordan, I think that puts you at like 400. You keep getting these bonus. Jordan, you were like, wait a minute. Sums of squared errors are like r squared is how much we reduce the sums of squared error, which is our ability to explain the variation. The error is the variation we're trying to explain. Like let's look at the notes again. So if you look, this is the variation, and this is like our reduction. And we'll see this right here mathematically. It's literally saying like, well, this is how you do the p-value. Sure. We'll talk about p-value for a second, then we'll show the next equation. No, I'm going to show the equation. Where's that equation at? Yeah, we'll get to that. Here it is. Here's the equation for r squared. So when you look at this right here, it seems super complicated. This is just the sums of squared error total. I know, I broke all the rules. This is the sums of squared errors total. So this right here is the total sums of squares from the naive. This right here is your model. What do you want your model to have as an error? Everyone repeat, what do you want your model to have as an error? You want your model to have a what as an error? What do you want your model's error to be? What would you love it to be? You want your model's error to be what? 0. You want your model's error to be 0. So if this were to go away, Like imagine this were to go away. This were to be 0. This whole thing becomes 0. What are you left with? You're left with this over this. What if this becomes 0, what does r squared equal? If your model has no error, then r squared would have to equal 1. Because literally this is the same thing as this. This is the total sums of squares over the total. It's from the naive. So it's the percent of variation that you're explaining in the sums of squared error. So you look at how much error there is and how much you reduce the error. So we want the reduction in the error. Does this all make sense? Now, what if your model has just as bad error? What would the top of this equation equal? Like, let's say your model does just as bad as the naive. Like the error your model has is just as bad as the naive. And then the top of the equation would equal 0 because it's like x minus x, and then you divide by something, you'd get 0. It's like this minus this. So if your model did just it, here's what the naive does, and here's the error in your model. This is the error in the naive, this is the error in your model. And if your model does just as bad, then you haven't reduced it in any way. So the top part of this equation is the reduction in the sums of squared error. We're looking at how much we reduce it by, and how much we reduce it by is going to be this right here. So we want to reduce it by as much as it is. Like that's the goal. So hopefully that makes more sense where r squared is coming from. R squared is literally our ability to reduce these sums of squares. And look at the reduction right here. 1,000 points first person, tell me r squared of this model. Serious. I could put this on the test. 1,000 points first person, tell me r squared of this model. 1,000 points first person, tell me r squared of this model. Not 1. The only way it can be 1 is if every point is directly on the line. That's the only way it's 1, is if you explain 100% of the variation. Jordan, I think Jordan got it. Jordan and Ryan, you're so quick. I'm giving it both to Jordan and Ryan. Yes. So Jordan and Ryan were first, so they get the points. And let's show what they did. So we see here the total. And so what I'm going to do is I'm going to take the equation 1, 2, 6, 4. This is the total sums of squares. I'm going to subtract from it this, and that is the top. That's how much we've explained. And then I'm going to divide this by, there we go. And that's the r squared. R squared is 86% of the variation in y has been explained by x, or the variation in x, you can say. 86.23% of the variation in y is explained by the variation in x. And that's how much we reduce the sums of squared error by. It's our reduction in the sums of squared error. Hopefully that makes more sense where it is. In 201, I tell them, we'll go more in depth in 320. So the reduction right here is statistically significant if it's unlikely by random chance. So what do? Permutation procedure. We go in and we create random permutations, which are going to randomly mix up the x's and the y's. Going a little quickly here because it was like our 4th time doing this. And we just mix up our x's and our y's. So any relationship we would see between x and y's now are by what? I can't click the button. In the permutation procedure, any relationship we'd get between x and y is completely by what? Random chance. Random chance. So the permutation procedure has completely random relationships. Like here's our relationship, and here's random chance relationships. And what do we do now? We look at our reduction in the sums of squared error. Here's our reduction. And we look at the ones that happen by random chance. What color is this line in your R output? What color is this line in your R output? What color is this line in your R output? Red, you know what's going on. You know how to look at that. But that's the red line in the R output showing you your results. And then the p-value would be over here. So there's the p-value to the right of it, and apparently it's about 2%. So about 2% of the time you get a result as extreme or more extreme. So we know right here, Carberry will come back one of these days. And we see right here that this result is very unlikely by random chance. This reduction in the sum squared error. What did we say is a very likely reduction by random chance? Like your reduction by random chance is likely to be close to what? Like if you just do random lines, you're likely to get a reduction close to what? And look at the graphic. What random reductions are likely? A reduction that is likely by random chance is often close to what? If the line is just completely random, you expect it to be closer to what value? If it's just random, like we just throw a random line in there. Like we make a random relationship. 0, Austin, 100 points, Austin. Yep. And Casey, 100 points. Casey, great job today. I've seen you come in like second on a few, so you're probably, no, couldn't get some answers here. So I get it right there. Here is our line, and our line is this line right here. It's the red line. And these are all the random chance lines. And here is our line in the reduction, and there's the p-value. And we notice here that this is very unlikely by random chance. The ability for our line to reduce the sums of squared error is unlikely by random chance. You usually get reductions closer to 0, and only about 1% of the time would we get a reduction as large or larger than ours. So it's very unlikely that we would see this reduction, and that's what this explains. How do we know if it's statistically significant? 0.05. 0.05 is when we know if something is statistically significant. So the reduction right here is significant. If it's less than 0.05. We'll talk more about this here soon. We'll talk more what that means. I'll just say what it means. This means that your residuals are normally distributed with a mean of 0 and a constant standard deviation. Constant standard deviation, that's heteroscedasticity. Constant standard deviation, that's heteroscedasticity. You don't want heteroscedasticity, you want homoscedasticity. Mean of 0 is actually the linearity condition, and normality of residuals is what we want. We want our residuals to be normally distributed. So this says your errors in your models are approximately normal, like are well described, by a normal distribution with a mean of 0 and a standard deviation that's constant. So once again, the errors in your model, which are the residuals, are well described by a normal model, so that means the bell-shaped curve, with a mean of 0, that means the line goes through it, and a standard deviation that's constant. We have constant, like equal spread throughout the model. So you want to see a model that's linear and equal spread. And just to show you here really briefly, like how do you know this mean of 0? It means it's linear. Well, the reason is, and I'm going to go to full screen right here. If the model did not have a mean of 0, here's what it would look like. And my brother and I literally saw this yesterday. I was like, I've done way too many stats. So the model my brother and I saw looked something like this. And I immediately said that's got a bend to it. So this is way more points than his model. So if you were to look at the residuals of this model, which could be looked at the following way. The residuals would be at any given point of x, we should see the residuals having a mean of 0. And we don't see that for this model. These residuals are centered around here, and they're not centered around this, which would be 0. And these residuals here are centered around here. I mean, they might be normally distributed, but they don't have a mean of 0. That one might be closer. But the model bends, and the residuals are not centered at 0. Something that has a residual of 0 would be where on this model. If something has a residual of 0, where is it on the model? You draw your model, and if something has a residual of 0, where is it at? If something has a residual of 0, where would it be at? On the line, exactly. Casey, 100 points right there. Great job, Casey. So if something has a residual of 0, it's right there. So what you want is you want the mean of the residuals, which we'll draw with the green again. You want, if you looked at like the residuals over time for this model, you'd want the model to be going through the center of the points, and that's what you want. And then you want equal spread. So this is the constant spread to it. This right here, the spread of this is the sigma. So you want constant spread. These all have the same sigma over time. And so that's what the sigma represents, is that there's a constant spread to it. So there's an equal spread. So all these sigmas are equal. There's the same spread to the residuals at all time. And then the normality, the big N part of it right here is the normally distributed. We see that in green because that's green colored. So this right here is the normally distributed, that those residuals are normally distributed. And then the line is this, and that means that it has a center at 0. So if you look at the coloring right here, we're showing everything. We're showing that the residuals are normally distributed. They're well described by a normal model at all points. They have the same spread at all points, and the line goes through the center of them because all the residuals have a mean of 0. So literally, you have, well, it's QQ, it's straight enough. The 0 represents that. There's no outliers. That kind of helps here. And plot doesn't thicken is well described by this. The only one we really don't talk about in 201, I guess, is the normality of residuals, that they should follow the normal pattern. But hey, that's awesome. And let's hop back to the note. So this is a tricky thing, but it takes a little while just understanding what that equation means. The ANOVA. We don't go too in-depth in an ANOVA on this class, but an ANOVA, when you take a look at it, we've got here, let me just explain. This is something I went over with my brother yesterday too. we have here your x variable. Now, do you want your x to explain things? The answer is yes. You want your x to explain. And no worries about degrees of freedom. We'll talk more about that later, but not today. It's because there's one x. There's one x in the model, that's why. And so the sums of squares right here is what your model explains. Your model will either explain things or it will what? Your model will either explain things or it will what? Your model will either explain things or it will what? Your model will either explain things or it what? Well, this is what your model explains. This is what your model what? Think of complements. Your model either explains things or it what? Think of the complement of explain. Either your model explains something or it... Think of the complement of explain, if you know how complement works, with the one word you can add before it. Because either your model explains it or it does... Because your model will either explain the variation... Let me make this clear again. Here's what my model doesn't explain. Brad right there. 100 points, Brad. Why not? 300-point limit. Or not. Here's what your model explains. Here's what your model does not explain. Does that make sense? And what do I mean by what it explains? This number. That's what your model explains. This is what your model doesn't explain. So which of these numbers do you want to be bigger? The top or the bottom number? Which of these numbers would you like to be bigger? The top or the bottom? The top or the bottom is the one you want to be bigger. Because yep, the top. Because that's what your model explains. The residuals are your error. That's what's left over as the error, like what you did not explain. This right here, these residuals right here, this thing right there, is literally visually this. This number right here in this output is the sums of squared error in the residuals. This is what your model did not explain. Now, you could get the top number by subtracting these numbers, which we did earlier. So you want the sums of squared errors in the residuals, which is visually there, to be closer to 0. So this model has a high R squared or a low R squared. Look at the ratio of the top number to the bottom number. I'm going to put someone to 500 points if you can tell me what the R squared is for this model. Who can tell me what the R squared is for this model? Be thinking this is a great test question. I'd just put this output on the screen and be like, tell me the R squared. That's really easy, something I can do. It's going to have a lower R squared. What will this R squared be? Good try right there. Good try. Who's going to get to 500 points? Who knows what the R squared is for this model? Hint. This is what your model does not explain. This is what your model does explain. And we should probably find the total, which would be the naive. From what I'm estimating in my head, it's not that. I might give it to Brad. He's the only one to guess. Brad, you're at 500. 2 guesses right there. I like it. It's low. It's low. So here's the hints. We need to first find the total variation there is to explain, because either our model explains something or it doesn't explain something. So here's what our model explains. Here's what our model doesn't explain. First find the total, and then figure out what our model explains out of the total. Here's the steps. This is what our model explains. This is what our model doesn't explain. So what it explains, what it doesn't explain. What's the total variation there is? And then what does our model explain out of the total variation? Here's what our model explains. Here's what our model doesn't explain. What's the total variation? Hint, hint, hint. We've got this and this. What's the total variation? And then what does our model explain out of the total? How much variation is explained by our model? Who's got it? I'll repeat the steps again for anyone working along. We have what our model explains. We have what our model doesn't explain. That looks right, Ryan. That looks right. So Ryan added them together and then divided it by this. So Ryan added this and this. So you add these two numbers and then divide 349 by the other one. That looks right. Great job right there. Excellent job. And so that is the R squared. So try working that out. Try to get that number. Check that. That's an amazing test question. I think it's very easy once you know how to do it. Like if you look at this out and you say, okay, well, R squared is the amount of variation my model explains. Nice job. And so this right here, the mean is just when you divide this number by 1. So it's literally just this divided by 1. And then this right here is on average per residual. So all you do is just divide these numbers. So I'll show you real quick. All you do to get the mean sums of squares is take this and divide it by 91. And that's it right there. So if we're been slacking on sending you our points, yeah, email me and add them up. Add them up. Please add them up. I don't know. Thank you to everyone who adds them up. Instead of, it makes my life easier when you add them up for me. Instead, if you send me like a long list and I'll be like, oh no, then I have to add them up. So the F value is also the F ratio. The F ratio right here is just these two numbers divided by each other. So this value right here, I wish I could delete everything a lot quicker, is just these two numbers divided that I've highlighted. This number here is just the ratio. That's why I often call it the F ratio. And so the F ratio, you want to be high or low. Would you like your F ratio to be high or low? Because look, if this is the top number, which is what your model explains on average, and this is the bottom number, which what your model does not explain on average. So remember, this is like what we didn't explain. This is what we do explain. And this is on average what we don't explain. This is on average what we do explain. Yep, you want the F to be higher. And a higher F equates to a lower p-value. The bigger the F, the smaller the p-value. So the higher the F, the smaller the p-value. It's a big thing to know right there. The higher the F, the smaller the p-value. And it literally looks visually, there's more examples, and here's the final output. I think that we're where I want us to get. We're so close. The F ratio is basically this right here. Like this is analogous to what you would see with the F ratio. High F, low p-value. Yep. And then if you were to get a smaller F, and I could show you the F distribution, but it looks kind of pretty much just like that. And let's do this final bit of output. Let's do it. Okay. Let me grab this output and go to the main screen because I'm going to draw on it. Okay. You need to know this full output for the test. Click the button. I have no idea why that took a delay. So let's go right here and take a look at this output. This right here is the equation. That's just your equation. It's just the format of the equation. So you can see here you've got your y, your x, and then data equals data frame. Or I should say code. So let's say this is the code. It's not really your equation, it's your code. It's just the code you wrote. This is a 5-number summary of your residuals. So please note, this is a 5-number sum of residuals. So you can use this to find extreme outliers. So you can identify extreme outliers. You do want this close to 0. So you do want your median close to 0. It's better if that's closer to 0, not the end of the world, but I don't like when that's off from 0. You can look at symmetry of the residuals, but we do have, let's put here outlier. So let's go right here and say outlier and put a question mark next to it, because that's where you can kind of identify some extreme points. And this also here could be a low outlier. Like these are things that don't follow the model, maybe, but these are the most extreme residuals. Does that make sense? Like when you look at your model visually, these points would be the most extreme points. Like they're going to be the things that have the furthest distance from the line, like whatever. Oh, this one right here, that's got the most extreme. So that point up here is the most extreme positive, and this is the most extreme negative. So this would be the min, and this would be the max, that point up there. Does that make sense? What this is showing you, it's showing you a 5-number summary of the values of the residuals. And the values we get reported here at the end, like this and this, are going to be reported right over here. There's the min, there's the max, and there's the 50th percentile of the residuals. Does that make sense? That this is a 5-number summary of the residuals, and it can help us identify the outliers. So we can see, like, this is the most extreme positive residual, this is the most extreme negative residual, because it's the furthest up from the line, furthest down from the line, and you're getting a 5-number summary. Hopefully that's clear enough what this part of the output is showing you right here. Next, we get the following output, and this is where it gets super important. This is where we get to the big stuff. So with this part of the output right here, we get B0 and B1. This is the name of the X variable. Notice I'm writing more carefully right here. These are the things you should know, like this. Who can write the regression equation in the chat for 500 points right now? Go ahead and write the regression equation in the chat, And you probably need to look up here also. Who can write the regression equation in the chat from this? You should be able to do that instantaneously now. 500 points. You get up to 500 on this. It sets you at 500. It's not like an additional 500. Try it. Take a moment right now. These are the big practice things I can easily ask you to do. That once you know how to do it, it gets pretty easy. But you have to be able to do it. Who knows? And this is why I like written tests, because, oh man, I miss the written test now. Because if you know how to do this, you're like, got it. Alex, that's close. 100 points, Alex and Stevenson right there. I'll reverse it though. No one's gotten it yet. No one's gotten the 500. Wait. That is correct, Nicholas. Nicholas got it. Nicholas got the 500. And Sylvia also, I'm giving 500 too, because Sylvia wrote it the way we write it. And both Nicholas and Sylvia are correct. They have it in units. And so so everyone else is getting 100 right here. Maybe you can get up to 300 unless we break the rules, which we broke it for Nicholas and Sylvia right there. Look at what they have written, because we're doing predicted and technically predicted salary. Don't worry, it's fine to write salary. It's still, we would know it's predicted and be like salary had. And look to the way they have it written, that we have B0 and B1, and we have it with the X variable. Make sure to put in context of your X and your Y. So that's very important for the homework. So these are like homework type questions to make sure we have it down and we're practicing right here. Now, the last few things is we have here the standard error. The standard error is your uncertainty. So these are uncertainties. And all we're going to do is let's put these in a box and let's just call them uncertainty. Anytime you see standard error, it stands for uncertainty. So this is your uncertainty in the intercept, and this is your uncertainty in the slope. Does that make sense? What is 80 divided by 20? What is 80 divided by 20? 100 points. What is 80 divided by 20? 80 divided by 20 is what? 4. Yeah, that's it. What is 3,200 divided by 100? 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 Wow, wait a minute. You're telling me that this t value is like a t ratio? That if you take these, like if we look right here, these are literally just estimate divided by standard error. It's a standardized estimate. Does that make sense that all of these values right here are just their estimate? So all you literally do is just divide these numbers. That's all you do to get the t ratio. That's all you do. Just divide the estimate divided by the standard error. That's it. You say this number divided by this number, here's the ratio. So I'll oftentimes call it the t ratio. It's the t value. And it's very much like a z-score. And guess what? The bigger the t, the water, like in absolute value. The bigger the t in absolute value, because t's can be negative, the bigger the t, the water the p-value. The bigger in absolute value the t, the water the p-value. The more extreme the t-value, the more it is away from 0, the water the p-value will be. Just think about z-scores. Because t's are basically z's. More on that tomorrow. Smaller. And we get to the final parts right here. So I'm going to give this full output. We have just enough time for me to do the full output, which will have you perfect for this assignment. So stay tuned. I can do it in 2 minutes. The residual standard error. This is your typical miss the model makes. It's in the notes, but this is typical miss. This is your typical miss the model makes. It's like your uncertainty in the residuals. This is your typical miss the model makes. You know what I'm going to do this thing right here? No one cares about that. I mean, it's not good in business analytics. We just don't interpret it. Multiple R squared. Good question. Someone emailed me about this. Very, very good question. This is just R squared. This one, the next one over here, we'll talk about more later. It's just adjusted and then R squared. So that is an adjusted R squared. I don't want someone looking at this and be like, wait, is that R squared or is this one? This is R squared adjusted. So this is R squared, and then we usually put in the subscript below it, adjusted. So that's the adjusted R squared. That's a different term, and we'll use that in multiple regression. No worries about it now. The F statistic is the ratio of what we observe our model explaining over what we expected. So once again, this is an observed over expected. So we observe it explaining 18.6 times more variation than we would have expected by random chance. The degrees of freedom go into the ANOVA. We looked at that just a moment ago. And here's the p-value of the model. And let's write right here, same as slope. And that's for simple linear regression. And that does it with like 10 seconds to spare. That's the full output. I know this is a lot right here, but you have to walk through it in parts. You have to look at each part of the model and be like, okay, what does this mean? And if you learn this full output right here, you'll understand what's going on and why to look at each part. Like knowing to look for outliers, or knowing what your model's coefficients are, knowing what the t-values are, the p-values, and we should put here that these are the same right here, like this for simple. So let's put here for simple. Am I blocking that? I'm totally blocking that, aren't I? For simple. That's got it. I had 30 seconds, but those will be the same. So for each other, they'll be the same for the simple, but that's the significance of the model. So that thing that I'm partially blocking is the significance of the model. So how do you know if your model's significant? It's the slope for a simple linear regression. Who feels pretty good about this output? Like you think you understand what's going on right here. You know where everything you're looking for. Hopefully this helps. This is a huge key for the assignment, reading this output. So good, awesome. Like this like should get you everything for the assignment. Knowing all this output, good. Yep. So understanding what the whole output means, awesome. Sorry, I wish my handwriting. Like my sister, she has the most amazing like she's always just been like, I don't know, my fiance has amazing handwriting too. I don't know. I've got such horrible handwriting. I used to, growing up, I'd be like, Emily, can you write this for me? Because I can't write. Maybe I should have just like learned how to write. That'd have been a good idea. So a little overwhelming at first, but good. Yeah, it's a lot. Yeah, it's a good refresher of 201. You're right. And hopefully it makes more sense. What do you use to draw? It's a, I can show it off right here. It's a pretty cool tablet. I'll show it off. I'll show you which one it is. It'd be hard to lift up, but where is it? Where's that tablet at? It's a really nice tablet. It's I got it with a grant last year. Yeah, I guess I've gotten 2 grants so far. I'm really lucky. And the amount of usage we've put into it is, it's called, like, I mean, I know what it is, but I just can't find it right now. And I've had multiple people ask me, like, see if I could draw this tablet would be, was it the 13? Where's it at? Where is it at? We'll give it a moment here, try to find it. We're between, oh, here it is, right. It's the Canvas 20. It's not that bad of a price. Here it is right here. So here is the tablet I used to draw. I mean, maybe someone who could really draw could tell you how good this is of a tablet, but it's not too crazy. I mean, you can put a lot of money into stuff, but overall, it's like a different screen. So there's a guy using it right there. So it's really nice. He's got a thing on, but overall, very, very pleased with this tablet right here. And so I've got the pen right here that I'm using. I need to learn more, like how to use the pen and stuff. Yeah, it's a really nice tablet. But it's looks like that pen's nicer. They've updated it. Mine's got I don't know, it's got the clicker thing. You can't even see it from that distance. But there's just like gray or something. I'm pretty sure this is the one I have. It's pretty large, 20-inch screen, so pretty easy to see, and it's my second screen. So then someone's doing like some awesome drawings on this. But yeah, it's really good. Oh, really? That's the resolution on it? Looks like a good monitor. And 60-degree function, 8,192 pen pressures. Yeah, so it's like when I'm drawing on here, it's really nice. Like, I mean, I only use it for Word, but I don't think Word has pen pressure. Oh, Word does have pen pressure. Look at that. I can go like this. I can make use of those 8,000 pen pressures. The things I'm learning. Is there a way to work on RStudio on my desktop and pick up and work somewhere else on my code? Yeah, there's ways to do that, Alex. We need to look into that. That is like version control, I think. Maybe I'm using the right terms, but if you were to have your work uploaded somewhere, put your file in a Google Drive folder. There you go. Yep. Dennis, 100 points, Dennis and Alex, for asking these big questions right here. You know what I'm going to do? I thought it was like 9. I thought it was a crazy time. Here, wait. I'll be back here in 10 minutes. So you guys ask questions. I'll be back. Let me. I feel like I need to continue. And get a haircut between this quick transition. 5 hours. We've almost got these new intros ready. We're almost there.
This has been going for like 20 hours. This ends now.
had him go twice there by accident. I was adjusting around this screen. Oh, because I got to fix the timer. Timer's just being, got to fix all the things. I think we're just like 30 seconds here early, so hopefully no one's joining in right now. But I was going to show you something cool here to start. So this right here, we're on the right one. This is code I wrote literally almost exactly 4 years ago. So this is code I wrote almost to the date. I mean, it's 4 days later. So this is 4 years and 4 days ago. So I wrote this code 4 years and 4 days ago. So this took me like 2 hours to do. And this was after I've been coding for about a year. And I don't like this. I don't like the way this is formatted. I don't like it. And because I was thinking up my own thing right here, I ran into some problems and I was just like making my own thing. And this is actually before I started teaching 474. I started teaching 474 like a year later. And we weren't even like in 320 at this time. We were teaching people how to use coding, but we weren't like stressing it. So this is like earlier on in Brian's coding career. So this took me like 2 hours to do. I remember struggling, it just not working. And I was like, the code's broken. And I just was like, oh my gosh. So guess what I did yesterday to take a break? So I'm the weirdest person in the world because yesterday to take a break, look what the next file is called. I was looking over this file because my grader was like, can you show me an example of the answer? And I was looking at this answer when I was going to send it to them. And I was like, I don't like this. I was like, this is really just a bad way to do it. So I was like, you know what? Why don't I just redo it? And I set a timer. And I think it took me 7 minutes to do this. 7 minutes for something that took me 2 hours. And of course I put it into a function and I formatted my lines the way I like to format. You can literally see the change in my coding style to where nowadays I'm going to do different arguments on different lines. I guess I could technically, sure, if we want to do that, but I don't mind. Oh yeah, sure, why not? I don't know. I could put each argument on its own line. Sure. Okay, we're going to make it look just like this. So each argument's on its own line inside of there, and you can see it takes the data frame, It's just better organized. I like the symmetry of it. It just looks nicer. I like the lengths. But right here, maybe I should have put comments in here. I should have thrown comments and been like, finds Pearson correlation. And then what I'm going to do is I'm going to copy that comment, and I'm going to go right here. I'm going to go to this and say finds Spearman correlation, and then that adds it to the data frame, like adds column with Pearson. Copy that, go here, add this, and this joins the two data frames. So just so people can wonder what they're doing, joins both data frames, sorts them, frames, don't want that, sorts. It just sorts it. That's pretty obvious. Fixes row names, and that function return. But what's really cool, what I'm really proud about is something, it was actually a student who taught me this. It was Tanner. So if anyone knows Tanner, why can't I think of Tanner's last name? If you know Tanner's last name, if you know it, 100 points to you. You might know Tanner, who I'm talking about. Thank you. It was either Tanner or Connor. Was it Connor or Cooper, that's who it was. Tanner or Cooper who showed me this. And what they showed me is inside an RMD, this is the cool thing I want to show you, is that inside an RMD, you can actually have it give you the answers. So this is the word part of an RMD. So I'm going to drop this in the chat right now. So for those who want, that's dropped in the chat. So this is the word part of an RMD. Watch this. When I knit this to an HTML, what's it going to show? Down here at the bottom of the HTML, it actually evaluates and says the strongest correlation is between desired weight and GPA with a correlation of this, and this was a Spearman correlation. So this portion of the code right there, which, we'll put it over here, this portion of the code I've highlighted is actually evaluating when the RMD runs. So this means you could have people upload their data sets and you could just evaluate them like this and then print out a report for them. So you talk about automating reports. Well, it's giving you the answers based on it, and it's inputting those values into your word output. So if you look at the way this code works right here, it uses the backticks, which are very similar to this. Like it's saying, hey, go to the R chunk. It's saying go to your R code and look to the R environment, go to the answers, go to the variable, and go to position 1. So this was something I was like, well, why don't I utilize this instead of trying to write out these sentences like I was doing earlier right here, which kind of come out clunky. They kind of come out Like I didn't like the way they look. I was like, why not just do it there and just have it so when someone evaluates their code, we lost it. Oh, is it over here? Yeah, we saw it. But and I sent this to Dr. Petrie, and he was like, yeah, I look back at the code I've written, he wrote reg class after coding for 15 years, he said. So reg class, which is something we still use in this class, because you'll notice I do the library reg class up here to get the all correlations function. So he wrote reg class after 15 years of coding. And he's like, I look back on that and I see ways I could improve it. Like, I'm like, why did I do it this way? He's like, I could improve this. But you guys know what day it is? You guys know what day it is. We're hopping over to that main screen. Let's get the notes up here. Let's hop over to the main screen. And it's Mega Mondays. Awesome. How's everyone doing this morning? How's everyone doing? I think we actually got to go back to the other screen because we've got to talk about the test a little bit here. Make sure everyone's set on that. How is everyone doing? Am I broadcasting? Good to see you, Andrew. Sometimes I worry when people don't respond. I'm like, oh no, tired. Let's wake up. Let's do this. You respond, now you get 20 points. So let's talk a tiny bit about the test. We just had to see Mega Mondays. So let's talk a little bit about the take home. The take home is not the easiest of things. It's not the hardest of things. With the take home, let's go right here. Let's do this. What you need to do with the take home, cooking breakfast, pancake and eggs and bacon. Oh, Andrew, make us all jealous right there. Let's go look at the instructions for the take home right here. So here's the instructions for the take home. Please read over these. Please read the exam rules. Just don't talk to each other about it. Don't post on the Discord about it. Don't post in any other, like if you have a group meeting or anything like that, don't post in it. Don't ask your mom, like really don't be like, hey mom, I'm stuck on this question. I don't know, maybe your mom knows how to code. But don't ask anybody. The best thing you can do is just kind of, if someone says like, man, that take home is so tough, be like, I don't know, just try not to respond. Just don't talk about it. Like, that's not cheating. If you say like, yeah, it's so tough, that's not cheating, but you just don't want to open the door to the conversation to where they're like, man, number 9 is what's really got me stuck. And you're like, oh yeah, that number 9. And they're like, what did you do? And you're like, I can't say. And they're like, oh, come on. No, just don't, just be like, oh, we can't talk about it. Remember, no talking about it. It just helps to make sure no one's cheating. Do not start posting things anywhere. Do not go to sites like Chegg or Course Hero. Those are the sites you want to avoid. Like if you start looking at results and you start Googling things. Also, you can't go to Stack Overflow. Let me finish that sentence. You can't go to Stack Overflow and post your question. That's what I meant to say. You can go to Stack Overflow. Has anyone been to Stack Overflow? Who's been to Stack Overflow? Let's see some hands in the chat. Who's been to Stack Overflow? Who's ever been to Stack Overflow to like check out how to code something? Anybody? Am I the only one? Yep. How good is it? Yeah, many times. It's really good. Just go. Yeah, it'll show up in your search results whenever you try to figure out all the time. Really good site, but you can't post your question there. Also be careful on, I probably wouldn't be posting stuff there about the exam. I probably wouldn't be like, hey, I'm trying to do this and this, and like look up stuff. You can look up stuff people have already posted. But if you were to see something on Stack Overflow that looked, and please alert me if you see something, you're like, hey, it looks like someone posted this on Stack Overflow. Like tell me, and we just don't want that. And the whole point is you're doing your work on your own. Now, once again, one thing I want to point out is the minimum grade that the class will get is a 75. That doesn't mean we will get a 75, as in we could get higher. So if you're worried about this, if you're like, man, this take home is so tough, if you're putting in a lot of work, if you're working really hard on it, then as long as you're doing the average of the class, you'll get a 75. Now, hopefully you're not doing the average. Hopefully you're doing better. And maybe we might even see grades like an 85, 90 average. Now, be careful though. I do want to say this, is that if you look at the average of the class after I curve it, you might be like, but Brian, the average is a 68. Well, it's probably because of zeros. So I'm not going to, like if someone gets a 0, I'm going to remove them from our data set if someone doesn't do it. So if someone gets a 0, they will be removed from the data set. So that way they don't impact the curve. Because let's say there's 3 students who just say, can't do it. And don't let that be you. If you're listening to this right now, start now. Has anyone started the take home and maybe has a certain percentage of it done? Has anyone started the take home and maybe has a certain percentage of it done? Has anyone started it? We'll remove those outliers because they're not. Yeah. And how are you doing on it? I've started it. Yeah. There's easy questions and then there's tougher questions. 17 problems. Whoa, that's awesome. So if you've got them all correct, you've got an 85, which would be awesome. And you can only go up from an 85. You got 50, I was 54. You got 4 done? Nice. And just take it slowly. And don't worry, Madeline, there's lots of time here. You've got till Friday. So maybe just like today, download it and look at it. Here, I'll even show you some of them in a moment, just so you can be like, okay, there's some easy ones on here. There's some easy ones, and then it's going to get a little more difficult. If you need clarity for any question, please ask me. Read over all these instructions yourself. Make sure. And don't worry, focus on the homework now if you want. I know there's a lot going on this week. Is it grade 50%? 50-50, yep, 50-50. And please don't cheat. Don't. This is where we catch people. Just don't do it. Store your answers. There's many ways to store your answer right here. These are all fine ways to store your answer, just showing you how to store answers. All that right there, we'll store it. Just make sure your answers are stored. There's a thing at the end of the assignment to make sure you've done it. So just make sure it's working. You are uploading your RMD. Make sure it knits. So you need to make sure it knits. This is key right here. You are not uploading your knitted file. You're uploading your RMD, but you need to make sure it knits. That means all your code runs. If something doesn't run, comment it out. Like, I can't make that more clear. Like, you need to comment out code that doesn't work. Submitting your answers, submitting a non-knitted RMD file. Like, I bolded, like, if the entirety of your code does not run, you will receive a 0. So the thing is just knit it, make sure it works. Can I be more clear? Does everyone understand what's going on right here? What are you uploading? I want to see it in the chat. 20 points. What are you uploading? Like, you have to know this. Like, it's bolded. And it's down here. RMD, exactly. So upload your RMD. What does your RMD need to be able to do? Now, you're not doing this and uploading it. You just need to make, not knitted RMD. Just, no, careful. You are only uploading the RMD, and you have to make sure it knits. Does that make sense? Yes, exactly. So you're uploading the RMD, and it needs to be able to knit. It needs to be able to work. Because when I run it, like, your code has to run. If your code doesn't run, comment out the things that don't run. So, and if for some reason everything's just crashing, talk to me. I really can't fix stuff. But, you know, if you're spending 3 hours and you're just like, everything's exploded, I can't really fix it, but I can be like, maybe you should, you know, like, for the exam tomorrow, can cheat sheet be front back? Yep, cheat sheet front back written. The exam will come out, I think tomorrow morning at least. Yeah. Whew. Man, it's a busy week. Don't worry, I spent this whole weekend working, so I feel it. Don't worry, we're working hard. We got this. Like, you guys, and that's why I took Market Basket off of it, giving you a little bit less to worry about. I was like, let's make the exam a little bit less material. So Market Basket is on the final. What time is the exam? It's all day Tuesday and Wednesday till 2 p.m. All day Tuesday, Wednesday till 2 p.m. And I'll do the Kahoot tomorrow. So is there a specific time period that the exam is available, or is it during class? It is available all day Tuesday and Wednesday till 2 p.m. All day Tuesday, Wednesday till 2 p.m. I think we are good to go on that. So the steps for getting 2 p.m. Eastern. Yep, Knoxville time. Yep, no, good question, Peyton. 20 points to Peyton. Very important to know, like, if you're in Nashville, it'll be 1 p.m. Is there going to be coding problems on the test? Yes. There'll be, like, true, false. There'll be numeric entry. Has anyone taken the practice test? Take home is due Friday night, 11:59 p.m. Has anyone taken the practice test yet and looked at the problems on it? Because the practice test does have problems that'll be on your midterm. And so you did. Yep. So by doing that, you're seeing, and I might try to put out another practice one. It's just, man, sometimes, like, I look and I'm like, man, it was 1 p.m. a moment ago and now it's 6 p.m. And then I look up again and I'm like, it's 10 p.m. And I'm like, where did the day go? I did take Discord questions. So look at those Discord questions. And who's been posting? Someone's been posting a lot of them. I think it's Alex. So I'm trying to like, there is definitely some Discord questions. So if you look over the Discord questions, you know how to solve them. You know what's going on. Practice exam should be under quizzes, right? So if you go to quizzes, you should get the practice exam. We'll probably do a lab, and remember, we'll do it again in class. So I'll probably try to do another lab. We might skip some of these labs, so I'll probably change the numbers. So we will probably do maybe 1, maybe 2 labs. Remember, I always do them in class, so you get to see the answers. So by coming to class, you just get the answers to those. So if you're coming to class, you'll get the answers to the lab, and you don't have to worry about that. So remember, coming to class every day, you don't have to worry about the labs. Do you recommend the prac? Yeah, they're all right. It's switching to only online exams. I do think they're good to look over. But like an online exam's gonna be different. That's why I put out the practice exam, because I wanted you to have an example. And then it's very valuable to do it because the practice exam does have questions that are on the actual exam. So I want you to have a better idea of like what exactly is going to be on there and how it's going to look. And the practice exam looks a lot like the actual exam. A few last things about that. Do not, I know this sounds crazy, but don't talk during the exam, because like, here's how people could cheat. They could have their phone recording them in their pocket. So we don't ask you to like empty your pockets and like, I mean, we could, but then someone could like, I don't know, tape their phone under their desk. I mean, you think about all these ways you could cheat. I mean, I could literally tape my phone under my desk and have it recording, and that could be like, 2 equals 2. Is that true or false? I think that's true. So I could be like saying the answers and recording it, and I could just go back and write down everything I record. And I could like send it to friends and be like, hey, I took the exam earlier today. Try not to talk to yourself. Like, please don't. Like, I know that sounds crazy, but pretend you are in a big, I know, right? So, because we can't tell the difference. If you talk to yourself and you're like, oh, what's the answer? Like, one, try not to do that. But two, I'm not gonna be like, you cheated because you said I don't know what the answer is. Oh, or if you're like, like, I know, don't worry. Multiple people have emailed me and said, I'm talking to the friends of my cracking me up, Madeline. So try not to. I know, don't worry, I understand. I realize, like, I don't think people are cheating. It's really tough because a lot of people do things that aren't cheating, but we're very, like, there's a lot of ways to cheat with online exams, and we're very aware of them. And before, in another language, and told the teacher that they were just talking to themselves, but really they were saying the answers to their friends in the room. Teacher was oblivious. Yeah, that's the thing. And Alan's totally right. And there's other ways to cheat that we're trying to guard for too. And I'm currently on a task force in the Haslam College of Business. And, we try to stay up to date on the way that people cheat on online exams. And the problem is, it's like, people come up with new ways, and we try to come up with new ways to stop them. And I'm sorry for those. But the thing is, if you literally are taking the exam and you're like, oh, what's the answer? And you're like, oh no, I just spoke. I'm not going to get you in big trouble for that. Don't worry about that. If you say, what's the answer? Or, what's this? You're not going to get in big trouble. If you're definitely, I know some Spanish. I'm not saying speak in Spanish, but like if someone speaks French, if they're like, j'attends mon petit chou, I'm like, you love your little cabbage? That's about all I know in French. But I'd be more, I don't know, if someone's speaking Spanish, I'd have a hard, I don't know. I wonder what percent of it I know. But try not to speak, because it makes it easier for me to know that you're not cheating. I was trying to say if you're speaking Spanish, I would know you're not cheating, but I don't know how well I could translate. I'd like to see how well I could do at that. I don't know. I used to be decent at Spanish, and now I'm probably pretty bad. French, I'd have no idea. German, I'd have no idea. But Spanish, I might have a small clue. But don't do it. Just don't talk. Don't talk during the exam. Other things. If there's an emergency, like, let's say there's a loud crash and you hear your dog start barking or something like that, please say it during the test. Be like, I have to go investigate this emergency. And then after the exam, immediately email me. So please tell me what happened, and tell me, like, I have to go. There was a loud crash and I need to figure out what happened. You can say it like a normal person, be like, there was a loud crash, Brian. I got to go check that out. But try not to leave. Try not to do that. That's like, if all of a sudden your fire alarm starts going off and it's like, beep, 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 and there's smoke coming in the room, I don't expect you to be like finishing the exam and being like, submit. Like, please, I understand things that happen. Does that make sense to everybody? Like, don't leave the room. Don't leave the room. If something crazy happens, please tell me and leave the room. But don't leave the room. Do not endanger your life while taking this exam. It's not worth it. We have the video of it, so we can tell, like, if smoke started coming into your room. Don't make smoke come in your room. Is there a time limit on the exam? Yeah, I think it's 2 hours. I'll put 2 hours on it, which is more than enough time. It'll be 2 hours. 2 hours. Wait, here we go. Any other last questions about the exam? Fuck machine. I know, right? Somebody does that. They've got like a button under their desk. So like if they're doing poorly on the exam, smoke just starts billowing in. You see them just like looking over their shoulder. Like they hit the button and they're just like, they're looking to see. I expect there to be about 50 questions. Still class tomorrow. Yep. Class tomorrow. Class tomorrow. Yep. And any other questions? 50 questions, 2 hours. What's the best review for the conceptual part, like lectures, Discord, everything right there? I'd say lectures are probably best. I'd go lectures, slides, homework, Discord. We need to build up the Discord more. So go to the Discord right now. Go to the Discord. I tried to answer some questions last night. Feel free to email me and put potential test questions. I'll try to go to the Discord more. I know I play a role in that. No pen. You're not allowed to have pen or paper. You'll do everything on the calculator on the screen. So to use the practice test so you know how the calculator works. So if you're worried about using the calculator, use the practice test calculator. Does that make sense? Use the practice test calculator. A lot of the calculations on this can be done in your head though. A lot of the calculations on this exam can be done in your head, and the practice test shows that. There's not really tough, I don't know, I might put in tougher ones, but I think everything I've written so far can be done in your head. And I'm not saying like, what is 5,822 divided by 19? Like that can technically be done in your head, but everything I've written is like, what is 8 divided by 2? Like it's a lot easier. Like it's like 8 divided by 2 is 4. Like we'd expect you to have these mental math abilities. So any other last questions? Just make sure during the test not to be writing stuff down. Like you can't have pen out. You can have your review sheet, your cheat sheet, but you can't have pen to write stuff down. So I think that's got it. Any other last questions about the test? We'll pull up the take home right here. So here's the steps for making the take home. There's 3 steps. And so to do the take home, both sides, you can do both sides, front back take home, front back cheat sheet, and it can be written or typed. Cheat sheet, front back, written or typed. Good question there, Carly, 20 points. Great question. And let's do this. Okay, so I've downloaded the file. Here, I'll do it again just so you can see. So you download this file right here. And once you've downloaded that file, you'll go over here to the global environment. And what we're going to do is we're going to clear the global environment. We're going to clear this out. I'm just going to like restart R. I'm going to go here. I'm going to delete that. And I'm going to get everything cleared. Now I'm going to go here to the load stuff for the global environment. I'm going to go to where I downloaded the file, go to downloads, and here it is right here. That's the second time. Here's the first time I did it. Okay, this takes a moment to load. It's a rather large file, and don't worry about that. Warning load, sure, fun stuff. And here is what it loaded in. That's a huge data frame. Now we got video games. We got video games on our computer now. What we're going to do is we're going to go to make my exam, and you'll enter in your number. So 234, 234, 234, sure. That's not your number. Don't enter in that number. Now it made this file right here on my computer. So I'm going to go exam 234, and here's the file. Now save this file as something else, but this is exam 234, 234, 234. Now be careful. If you run this code again right here, you will overwrite your exam. So I would save this as something like midterm exam. Now do not change this either, because this is what makes your exam. So do not change anything in here. This is what makes your exam. Does that make sense to everybody? This is what makes your exam. Do not change this. Change this. Go to File, Save As, and change the name of this file. And this is your custom exam. This is your custom exam. When you are saving your answers, make sure to do it as we say right here. Make sure to be saving it into answers. To automate the grading. Yep. That's the thing, is that I can generate the answer keys, and you're right. So I can check and easily look at who's got stuff right. So this should be easier to grade, and I've got to make some changes to it. So that'll be fun. If you look, here's your answers. So there's the spots in the answers right there. How long does that take to code? This right? Oh, this. I'm going off of some stuff we have, but I was spending, oh man. I spent like 10, 12 hours this weekend, and I was going off of, I used some stuff we previously have, but I mean, a lot of time has been put into this. Like, you can actually look at the function yourself if you want. If you go here and run this, that should do it. No, I always forget. It needs this. There we go. Here is the function. Darn it. There we go. Here is the function. And here it is right there. There's the function. So here is the function with everything in it, and this is what creates your exam. Now, this is not what you're doing. If you get to this, don't, I mean, you can look at it if you want, but this is the function that creates everything you're seeing. There's a bunch of blank lines, but still everything right here. You get the R chunks being inserted and all this stuff right here, but this is how everything is created. So you can take a look. You can see what's going on. You can see how the messages are being output, the R chunks and all this stuff right here. And yeah, I think it's pretty awesome, and just worked on it, got everything ready to go. And you can see the different values. So you can look behind the scenes at this. Random uniform numbers being created right here. So some of the lines of code are not that complicated. If you look at what's going on here with profit tests, like what's being created in it for the matrix and all these values. And so yeah, that I think is pretty cool. Any questions about the take home and what all is in it and how it all works and what you'll be doing as you go through here and work every single problem? There's a lot. Start early. Once again, some of the problems here at the very start. Let's look at the very first problem. It's putting in the rows and columns. So left arrow into Q1, element of answers of length 2. So we need a vector element stored into Q1, whose first element is the number of rows, and whose second element is the number of columns in game. And game is already created when you run it right here. How long does this one take to code? You can answer questions when I don't say the code for this, obviously. Don't say how to do it either. But how long does this one take to code? Who thinks they could code this, and how quickly could you code this one? Where it says store into answers Q1 a vector of length 2, 15 seconds, yeah. If you know how to do this and you're like, wait, I know how to do this, you're like, oh, it's about as quick as you can type it. And it's not that, 20 seconds. So there are some ones on here, especially even the later ones that are really complicated. The amount of time it takes to write the code is like 1 minute, but you have to figure out what to do is the harder part. So the knowing, like generating the code is the harder part. Once again, the lowest possible grade on this will be a 75 for the whole class. So do not freak out if you get to some questions and you're like, I'm completely stumped. If there's two or three questions which have you stumped, don't worry. If there's 3 to 6 questions that have you stumped, or 4 to 6, be a little worried. If there's 7 to 10 questions that have you stumped, be concerned. Does that make sense? Like it's like 3, 7, and 10 are your guidelines. Like 3 is like, if 3 questions you're like, I'm really stumped on, you're probably doing all right. If 7 you're really stumped on, you might be around the C range. If there's 10 you're stumped on, that's where you're like, that's, you're behind a little bit, and it's gonna, it's tough. But who is pretty far? You can answer the questions I ask about the take home. Once again, it's like, don't talk about the take home unless Brian's asking you questions. Who's pretty far on the take home, and how much time have you put into it? Who's pretty far on the take home? Has anyone looked at it a good bit? And we'll hop back to the notes right here. I'm gonna hop back to the main screen. Or who here has even attempted it, and how much time have you put into it? You can say, I've spent this much time and I'm this many questions through. You're allowed to answer these questions when I ask. You can't just, you can't randomly say to people, like, yeah, like this is when Brian, anyone? About almost half spend a few hours. There you go. Like 3 hours, Andrew. So 4 hours was what I estimated, but it might be 5 or 6. It depends. I've done a third and it took me like an hour. Yeah. And that might be the, 3-ish. Good. Yeah, and realize that there are some tougher ones. I've just looked at it. Good. Get it open, download it, make sure you have it going. I spent about 20 minutes and I've done a quarter. Nice job. Yeah. There's some easier ones. Like you might have done, that's the thing, you might have done the easy quarter. So always Market Basket going to be on, nope. Market Basket's on the final, not on the exam tomorrow. Market Basket's going to be on the final. Good question, Madeline. So I think that's got it. I think we know what's going on with the exam. And we are good to go. Oh, it was. I like her there. You're like, yeah, it was easy. It was the easy quarter. And now I'm like, okay, easy quarter done. So do that. Knock out the easy quarter and then start looking at each problem individually and being like, okay, come up with a strategy. Be like, what's it asking? You can ask me for clarification. You can be like, what exactly? I can rephrase it. So remember, you can say, hey, Brian, what's this asking? What are we looking for here? And I can rephrase questions. I can be like, well, like if I had to rephrase that first, I'd be like, well, you want 2 things. You want the rows and you want the columns. You're going to join them into a vector. We're going to go over Market Basket today. Yep. And then tomorrow we'll have Kahoot and review tomorrow. So I think we can finish Market Basket today. Yay! Finish Market Basket. Let's do it. And then tomorrow will be Kahoot and review. Kahoot later in the day. You guys ready? Guys and gals ready? I want like a second Red Bull, but I'm limiting myself to 1 Red Bull a day. I had my coconut Red Bull this morning. It's gone. Let's do this. Let's do some market basket analysis on these Mega Mondays. You ready? Mega Man's there's Mega Man. Sometimes he's just like, he doesn't want to appear. He doesn't want to appear on Mega Mondays. Let's do this. Okay. So with market basket analysis, what's the point? Like the biggest thing, Jinning and Adam right there, 20 points. So the biggest thing right here with market basket analysis is like, why are we doing it? The whole point of market basket analysis is to make rules. And what are rules? It's telling us how one product influences another product. And this could be literal like grocery store products people are buying. Like literally if you buy cheese, you're more likely to buy bread. And just think about a rule you could create at a grocery store. 100 points first, 3 people to give me rules. This influences this. Like this influences this. You could even come up with rules like buying name brand milk influences buying grocery store milk. That would have a lift below 1 because if somebody buys name brand milk like Mayfield milk, maybe they make milk. If someone buys Mayfield milk, they're less likely to buy your store brand milk. So that's a lift below 1 because people who have name brand milk in their cart are going to be less likely to have store brand milk in their cart. So that's where you see a lift that goes down, where people are less likely to buy a product because they have another product. Price influence. Well, that would be like a correlation between, think about products. But this is what market basket. And I'm glad we asked this question now. Market basket analysis is a transactional data frame, where it's like people who watch Minority Report are more likely to watch Mission Impossible. So this is what we're getting at right here. Is like when you take items and you say, if somebody does this, they're more likely to do this. And it can be like, if somebody buys, like we saw the Frenchie example on Amazon, if somebody buys Frenchie socks, they'd be more likely to buy the Frenchie, salt shaker. So that's why they're marketing to them. One item influences another item. Yeah. And so 100 points, all those attempts. What would be a market basket analysis that you could get if you're doing market basket analysis right here? Buying peanut butter flute, boom, Jordan, boom. So peanut butter is going to, if someone buys peanut butter, they're more likely to buy jelly. So think about this. Do they send you a coupon for peanut butter and a coupon for jelly? Do they do that? Do they send you a coupon for peanut butter and a coupon for jelly? People who buy milk are more likely to buy cereal, more likely to buy milk. Yep. Buying salsa influences buying chips. Yep. So they could send you coupons for the salsa because who eats salsa by itself? I mean, you can use salsa on like tacos and stuff like that. I just want tacos. So you can buy, I think Madeline, you get 200 right there because I really like that because you'd probably send people coupons for salsa because then they need something to put that salsa on. And you know what? I think about all this. I think I've gotten salsa coupons because salsa is not an item you buy by itself. A nice bowl of, he's like, just a bowl of plain salsa. Ooh, it's hot salsa. This is good. I'm going to eat this salsa with a spoon. I mean, I've had some good salsa before, but yeah, it just sounds weird. So an item like salsa is a perfect item to give people a coupon for because you're going to sell another item. Like you're highly likely to have someone buy something for that salsa. So someone will be like, oh, I need to buy this because I bought this. That's what lift is, that if you sell the salsa, you will increase the probability of buying this. The problem is there's so many combinations of ways in which people can buy things. If we have 10,000 items in our grocery store, which, maybe we're Walmart or something like that, so we got 10,000 items. And then if we look at the pairs in which ways people can buy the items, there'd be 50 million pairs. If you look at the ways people can buy 3 items, there'd be this. But do people just buy 2, 3, 4 items in their cart? Think about this. If someone walks into Walmart and Walmart has 10,000 items, how many items do you think people usually buy? How many items do people usually buy if they walk into Walmart and Walmart has if Walmart has 10 items, if Walmart has 10,000 items, they buy 10 at least. So you go choose and we go 10 out of, this is how many. And so 10 is probably just going to give me, oh, great. Here's the amount right here, as in, I'm going to make a mistake here. 2, 7, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. There you go. I think that's about right. This is how many combinations you can buy 10 items at Walmart. Just to make that clear, if you buy 10 items at Walmart, this is the unique ways you could buy all 10 items. And I didn't carry everything, but whatever that is, that's the unique ways. And if you do 15, it's like going to break ours. It's going to be like, really? and it didn't break it, but it's ridiculous. That's the unique amount of ways you could buy 15 items given 10,000 items are your choices. Does everyone understand what this code is telling us? It's telling us the unique ways. And to look at it very simply, if there's 5 items, how many unique ways can you buy 1 item? If there's 5 items, how many unique ways can you buy 5 of those items? 1 of those items, excuse me. If there's 5 items, 5 ways, yep, because you could buy item 1, 2, 3, 4, or 5. There's 5 ways. If there's 5 items, how many unique ways could you buy 0 of the items? So you walk into Walmart, there's 5 items. How many ways can you buy 0 of them? So think about this. You walk into Walmart, there's 5 items. How many ways can you buy 0 of them? 20 points. Yep. There's 1 way because there's only 1 way to buy no items. There's 5 items. How many unique ways can you buy all 5? There's 5 items. How many unique ways? And the answer again is 1. There's 5 items. How many unique ways can you buy 4 of them? Well, this would mean you can't repeat. That's a great question. Vajrana, 100 points right there. Doesn't count for repeating. Wow. That would make the problem even bigger. Like maybe trying to sell an item twice. Like you could look at this as like you want to sell 2 of this item. And I don't think I've ever considered that. Like that's a well-earned 100 points because I've never considered that about this problem. Because you could it would literally grow this to 10 because you could say, what's the probability, like how would this influence someone buying the product twice at our store, which would be them having 2 of it in their cart. Ooh, you know what? I wish someone was here from Dun Humvee because I bet they have a way of doing this with the code. Like I bet they have a way of looking at lift, like for repeat items. Probably what you would do is you would code in a second one of it. So you'd have someone buying like Lucky Charms, and then you'd have someone buying a second box of Lucky Charms. And then you'd look at the lift of Lucky Charms 1 box to Lucky Charms 2 box. And obviously I think there'd be a big positive lift. And then you look at what items are most sold in duplicates, like what item buying it most likely increases the probability of buying a second one. So what items have the highest duplicate lift? That's a really, I bet you Dun Humvee looks at stuff like that. And they're like, what items are bought in like multiples? Probably like maybe cheese. I don't know. I think of what items I buy like 2 of. I buy like 2 blocks of cheese. Like cut the cheese, put it on Triscuits. Cheese and Triscuits, so good. Who's with me on that cheese and Triscuits? I want to see that cheese and Triscuits in the chat. Who's with me? Cheese and Triscuits, sharp cheddar, Triscuits. You know what I'm talking about. And like that, what is so many good Triscuits. Triscuits, like you got it right there. Cheese and Triscuits. So we go right here. I love it. It's the bond. You guys are awesome in the chat. Love it. So and think about that. If you sell Triscuits, you're probably going to sell some cheese with it. So maybe and you know what? A lot of times Triscuits are like buy one, get one at Publix. A lot of times Triscuits have a sale on them and then the cheese doesn't. So they're doing it. They know I want to buy those Triscuits and they know I need something with those Triscuits. And then if I buy more Triscuits, I buy more cheese. So they're doing it to me. They're doing the market basket analysis maybe. So these key terms are very important. Lift is when we notice that one product, it's the ratio increase. Now listen carefully to this. Lift is the ratio increase. 20 points right there for tomato and basil Triscuits. Lift is the ratio increase or technically decrease between 2 products. So when a product has lift, like cheese and Triscuits would have a positive lift. And think about this. If I told you the lift between cheese and Triscuits these are great test questions. Someone has a 20% probability of buying sharp cheddar cheese. It's probably, okay, someone has a 5% probability of buying sharp cheddar cheese. But the lift is 10 if they buy Triscuits. So let's write this in the chat. You ready? Here, I'm going to put in the chat. The lift is 10. And the probability, which is the support for cheddar, is equal to 5%. What is the confidence for cheddar given Triscuits? How do you spell Triscuits? What is the confidence for cheddar given Triscuits? What is the confidence for cheddar given? So cheddar has a support, which is the original probability. And this is support of the rule right here, but it can be also support of cheddar. So cheddar has an original probability of 5%. If someone buys Triscuits, the lift is 10%. What is the confidence? What is the confidence in somebody buying cheddar given they have Triscuits? So what is the confidence? There's silence. 100-point question. Who knows? I get afraid when there's silence. I'm like, yes, Yao Ji, you're totally right. It's 50%. So that's what lift means. It means how much we raise the original probabilities. Does that make sense? It like lifts it up by a factor of that. And you could say the probability of somebody buying, imagine this, the probability of somebody buying grocery store milk, so let's say milk grocery store, I wish I could do subscript, is 5%. Oh no, let's do 20%. So the probability of someone buying milk from our grocery store brand is 20%. And then the lift is going to be this right here. Here's the lift. If somebody buys name brand milk, so this would be like name brand and then grocery brand. So the lift is, so if somebody buys name brand, the lift is 0.05. And I think I did that right. Yeah, I did that right. So what is the probability of somebody buying grocery brand given they buy name brand? So some people, 20% of our customers buy grocery brand milk, our Publix brand milk, but the lift is 0.05. So what is the probability somebody buys grocery store brand milk given they have name brand milk in their cart? Which would be the confidence, like how confident we are that they will have it. 1%, yep. I was working in my head. I was like, what would 1% of that be? So you notice the lift here is below 1, saying that it would decrease the probability. So just think about this logically. If somebody buys name brand milk, they open up, they buy the name brand milk, they're going to be less likely, that's why the lift is below 1, to buy grocery store milk. And so we'd say there's a 1% probability given they have name brand milk in their cart that they would buy grocery store brand milk. So it would decrease the probability. That's what a lift below 1 means, is with the information of what they have in their cart, the probability of Y decreases. Now support, we have to be very careful on what this means. So with support is used in two ways. There's the support of the item and the support of the rule. The support of the rule is the amount of time everything in the rule is in the cart, which this slide says. The support of the item is also known as the item frequency. Support of item equals item frequency. 20 points in the chat. Support of item equals item frequency. 20 points in the chat. Who's got it? Everyone start writing it. Support of item equals item frequency. Support of rule is how often the rule. Support of item is item frequency. Yep. And support of the rule is how often everything in the rule is bought. So you would see a rule like name brand, grocery brand have very low support, but the support of the item like name brand is how often people buy name brand milk. So very important. This is where people often get confused, is because there's two different supports. Support of the rule, how often everything in the rule is bought. Madeline right there, 20 points. And then support of the item is how often that one item is bought. So be careful. It's like, are you talking about the support of the rule? Or are you talking about the support of the item? Very, very important right there. So we see right here just the mathematics that I was having you do. So I don't like to read the slides. A lot going on right here. It basically walks you through the examples, showing you how the confidence is done. And we're going to see a little bit more on the mathematics. But this shows you right here, the probability of A and B in the cart is the probability of A given B times the probability of B, which is equal to the probability of B given A times the probability of A, where the probability, it's conditional probability, the probability of finding A in the cart conditioned on the fact that the shopper has B. So it's probability of A given someone has B in their cart, right here, probability of A given B. If you hear thudding, I think it's my neighbor below me. Sorry, I hear it out of the corner of my ears. So there we go backwards. So here it is, probability of A and B. And this right here is just the naive probability. So I want us to think about this for a moment on this. The probability of A and B right here is with no additional information. This is just independent probabilities. So what this finds right here, if you think back to 201, and I always like to say like, wait, we learned this in 201. This is picked by random, because what are we assuming to multiply two things together? If you took 201 recently, you remember that when we multiply two things together to get the probabilities, we are merely saying, what's the probability by random chance, or they're independent. So we have the independence assumption when we multiply things together. So when we look at the equation coming up here, this is the big thing. What we have right here is the lift is the amount of time we see A and B in the cart, like the actual amount of time we see A and B in the cart via what we would have expected via random chance. Does this make sense? Like the top part of the equation is how often do we actually see A and B in the cart? And the bottom is how much would we have expected it to be by random chance? And so when lift is equal to 1, the amount of time we see it is equal to what? When lift is equal to 1, the amount of time we see it in the cart is equal to what? Like this is what we see it in the cart. This is by random chance. When lift is equal to 1, then the amount of time we saw in the cart was what we would have whatted by what? It goes back to classic statistics. When lift is equal to 1, well, it would be equal to the amount we would have expected due to, I missed the button. So when lift is equal to 1, the amount of time we observed in the cart, because that's that, is merely equal to the amount of time we would have what? Would have simply expected. Man, I missed the button. It's equal to what we expect, yeah. What we would expect by random chance. So, yeah, well, you got it. Great job. 100 points, answers right there. Great job going on a limb on Sarah, Ahmed, and Madeline. It's what and there's 200 points max today, so you guys are getting up there already with that. But I really like it when people are like taking a shot at it. Anisha also. Same as yep, that's it. Anisha, you're exactly right. It's the same as the independent probability because when lift is equal to 1, we're saying, well, this is kind of what we would have expected given their independent, which is the bottom of the equation. This is the mathematics with independence. This is what we actually observe. So this equation is literally observed over expected. It's what we observe happening, and it's what we would have expected happening by random chance. And that's the lift right there. It's once you realize what the equation is showing you and you put it into words, it's like how often are A and B actually in the cart together? And then right here is how often would we expect them by random chance? So it's a ratio. And it's showing us how much more or less we would see them by random chance. And yeah, I like that equation a lot. And here's the mathematics behind it, walking through what everything means, just lots on the slide. So lift right here, just more ways of calculating it. We'll talk through the slides here in a moment. Once again, showing you the mathematics behind it. So good slide right there, but we're going to talk more through this. The probability of finding y in the cart goes from this to this. So this is what lift is. When you look what lift is right here, if lift is 16, what does a lift of 16 mean? It means we would have expected these two things in the cart 1.5% of the time by random chance. So by random chance, we would expect these things to be in the cart together this much, but the lift is 16, so we are now going to see them this percent of the time. So this is how often we see them together in the cart. This is how often they are actually together, and we would have expected them together this amount, but we're doing it 16 times that. So the ratio of how much we would have expected to see them to how much they're actually observed. So this is probability of A and B, and this is the probability of A times B. So this is the bottom part of the equation. So literally you could reverse this. You go right here and go 24 divided by 1.5, and you get 16. So knowing how to reverse it and find the lift. So what is the equation for lift? It's what over what? Let's wake you guys up. 1,000 points first person. What is the equation for lift? What is... That's what I asked. What's the equation for lift? I just solved it right now. Let me solve it again. What is the equation for lift? Pretty much. And should it be? I think so, right? Because it's the... Yep, because the... Well, it's going to be... Yes, Vajrana is correct. 100% Vajrana is correct. Because it's the equation for lift is the original probability divided by... Exactly. So Vajrana is 100%. What is it? The other... Vajrana is 100% correct. It is the confidence, which is the new probability, divided by the support, which is the original probability. It's the ratio of how much the original probability increases. And so that's what we're seeing right here is the ratio of the increase to the original probability, 100%. I had to double check in my head right there. Nice job. Well earned, 1,000. Quick answer right there. Try to wake you guys up with that. 100 points, everyone else. Probably getting you close to that 200 right there. Limit for today, unless we break the rules, which we just did. So... imagine the probability of having an item is 50%. The maximum value, there you go. So this is a really, man, I think about questions that are just so easy to ask. If I were to say 50% of our customers buy a certain item, what is the maximum lift? 50% of our customers buy a certain item. The maximum lift would be 2 because you can only get 100% of your customers to buy an item. Does everyone understand this theoretically, that if 50% of our customers are buying a certain item right now, we can only get a lift of 2 because you can only have 100% of your customers buy the item. So that should be pretty clear that if originally 50% of our customers buy it, we could only have a lift of 2. What is the maximum lift? If support for an item is 20%, what's the maximum lift? 100 points first person. If support for an item is 20%, what's the maximum lift? What's the maximum lift? There's no lower bound to lift. If support for an item is 20%, what's the maximum lift? 5. 100 points right there, Ahmed. Great job. Yep. Because you can only multiply that by 5 to get 100%. So if you were to figure out maximum lift, I guess it would be 1.0 divided by support equals maximum lift. Very similar. And the one we did in the previous homework, Jordan, was for missingness, to tell us if things were missing. Like, how does A missing, like how does this value missing impact this value missing? So it's very, very similar. And so be careful, because this is now market basket, like people are going into a store buying stuff. So it's a little bit different, but very, very similar. So be very, very careful, because it'll get a little trickier. Like, wait a minute, missingness in the data frame, or is this going to be market basket analysis? What's the difference between confidence divided by Zort and observed divided by expected? Pretty much just this will figure it out for you. We don't have to do this way of doing it. So this is the way of doing it right here. But once again, we're often going to just do confidence divided by support. So we don't have to worry about figuring it out this way. Don't worry, this is the way it's figured out in the background. And then we are just going to do the confidence divided by the support of the item. So we can look at the increase right here, and we would say what would happen. If you notice, there's other ways of doing it. This right here, there's multiple ways. The one you mentioned right there, confidence divided by support, is going to be this right here. This is confidence divided by support, because it's still equal to this. Here's the support for product A. So hopefully, great question, Sarah. I'm throwing you 100 points because I feel like that is a little bit confusing. So here's the support of A, which is just the probability of people buying A. And then here's the confidence, the probability someone buys A given they have B. Does that make sense, that this is the confidence and this is the support? Now, this is another way to calculate lift over here. There's multiple ways, but you can easily calculate it, which this is the way we'll more conveniently do. Sarah, that's worth 1,000. That's really a good clarification. And this slide points it out, that this is the confidence right here, which is the probability someone buys A given they have B. That's confidence. And then this is the support of A, which is just the probability of someone buying A. Really great question. And you could, same thing right there, you could reverse it. Will the global environment be affected if we switch back and forth between homework assignments and take-homes? No, you can have everything loaded up. If you feel like there's a problem, please tell me, but it should have everything loaded up. And the good news is on the test, I often just go for this way right here that I did. So I try to point to test questions while I'm doing this. Like, I try to be like, this is how I could ask it on the test. I try to make the calculations pretty easy if you know how to do it. Like, if I'm like, the confidence of the item is this, the support of the item is this. So, or the confidence of the rule technically. So good questions, amazing questions today. So in general, the maximum value of lift involving A is that. There's the equation I just put in the chat. Lift sum small is interesting sometimes, because you can get a lift that is very small, but imagine if we have something we sell to nearly all of our customers, like milk. If we just look at any brand of milk and we want to get 100% of our customers to buy milk, well then, if we have 90% of our customers buying milk, we can only achieve a lift of 1.11111 repeating, because the maximum amount of our customers to buy milk would be 100%. So the maximum lift right here, once again, you could compute this. It's 1.111 repeating, but you could go 1 divided by 0.90, and that's the maximum lift you can achieve. Now, why is this interesting? You just got everyone to buy milk. So you had 90% of your customers buying milk, and now everybody buys milk. So you have to look at it and put it in context. You have to think about, okay, does this matter? What's this rule? Is it interesting? It's big. This whole chapter we're doing there's so many jobs in this. There's so many jobs. So right here, summary interpreting rules. Overall, 10% of carts contain item C. The probability of finding item C in a cart increases from 10% by a factor of 7. So that's the lift, to 70%, which is the confidence. Among carts that contain items A and B, indeed, if a cart has items A, B, and there's a 70% chance it also has C. 5% of all carts have these items. There's some rules there. I don't like that slide that much. So let me go to some rules and just show you them real quick. Since we've been talking about the rules here, let me show you rules. Here's what rules look like. Now, there is a little bit more in this output these days, but here's the important parts. So does anyone see a rule they find really interesting right here? I'm trying to think. Some of these rules are interesting. Does anyone see a rule? It's just this one right here. It's like, what does this mean? What's going on with this rule? What is going on with that rule? That rule has two things on the left side. You have to look at the comma to see where the things are separated. So there's two items right here. It's two items. Rule 5? Rule 5? Oh, whoa. That is Anisha, 100 points right there. If someone buys bottled beer and soups, it increases the probability of them buying whole milk. That's weird. And it increases the probability of them buying whole milk by 3.59, a factor of 3.59. So the probability, you can find the probability of buying whole milk. Does anyone know for 100 points the probability of buying whole milk? This would be great output for the test. There's so many ways to answer this question. What's the probability of buying whole milk for 100 points? What is the original probability of buying whole milk? Lots of ways to find this out. 100 points first person. I'm trying to do it in my head right here as I say this. Okay, I've got a good guess of it. Let me check with that one. It's a hard one to guess. Man, it's a hard one to guess. Okay, I think I got it. Good guess, good guess. 100 points first guess, good guess. I'm trying to think. It's such a tough... Yeah, okay, I think I got a good guess. I've got to get... What is the probability of buying whole milk? This is something you should be able to figure out from this output if you know how to find support of an item. No one's got it yet. Try to pause if you're watching this. Caroline might be right. That's a little bit higher than I'm estimating Caroline. A little bit higher. Any last guesses? Caroline's answer looks to be close, which it could be right. I'm doing it in my head. I'm getting a little bit lower than that. We'll see. We'll see here. Ready? What we do is we take the original, or we take the confidence. So here's the confidence. We divide by the lift. And that, yeah, you're right. Yeah. I was trying to do it in my head. So, I mean, I was getting like 24%. So, yeah, which I'm doing in my head once again. But, yeah, that's exactly, nice job, Caroline. Caroline, and you could take any of these. You could take this and divide it by this, and you'll get the same answer. The decimal differences are just because we're only rounding to 3 decimals in the answer. But the confidence divided by the lift is the support of the item. Does everyone see this right here? That the confidence divided by the lift is going to be the support of this item right here. Does that make sense? That is a huge thing you should know, because I can ask that in the test like this, and you should be able to tell me, like, what is the probability somebody buys whole milk? Well, all you're doing is delifting the probability. You're going to take the confidence and divide it by the lift, and that'll get you the original probability right here. Confidence will listen the probability of buying milk when buying. So, so confidence divided by lift, the probability of buying milk when, so what this is, the confidence divided by the lift equals for the probability of just buying whole milk. So it's just the probability, it's just literally what's the probability of someone buying whole milk. Does that make sense, Sarah? Like what we just found is literally just what % of our customers buy whole milk. Has nothing to do with the rule. It's just the original probability of buying whole milk right there. Does that make sense? I think where people get confused, that's the support of milk right there. Awesome. Great job, Sarah, 100 points. Now, where people get confused is this support. How is this support interpreted? Who for 100 points can write out an interpretation of this support right here? These are really good and easy to write test questions. I always think of test questions while I'm teaching. I need to think of them when I have to sit down and write test questions. What is that support right there? What does that support mean? That is people who what. Hint, that's the hint right there. This support right here is people who what. So people, this is a longer thing to type out. Or you could, there's an easy way to type a shorthand of it. This support right here stands for the probability of people. You should understand what that support means. It's not the support of an item in the cart. It's the support of the rule. So that's not an item frequency. It's not like the probability of buying a certain item. It's the probability of what. What is that support right there in the output? We should be able to read this whole output and be like, oh, this makes sense. It's the probability of this. The probability of buying bottled beer, soups, and... No, Jordan, so close. It's the probability someone buys all 3 items. So it has nothing... Great job, Jordan. 100 points. Well earned. How often they buy all 3 of these items. So this support right here, it's It's the probability they buy all 3 items. It's literally the probability someone comes in and buys all 3 items. Has nothing to do with a given or anything like this. So this support right here, I'm glad we're doing this nice and slowly right here. Probability of buying all 3 items. Yep. This is, and it could be 2 items, but this is 3 items because it's all the items here. This support is the probability you have all 3 things in your cart. It's the probability of buying everything in the rule. So 1.12% of our customers bought all 3 of these items. They have all 3 of the, now they could have more items, but they have all 3 of those items in their cart. So it's very, very important. Now, what is the interpretation of the confidence right here? This is a rule related thing. This is given people have these items in their cart, the probability they will have whole milk is this. The confidence is like, think about this. I am this confident they will buy whole milk given they have those items in their cart. So the probability of someone buying whole milk is 91.7% given they have those 2 items in their cart. So that's the big thing. You should know what the confidence is. It's the confidence given they have the left-hand side. What's the probability of the right-hand side given they have the left-hand side? The lift, once again, is the factor increase from the original support. We've covered that a lot. And then this right here is the count, which is directly related to this. So the count is how many out of the total. And that's, you can notice that the counts here are similar to these. They'll, it's very similar because counts is just how many carts have all 3 items. So the count is how many carts have all 3 items. The support is what % of carts have all 3 items. So how many carts have all 3 items? What % of carts have all 3 items? So pretty good right there. And we'll go back and talk about this here. We got some more code. We talked about the a priori learning method last time. It's very, very important. Good. So the a priori learning method, we've got the antecedent and the consequent when we make these rules. The antecedent is the left-hand side. So that's the side you saw. I'll show it again. I know I'm switching between slides, but just to make it very, very clear what the antecedent is, this right here is the antecedent. The antecedent is this. This is the antecedent. This is the consequent. So you've got antecedent comes first and consequent comes second. Left-hand side is antecedent, right-hand side is consequent. So it's like the consequence of the rule, like what we're focusing in on. So these rules are going to be created with an antecedent and a consequent. And there it is. And the length of the rule is how many items are total in the rule. So if you were to add up all of these right here, that's the length of the rule. So all those rules I just showed on the screen, 100 points first person rule, all rules of length what? And so the answer is kind of in the chat right now. All those rules I just showed had a length of what? All those rules had a length of what? Every single rule, 100 points. 3. Jordan, nice job. They all had a length of 3. They all had 3 items in the rule. Great job. 100 points, everyone answering right there. 200 points max, unless we've broken the rules for you. Here's the ways in which we can create the rules, which creates a huge problem because when we do this, you can see here the combinations, especially when you start to look at buying like a middle amount of items, gets crazy. So what do we use? We use what's called the a priori learning method, and we're going to limit the amount of rules we make. So we're going to limit the rules by saying, okay, if people do not buy these items enough, like a combination enough, you can eliminate everything below it. So it's literally like saying only 1% of our customers buy peanut butter and sardines. So we're not going to look at any rules that have peanut butter and sardines together in the cart because those rules would apply to 1% or less of our customers. Because peanut butter and sardines is like such an unusual combination that we're not going to figure out how to market to these like very small groups of customers. Not that you don't care about smaller groups of customers, but you're like, okay, this rule probably like doesn't apply to that many people. We don't have a good understanding of this rule because it's based on a small sample size. So you would not base decisions on small sample sizes. You want to do larger sample sizes and to be like, okay, I'm going to, like not based on that. So once again, we can eliminate more rules, frequently item sets, all that good stuff. So the a priori learning method is going to eliminate down and make it easier for us to view what's going on. That's all the a priori learning method does. What's the point of the a priori learning method? To limit the amount of rules we look at, because we could be looking at like billions of rules. Billions is a small amount. We could be looking at quadrillions or quintillions amounts of rules. So what do? The a priori learning method allows us to eliminate rules that don't have enough support or confidence, and we will use smaller subsets of rules based on the a priori learning method. That's the whole point of it. So here's the A rules package. Let's start looking at the package right here that we're using. It's the A rules. It's association rules. That's what A rules stands for. and market basket with R, really good stuff there. Data representation inspection. So here we go. Here's our grocery store data. And these are transactional data frames. So the way this looks right here, you've got like market basket 1, market basket 2. This person came in and just bought whole milk. That's all they bought. They just went to the store, bought their milk, left. They bought pip fruit. Anyone know what pip fruit is? So you can look at each of these market baskets right here as you go across. So every one of these is a market basket. This person, whole milk, butter, yogurt, rice, abrasive cleaner. So they wanted milk, rice, and cleaner. I don't know. These are their carts. This is transaction format coding right here, or transaction data frames. So here we go. We're loading in our libraries. So load in your libraries. And then this right here is very important. You have to use the read transactions for this CSV. If you use read.csv, not going to work. Read transaction reads in the data frames that look the following way. This is a transactions data frame. You have to use read transactions and it'll store it as a transaction. If you take a look right here, here's our customer 3 right here we just saw previously. And take a look, customer 3 right here with their whole milk. There they are right there in this data frame. And here they are right here. They are cart number 3. They went through and they just bought their milk and they left. So don't worry, you can literally just use this code as is, as long as it's formatted the same way, but that works. We're going to inspect the data frame, and inspect is a very specific thing. Now, this is what took me like a semester. This took me a semester to learn. Inspect just cats to the screen. So it just prints stuff to the screen. You cannot capture what is printed to the screen. So when you run inspect will instantaneously print to the screen. So you have to do all of your, this is a huge note, you have to do all of your manipulation inside of inspect. So put this in the chat. Do all the manipulation inside of inspect because it just prints to the screen. You can't manipulate a printing to the screen. Do all your manipulations inside of inspect. I did not know this for a semester and it drove me nuts because it looks like this is element 3, but it's just printed to the screen. That's not element 3 in a vector. That's just printed to the screen. So you can't manipulate that. You can't call it there. So do all the manipulation inside of inspect. You can't go outside of inspect. Like here's what does not work. What does not work is you can't go here to inspect and you can't say inspect and go to 1 through 4. This does not work. This will not give you the output you want. It'll just ignore this right here and it'll just run the inspect. So this right here does not work. It'll print to the screen, but it won't give you what you want. And this literally took me a semester. It drove me nuts. I was like, why is this not working? Until I realized inspect just prints to the screen. It doesn't create an output that you can manipulate. So you have to do all your manipulation right here. You don't do it on the outside. When I say things took me a semester, I mean it. And then I was finally like, oh, that's how that code works. That's why it's doing that. I can't manipulate it because it's just printing to the screen. It's not actually storing anything. It's just printing it out to the screen. So if you notice how the manipulation here is all done inside of inspect, these are great notes for your for when you're doing your work. So when you're doing your assignments, make sure you're following the following right here. Like literally you can look at all the carts 13 through 15, the last 2 carts people bought from, nice and easy. You can make subsets, and here we get to a big thing. It's one of our last, we've still got tons of time. But this right here, %in% versus %AIN%. Here's huge notes you need. IN means that the items in the cart, when you look at it, grapes and soda, can contain one of those items. Like this cart has soda, this cart has grapes, and this cart has grapes. It means that the items in the cart have at least one of these. So when you look at the carts right here, they have at least one of these. But AIN I call all in. So AIN I call all in because if you do AIN, then what? What is the difference between IN and AIN? What is the difference between IN and AIN? IN can have any, needs all of them. Yep. So when you do IN, and I might download the grocery store data set here. Well, when you do IN, it can have both of them. It just needs to have one of them, like carts that have these items, and it just has, and it could have any of them. So at least one item is contained in all of them. Yep. So IN means like one of these items is in the cart, at least one. Like if the item's in the cart, it's a cart that has one of these items. So you might say, I'm interested in people who buy milk and bread. So then you would run an IN. What if, so I got to be specific. What if I want to look at people who buy both milk and bread? Like they need to buy both milk and bread. Yep, either, and you can do more items than 2. You could do a whole bunch. But if I want to look at people who buy, yep, to be AIN. If I say they have to buy. So, and this only works for transactional data frame. So if you look right here, if you add more, it's this or this or this. So it's just an or statement. It's like you can have this or this or this or this in your cart. And then AIN, which is only for transactional data frames. Is that a typo? That's $1. Ooh, I never noticed that. Wow. Typo you notice after 3 years of using these slides. But this is the and right here. They have to have both of these items. So key difference right here we should note is that we have right here, there we go. Key difference. IN is or and AIN is and. And it's easy because it's the AIN, so it's and. There is an OIN. That one confuses. We won't use OIN in this class. And then there's PIN, which is like partial match. There's IN, AIN, OIN, and PIN. But we use IN and AIN in this class. So don't worry, you don't have to know the other ones. I've used them a little bit, but there's always more to learn. The item frequency right here is such a cool chart because I like it right there, Anisha, 100 points. The whole milk right here is the most commonly bought item. One thing I will say about this chart is it's not stretched. You can't see the names of everything. There's more things than we're seeing, but you can see what percent of our carts bought. And so these are the item frequencies. And how many carts are there in this data frame? Does it say somewhere in here how many carts there are? I wish it did, because we could then figure out the support for those items. Here's the item frequency right here. If you look, we're doing a item frequency, and item frequency reports out the item frequency, which is just the support for each of these items. You can look up individual items, like you can put a name in, which is really cool. So what does the top N argument mean? Oh, that just makes a plot right here of the top N items bought. So, the top N argument, yes. The top N argument just returns the top 20. So if you change this to top 10, it'll just return the top 10 items bought in item frequency. So we can do item frequency plot of your transactional data frame. And I forget what absolute means. I think it changes it from percent to the amount. So the argument here, absolute, I think goes, if it's the other one, it'll do a percent. No, Jordan, 100 points, good question. And then that just changes how many you report back. No, you should know what every argument does. Good pullback. Hey, Brian, what does the top N argument do? And right here, item frequency just reports the support for each item. So if you look at what item frequency does, this just gives you the support of every item. So here's the top 6 supports. Here is the item frequency of item 121. And you can also call the name of the item. So you can actually look up things within the positions by looking up its names. The length is just going to tell you how many carts there were. This is the length of the transactional data frame. So it's how many carts. Just once again, to look at it, remember what your transactional data frame looks like when you read it into R. It looks like the following right here. So we just have how many carts are in our transactional data frames to figure out the length of it. And length right here times this. This is how many people. So this is where it gets a little bit tricky, but take a look at this. This is how many carts there are total in the data frame. This is the percent, and we're doing 2 things right here. We're doing the percent of people who bought item 121, and we're doing the percent of people who bought soups. And so if you say something like, we have 200 carts and 4 of our carts bought soup. If we have 200 carts and 4 of our carts bought soup, the mathematics behind that would be 200 times 4%, and be 8 of our carts bought soup. Does that make sense what's going on right here? This is like 200 carts and 4 of our carts bought soup. Now that's not the math being shown, but it's like, this is how many carts there were, and this is the percent of carts that bought this item. You've got a vector here of 2 values, which makes it a little more confusing because you're doing like, here's the total carts, here's the people bought this item or this item. So we're just multiplying this number by this and this number by this. The mathematics is length times this, and that returns a vector of the probability, not the probability, but the amount of carts that bought each of those items. So hopefully that makes sense what's going on right here. And here's the associated probabilities. So, and out of the 9, yeah. So it's literally just this times this right here. Little confusing. Like it's a lot of math on the screen. Finding the rules. The example below shows how to use the a priori method right here. So this is key. This is really the most important thing, and let's break this down right here. So when you look at the a priori learning method, let's go over to the main screen. Let's break down what every part of it means. Okay, so with the a priori learning method, you have right here your transactional data frame. I wonder if I can put, I might not like it when I put comments right here. Transaction data frame. Yeah, it doesn't like that. Sure. I don't think I can cancel out of that. I'll put it over here. Okay, so this is your transactional data frame. Parameter equals list, and then you get into your list of what you're doing. So the support equals support of rule. Confidence equals confidence for rule. Confidence for rule. And this is the length we want. Does it already have a space right there? I think something. Oh, it's because of the, yeah, I see what's going on. There we go. I didn't like that. And there we go. Good. So this is smallest rule, lowercase rule, and this is longest rule, and limits output. Okay, so here's what everything is doing inside of here. We give it to the transactional data frame. You have to do your parameters as a list, because if you don't do a list of parameters, you could only enter in one. So you'd usually want to say like parameters, and then you're storing into your parameters this, but you have to store it as a list. That's just how the function takes it. You could literally run this code as is right here, I believe. This should run, and you'll notice parameters is a list of these objects. It's just how the code wants to take it. Does that make sense to everybody? Like parameters, so you could, now that it's stored outside there, you could technically run this. But parameter is a list of objects, and that's just how the code wants it to be, which took me a while to understand that. But these are your parameters of how it's going to do the a priori learning method. Does that make sense to everybody? This is how the a priori learning method will run. We're going to run it on this transaction data frame, and then rules need to have a support of 0.001. Confidence for the rules need to be at least this. The rules can be as small as a length of 2, which is our one thing on one side and one thing on the other, and the rules can be as long as 4, and this just controls output. It limits the output so it doesn't just print tons of output to the screen. So verbose equals true would make a lot of output. It's like someone being verbose, like I'm verbose, so it would give a lot of output to the screen. Does everyone think they understand how the a priori learning, what it takes? Like when you break it down to these parts, you need to give it the transaction data. You need to store it into something. You need to give it a list of parameters. So the parameters will be a list of things. You'll say like, my parameters are equal to these list of things. Inside the list, you'll give different parameters. So you're just creating a list of different parameters. And then the control equals list. And I guess there's more you can do with the control, but I've never done that. I've never really. Our lines 6 and 8, all for the a priori setup. Yep. You'll run it inside of here. So everything inside of here, this can all be ran the way it is in the notes, just like this. It can be ran like that. So it's everything inside of here. I've just kind of staggered my code. We're still inside of this. If you notice right here when I click on that, this is the start of this and this is the end of this. Everything inside of here is all in the a priori. So do we always have to include list equals? Yep. You have to do, so you open up the list and you end the list right there. So if you look at where the list opens and ends. So list, when you're storing the object, might make more sense if I do it like this. The object is being stored, like the control is a list, because control probably has more things. I've never really messed around with what the control can do, but apparently there's more options. So you could have like a second option. I don't know what the second option would be, but that could be equal to true. So if you notice right here, the control might have more things in it. So that's why it's a list of things. Like the control is a list of things we're going to choose options from. So then you could have a third option right here, and you'd go like third option equals 2. And so this is how we do this right here. But I don't know of a second or third option off the top of my head for the control because I've never manipulated it. I'm just happy with what the output does. Does this make sense why this looks this why it looks this way? With what's going on with the code right here. Hopefully it does. Like it's like, okay, I understand the structure of this. And so that's got that. I think we understand what that means. We'll go back. Awesome. So we should know what this does right here. These are just our options for it. And this is the object we're manipulating. And this just controls our output. Not a big deal right there. And the slide says it too, what's going on. So here we are. We've looked at these rules. I'm trying to think if there's, I mean, it's mainly just output. Verbose just controls the output. If you do verbose equals true, you'll get a lot of output. And you know what? I'll show that. Let me download the transaction data frame. So I'm going to download the transaction data frame. 2 seconds. Let me hop over to here. So I'm going to download the transaction data frame and show you if verbose equals true. And let me make sure I get all libraries. Grocery. Because we got enough time. Grocery? It's not grocery? Am I losing my mind? .csv? Ooh. 2 seconds here, everybody. Where is that grocery.csv? Sometimes we need things on like 3 different computers. How is everybody doing today? We're going to look at some transaction data frame right here. It's saying it's not found here. Am I spelling it incorrectly? No, I don't have to spell grocery anymore. Groceries. Ha ha ha. Ha ha. Ha ha ha. There you are. How dare you? I thought your name was grocery, not groceries. And here's this. Let's grab, well, we need the read transactions. We should be good there. We've got it in downloads. Let's see what chat's saying. How is chat doing? Verbose. How is everyone doing today? We're almost done. Oh, oh, that did not end. That's why I moved my code with the indent. Okay, there we go. And let's see. We still got 10 minutes. Don't sleep. Oh my gosh. Stressed? Oh no, don't be stressed. Don't be stressed. A rules is not on. Oh, A rules is on here. A rules viz. No repository A rules viz. Install.packages. Is it gonna say no? Won't tell me A rules changed. Oh, A rules viz is installing. You're gonna need data sets. I know today is a busy day. I'm going to finish writing the test today, so it's busy day. If a library doesn't load, try installing it. Can I write a code to time travel forward about 3 weeks? I would like, hey, George, or is that Adam? Adam, 100 points right there. Adam, if you write that code, send that code to me. Share that code with me. I would love that. 3 weeks from now, I'll be living with my fiance in Texas. There's no thing called data sets. Really? Then why does it exist? Sure, let's just see what happens if I click yes. You gonna do it? Sure, okay, there's no data sets. Well, hopefully we don't need that. Send me that code so I can hang out with my fiance and we can make taco night. And we can watch movies. So that'll be awesome. So I'm just going to indent this code to make it look better right here. R doesn't have enough 1.21 gigawatts. I love it because it's gigawatts and Doc Brown says gigawatts. It's got 100 points, cracking me up right there with some gigawatts. Yeah, it's, like back then they didn't really, I got to change my working directory because I'm not working out of downloads where I want to work from. So I can't find the file. So back then, gigabytes and gigawatts was not a big thing. So they didn't really talk about it that way. And let's move this code up to here because we want to look at it this way. Okay, so we can expect the data frame now. And if you notice, good, it did what I wanted it to do. Please note, this doesn't work the way I want it to. You can see it down here in the output. It still returned 6 objects, and it got mad, and it gave me that null, and that took me a semester to understand. And then there's the first 4. You could go here and return like 20, and you could go to item frequency, and we should be able to go to item frequency of G. We can go to position like whole milk, and this will tell us what % of the time people buy whole milk. You could take this, times it by the length of G, and that's how many people bought whole milk. Does everyone understand how I'm easily able to figure out questions right here as like what % of people bought whole milk? How many people bought whole milk? I can figure out all these things. I could take any item we see on here like meat, or that's meat spreads. Is there meat? Let's find out if there's meat. We can go to meat, and is meat in here? Nope, there's no position meat. So we can go to yogurt, go to position yogurt, or there might have been that space that did it. Let's go back in time. Was it the space? Oh, it was the space. There is meat. So we can figure out how many people bought meat. We can figure out what % of people bought meat. Does everyone see the difference between this code, how many people bought meat, what % of people bought meat? And if you times that by how many people there are, you'll get the amount of people who bought meat. Very important right here to see what's going on with these codes and how we can quickly manipulate them. If you go to item frequency plot, you can go right here. You can just put in G, and it should give us the item frequency plot right here. So I don't know what the default is for this. Error too large, that's fine. Rerun it. And whoa, here's what you're going to put in your report. What's going to happen to your job if you put this in your report? What does item frequency mean? It's how often the item is bought, the percentage of time the item is bought. So that is the percent of time the item is bought is item frequency. So when you look at item frequency of meat, that's the percent of time meat is bought. Yep. How frequently percent of time item is bought. With this item frequency, we need to go here to top. Is it going to show me it? Really? It's top n equals 10. There we go. Here's the top 10 items bought in the data frame. And you see right here, the scale is percentage. This is not absolute right here. You will lose it. Exactly. Vader nut, 100 points right there. Great answers. You'll lose your job. Not legible. And all we're doing is reproducing a lot of this output and understanding what codes to use and when. So if you notice, I'm just reproducing a lot of this output right here. We can make subsets of people who just bought certain items. So we'll go down here to the end and we'll do a subset. I need to move this code up to here though, because I don't want you running this code in this order. I want you running it like that. So we could go here to grapes and milk. Here's the people who bought grapes and milk. What is it not like? Items %G. Error in items. Table contains an unknown item label. Well, this code should run. Let's do the other code. Let's try this. Okay, that works. Was there no one who bought grapes and milk together? No way. Grape, milks, and soda. Is milk not an item? I thought milk was an item. Whole milk. There is no milk. There's whole milk. There we go. Jordan, 100 points. It's whole milk. Yeah, you guys are seeing it too. I was like, I thought people bought milk. There's no one buy milk. So when you go to sub now, if you go to inspect on sub is a transactional data frame. Here's the carts. But you'd want to go to inspect sub carts 1 through 5. And here's the carts. And look, right here, people who bought whole milk right here. So if you look at this code right here, we're inspecting the carts of people who bought, and that's so much output, people who bought any of these items. But if I go to this, it's going to limit my subset. If we go here to, well, let's do this. Let's go here and go to sub 2. And this will get me the answer for how many people bought either milk or soda. This will get me the answer for people who bought both milk and soda. And so sub 2, length of sub 2, is going to be how many people bought both milk and soda. And that's how many people bought both milk and soda. And we might be able to figure out, you know what we can figure out? We can figure out the lift of this real quick. Because given somebody buys soda, what's the probability they buy milk? So this is the people who bought soda and milk. And there's 394 carts that have both soda and milk in them. So given someone buys soda, there's 394. So that'd be out of the total transactions. Why would AIN, so let me see here. I thought it included everything. Limit it because AIN means they have to buy both. So if you actually inspect this right here, let's inspect sub 2. Everyone in sub 2 must have what in their cart? Everyone in sub 2 must have what in their cart? Everyone in sub 2, we got 3 minutes. We got good stuff right here working with this data. Everyone in sub 2 must have what? Hey, what's up, Morgan? So good to see you. Mini-term, right? I think? Was it fall? So good to see you, Morgan. They must have both these items. It has more constraints, yeah. So everyone in this cart, like this person right here has soda and whole milk. Soda and whole milk. They have to have both. Does that make sense? Soda. Everyone has to have soda and whole milk. Like every cart you see will have soda and whole milk right here. So they have to have both of these. Like every cart, soda and whole milk. And you could add a third item in here. So now every cart right here has to have all 3 of these items. So there's 54 carts that have all 3 of these items. So you see we're like limiting, you know, these are the carts that have all 3 of these items. So to be in this subset, you have to have all 3 of these items. Let's go to inspect rules real quick. And we'll just look at the rules. So error rules not found. I didn't create the rules. Cool, rules are created. Inspect rules. Oof, rules are so long. There we go. Okay. Inspect rules. Rules 1 through 5. Remember, inspect. You need to do the inspect inside. That's a graphical error, as I say every day. Another day of Brian saying that's a graphical error. You now get coverage. You are not expected to know coverage because even I will have to review what coverage is again until it's implanted in my head. What coverage is. Someone told us a class or two ago what coverage is, but I I think Connor came in and he told us. But don't worry, coverage is not on the test. They've just updated the package to do more. Is it possible to limit how many carts? Possible because they have to have both. Expand upon that, Alex. Really good question. We're here in the last minute, but you can see how to inspect the rules, and you can see this just returns the rules. You can also sort your rules. I'll just show that really, really quickly here because that's like the last part of the assignment is like sorting the rules. So when you want to sort some rules, there's all your rules. And if you want to sort the rules, here's how you sort it. You have to do the sort inside of here. So you have to go to sort the rules by this. And then remember, everything you do is inside of the inspect. So I don't think this will run. Will that run? Yeah, it doesn't do that. You have to inspect the rules. So once you create a rules object, you have to inspect it. And here's my rules sorted by this. And I'm going to decrease the length of the rules. I only want rules of length 2. So now when I inspect these rules, ooh, script is out of bounds. It didn't get any rules? Really? Really? Nothing? No way. Max length 3. How'd I break it that quickly? There we go. There we go. There we go. 1, 2, 3. Are there... Oh, there must not be enough... Due to the constraints, it must have made rules not enough. I guess when I hear limit, I think something is being excluded or there's a max. I think go into a little bit greater detail. I'm trying to, here, wait, I need to vanish. You can see all the output right here if you're looking at it. Like liquor, this is what you see on the slides. And I limited it to the top 3. You can sort by confidence if you want. And the best thing to do is copy paste what's written there. You can do it by support. We should be able to do it by support. You can sort this right here. So you can do it by support, which is the items that are bought most frequently together. So we have a midterm tomorrow and Wednesday. We have homework due tomorrow. We have our code night, take home due Friday night. I know it's a big week, Alex. It is a big week. And so be working. I know this is the big week. This is the big week. It's just power through this week. I'm so sorry. I'm so sorry, guys. I'm so sorry. Let's take a vote right now. What if we have the test on Wednesday, Thursday rather than Tuesday, Wednesday? Would that be better for everybody? Test on Wednesday, Thursday. Do we keep the test Tuesday, Wednesday, or test Wednesday, Thursday? Okay. If you're here right now, you get a vote on this. So let's do this. Let's put a vote in. You ready? I'm gonna start up vote. So got everything good to go here. So the poll, there we go. Vote Wednesday or vote Thursday. When should we have it? When should we have it? I think I know it's going to win. The initial reaction. So, okay, there's a bunch of yeses. Okay. This is a big week. It's a big week. It's big week. So, I remember Market Basket is not on the test, but this is like one of those weeks where you're like, man, this was the hardest week of this class. I'm very sorry for that. This is the big week. Brian even realizes it. Okay, I think it's unanimous. I'm going to still have it open on Wednesday, but the test will now be on Wednesday, Thursday, which also gives me a little more time to work on it because even I'll tell you guys, I feel it. I know when I feel it. I know you feel it. I know you feel like, man, this is a lot of work. Thank you so much. Thank you so much, Malin, right there. It is unanimous, but it'll still be open on Wednesday. So I'm going to have it open on Wednesday, and it'll stay open until Thursday. So that's unanimous. Wow. So, well, thank you. No, I mean, I was feeling it. I could tell that you guys, I try to react to the class, and I try to look, who gets 100 points right here? Who's speaking up first? They get 1,000. Adam was the first person to bring up the topic. Adam, you get 1,000 points. Adam brought it up first. Adam started the conversation. So it'll close at 2 p.m. on Thursday. They'll close at 2 p.m. on Thursday. So mainly the idea is take it like Wednesday or Thursday after class. I mean, you could take it immediately Thursday after class. You get the practice test. This gives me a little more time to get it up and going because, man, I've been writing so many questions. If you want, put practice. If you want to, seriously, I look at the possible questions. Class is over. We finished class. I look at the possible questions, and I've been taking from those. So I can't say everything. You're welcome, Anisha. And you're welcome, Kelsey. So I don't take everything and Vidrina. So like I listen to you guys and try to go with what the class is going to need for help. And so it's still open Wednesday if someone was planning to take it Wednesday, but you're welcome, Jordan. But it's going to be open Thursday now. So Adam to the rescue right there. Adam was the one who started the conversation. So please, the biggest thing is I always want people to know I do listen. I do try to react. I do try to, you guys, the gals, and everybody here are my students. And it's important to me that I know it's a tough week, but so midterm due Thursday, take home due Friday, homework due Tuesday. And there might be another, when's the next homework due? Every homework now has a due date because some people were wanting that, which I totally understand. People were like, hey, Brian, can you put due dates for all the assignments? So I said, yes. And they were like, I really want to plan out my schedule here. Can you put due dates for the assignments? And I was like, you bet. Let's do that. Let's put due dates. Due dates are good. Then you can plan out your life. And, oh, good. Oh, man. Oh, wait. Friday night has 2 things due. Oof. Okay. Here's another conversation. Okay. Okay. You guys, this is... Okay, now we need to do another vote here. Okay, I'm seriously putting another thing to a vote. Homework. Can't spell. Homework. Is homework going to be due on Friday or Saturday? I'm going to move it. I'll keep it the same or I'll move it. Here's the poll. It's open. Is homework due on Friday or Saturday? There's going to be limited votes on this. Homework due on Friday or Saturday. Yeah. You guys can see it on the screen now, I think. Let me go back to look at what you're looking at. But there's also one due on Monday. I mean, this is a big week. It's going to clear up a little bit from here. I tried to space everything out. It's pretty unanimous again. So I'm going to move it to Saturday right here. And this is so we've covered association rules. Does everyone understand? Like, we're going to talk about this a little bit more. No, this is pod. Is it pod? Oh, that's the line from Star Wars 1, isn't it? Like, no, this is pod racing. Oh man, you're cracking me up. You guys are cracking me up in chat. So let me move that. Let me go to assignments. This gives us more time for activities. So I think tomorrow we'll do some activity. We'll review tomorrow. So the plan tomorrow is to do some review, to do an activity tomorrow. So definitely be here. Activity tomorrow, review tomorrow, and all that good stuff. So let's change the homework due date. Association rules. Cool. And this is great. I know Monday, it's good because I don't like things being due over the weekend. I might hold office hours. I kind of plan to go home next weekend. I'll plan to do it this weekend. But, oh guys, it's so busy. It's so busy. When is it not busy though? You know when it's not busy? Next month when I get to be in Texas. That's when it's not busy. I say that and then it'll be like really busy. I'll be like, it's so busy still. But that's got that. Okay. We got that situated. That's got it. Poll is unanimous again. And there we go. Like, thank you everyone for telling me what you think and voicing your opinion. Because that's, this is a democracy. Extra time for tacos and movies. Exactly. I'm still going to be like, if Chelsea has off at the start of it, it's just going to be like, let's have as many taco and movie nights as possible. Like, make your own pizza night. I love make your own pizza. Like, I like that. Or like, like making steaks, making calzones. I made calzones one time. We'll need to try that again. One of the people in my department's from Italy, and he's like, he made these calzones, and I was trying to. You're making a pizza right now? That's awesome. What's on the pizza? It's Dr. Paulo Lattis. Hopefully not mispronouncing his name, but he's from Italy, and he's like, Brian, he's like, you just need a simple dough, and then you put in the mozzarella, and you have and I was like, oh man, because I've had his calzones, and they're so good. Like, has anyone ever? His calzones were some of the best. Just cheese and pepperoni, and I think he had prosciutto in it. He had prosciutto and like probably pepperoni and prosciutto, and it was like there was this like amazing balance of like you could taste the sauce, you could taste like the cream of the cheese. Not that it was a cream cheese, but there was like this smoothness to the cheese, and then there was like this like pepperoni prosciutto like taste to it, and then the dough was just like so soft, and I was like, this, it's like I'm not allowed to eat this. This is so bad, like, because I would just eat like all the calzones. What is the take-home data mining exam on Canvas? That is, make sure to do it. That is your take-home exam due Friday. Great question right there, Yaji. So that is your Friday take-home exam. Make sure to do that. That is the take-home data mining exam. We covered that at the start of class. Wait, is that? If I have two things posted, I'm sorry. Do I have two things posted? Do I really? Oh, I do, don't I? Okay. This is, that says take-home data mining exam. Don't worry about that. Sorry, I'll make sure everything's properly situated with points. I don't want to change it right now because I'm slightly confused. I'll make sure everything follows the syllabus. Sorry if this is in the wrong category. This is the programming midterm. Maybe I already had a spot and I guess I duplicated it. But I'll make sure everything has the right point allocations via the syllabus. But this is what you want to follow. It's very, and I sent this in the announcement too. This is very explicit in what it says. It's like, do this, do this, do this, do this, do this. So make sure to follow this exactly as is. Does that make sense, Yaoji? Does that make sense on how to do it right there? Great job, everybody. We'll see if people have questions about homework. Any other last questions? If you're here for 3:20, I might leave soon, make some lunch, and start doing some work. I made rice, and I had a taco kit, and I made like I was like, wait a minute, I always have such a hard time with taco kits. So I'm like, I'm gonna make all the meat, and then I'm gonna make some rice. I'm gonna put it in a big like pan, and I'm gonna layer it. And I made like a taco layer thing, and it was really good. And then like put some cheese on it and put the salsa. Could you help with? Yeah, let's do it, Jordan. Let's do it. That's the current homework. You got it. You got it. It was like I made this really good like taco bake. So you know what I should do? I should put it in the oven today and like rebake it because I've only got a little bit left. BAS 470 course. Try to know how to code the elbow plot. Yeah. Madeline, is that the ideal elbow plot? I can go over that some here. Is that the ideal elbow plot? Is that the ideal elbow plot? Cluster. Look at this. We're so close. Like when we get with 1, 2, 3, 4, 5. This is the hill. Once you climb the clustering hill, then you're gonna go down, like down the clustering hill, not fall down. So there it is right here. Here's like the code for it. And so is this what, and Jordan will do that one next. Sorry, wait. I'm like, Jordan asked first. Are you talking about the ideal elbow plot right here? Does everyone remember how the good elbow, bad elbow works? I got trouble on Q7 on homework 5. Yeah, let's do it. Let's start doing some homework here. Let me save this. Today's the 15th, right? Today is the 15th. Got to go back to 320 folder. That's where I store all the files. This is Philip DeFranco show. I like that. I don't know. I miss his. If anyone else watches Philly D. Anyone else watch Philip DeFranco in the audience? Any Philip DeFranco fans? You know who Philip DeFranco is? He's my news of the day type person. My world view is shaped by Philip DeFranco. He'd probably be like, oh no. You run a news show. Come on. You're going to shape my worldview. I'll admit that. You got to, there's someone that's going to shape your worldview somehow. Let's go to, now we got to go downloads. Cool. Here's the clustering homework. Cool. Okay. And so graphic error. Sure. Okay. So ideal elbow plot, then we'll do Jordan's. I've already got the ideal elbow plot in here, and it was 3D. The quickest way to do it is to go right here. Madeline, are you talking about this one right here, the ideal elbow plot? Is this what you're talking about, Madeline? I think 3D, right? Was that, oh wait, I have a question about the code in the elbow plot for 3A. Okay, 3A, sorry. So produce the elbow plot exploring the values of K from 1 to 20, taking iterations max and start. Okay, well, I meant the first part of the question, yeah. And so when you do this right here, we're going to pull up the clustering work. Let's go to files. Let's go to open. Let's go to clustering. Let's go to elbow plot. Here we go, k-means. And where's the elbow plot? Elbow plot now. Here we go. So here we go right here. And there we go. This is basically the code right here. That's an ideal elbow plot. Well, we should have it for the data. Here's the data. So this code right here is going to be very valuable. And let's see what data it wants us to run it on. Okay. So this is the code to get your elbow plot right here. Question 2, you got it. And Jordan will do next right here. I think you will do all these questions. So let's try the, do we have to make the data frame? We have to make the Kroger data frame, right? Okay. So the Kroger data frame, we'd have to go back and do that. So we need the Kroger scaled data frame, right? We need the Kroger scale. Is that correct, everybody? Am I doing this correct in my head? We need the Kroger scaled data frame. So once you have the Kroger scaled data frame, you can run this code on it. So does everyone see where I got this code from? This code is right here in the notes. This is slide. Wait, there we go. This is slide 64 in the notes, gives you how to make the elbow plot. And if you look at the way the code is running, the code right here is running on this data frame. So this data frame right here is the name of your data frames. Like this is Kroger scaled. So does everyone see this should be Kroger scaled? It's going to store into CL. And we're going to run this right here. And we're going to store the within cluster sums of squares after this runs into the following. So, yep. We can go back and do that, Kelsey. You got it. And so this code right here, I don't think I can drop the whole code in the chat. We'll drop. Oof, so close. Here, wait. We might have to do it in 2 parts. What is the total within sums of squares? So the total within sums of squares, which is right here. So this is the value you're getting. That's all these values. So this is for every cluster. Like this was the total within cluster sums of squares for this one. It's this value right here. It does it for each cluster. So this code goes through all the possible values of k, which are all these. It goes from the first to the second to the third to the fourth to the fifth to the sixth to the seventh to the eighth to the ninth to the 10th, because we did 10 possible values of k. So that's what the for loop is doing. It's going through all possible values of k, and it iterates through where it runs and it does the k-means algorithm. And so it creates the clusters with like one cluster. That's where it creates with 1, then it creates it with 2, then it creates it with 3. And every time it creates it, it stores the within cluster sums of squares from each cluster. So it takes the total within cluster sums of squares and stores it right here. Now, what we're doing right here is we're trying to look at the relationship between, as we add cluster centers, what happens to the within cluster sums of squares. And the within cluster sums of squares is the error within the cluster. Like you can see right here visually that if you were to add 4 clusters, like you'd have a cluster here, you'd have a cluster here, you'd have a cluster here, you'd have a cluster here. The error within the cluster is going to get smaller. So with this cluster, there's smaller error. If you had 1 cluster, the within cluster sums of squared error would be the error across here, the error, like every point would have its own error. So you look at what does it mean to have an error? It means how far it is away from the average, which is the mean of the cluster. So here's the mean of this cluster because it's the middle of the plot, just visually speaking and kind of mathematically. And so you would then have how far a point is away from that middle. And this point is very, very far away. My sister texted real quick. 2 seconds. I'm going to reply to her. IPS monitor 27 HP IPS refresh rate. Sorry, gotta help out. It's 1080. Pretty good. I can look. Okay. Gotta help the family there. So, she's probably gonna like call or text. So, we see right here possible values of k, and these are the possible values we have. What does that's random uniform? Is there a random uniform in this that I missed? So it looks like run if. It really looks like run if, but it's random uniform. And so when you do this right here, random norm is random normal. So it stands for random uniform numbers, and it'll create random uniform numbers usually between 0 and 1. So random uniform creates random uniform numbers between 0 and 1, and then you could put a lower and an upper bound. You could say like 10 random uniform numbers between that, and there's 10 random uniforms. You could round it then and get just no decimals. So then there's 10 random uniform numbers, which are evenly distributed. So these are 10 random uniform numbers in the, Yeah, no. Great question. I mean, it looks like run if. The first time I read it, I always thought it was run if, but it's random uniform numbers. So, but it's because it looks like run if. But I was like, what is run if? And it's random uniform. And then it helps when you see ran norm, our norm. So Madeline, I think, was asking about this one. Madeline, do you have your data frame? And then I think it wants us to, it says run with max iterations 30. For a lot less. I think she got a pretty good deal right there. I don't know monitor prices as well. And so then we have here max iteration 30 and end start is 25. And so this is control the end start. Oh, wait. Let's try the k-mean clustering, produce the elbow plot. Oh, okay, so yeah. Does this do... Should we have this restart? Where's the restart on this? So let me go here. There it is. Cool. Change this code out. This is the long way of doing it. And here we go. So here we go. Kroger scaled. There we go. And max iteration 30 and end start equals 25. So does this kind of, what's the reason for making 25 configuration? Yeah, oh, good question. This goes to this whole thing right here, and then we'll get to Jordan's. So the reason, you have to know what every one of these means. So centers is the what of k-means. Centers is the what of k-means, which you won't need to do the multiple things right here. So explore the values of k 1 to 20. Yeah, so we do need to take that previous code. There's multiple ways of running this. You could loop it really easily. And then you need to get the within cluster sum square. So you do need that previous code. I was right. Where's that previous code? Well, this code has it. See, I should just go to the page that has the code we're looking for. This code has it all. This code, I stand corrected, Madeline. The code you're looking for is this code on page 80, because it already has the for loop on it. I was going to write out the for loop myself, but this code already does everything. This code is the ultimate code right here for producing this. Did it also have the plot on it, I think? It does have the plot, but it's the same thing. It's the same code right there. So this code right here, I'm going to remove this, is the same code, or their best sums of squares. Cool. And then we're storing best sums of squares into that. That's good. And then we move this over here just so we can see. Okay, that's the same thing. And yeah, we're only taking. Okay. So yeah. And then this wouldn't be the ideal. This would be for just a plot. And this is what we get. And we need to go here to Kroger scaled. So now this code will do exactly what we want. It'll get the k-means from Kroger scaled, and we're going to do it for 20 clusters. We're going to do max iter equal 30, and the end start equals 25. Cool. And then k-means creates a list of things. So k-means creates a list of items, and we're just taking from that only the total within sums of squares and storing that into best sums of squares. So when we run the k-means algorithm, all we're taking from it is this. It'll create more than that, but we're only taking from it this item. So we're going to run the k-means algorithm and then take from it immediately. That's why the $ total within sums of squares is here, and store that into the best sums of squares. So it's going to find out the total within sums of squares for each clustering scheme starting at 1 and going through 20. And then it's going to store it to within this cluster sums of squares, and that's going to do this. This is the whole code for this question right here. So this, and this once again, just so people can see, is on page 80 of the notes. So that's page 80 behind me. Everything right here is the whole output. You just have to change the data frame you're working with. So everyone should have this one right here. Let me do a little bit more of this question, then we're going to jump right to Jordan's question. When we look at the max iterations right here, to review what the max iterations does, the max iterations is when we're running the k-means algorithm. The max iterations, here we go. So the max iterations is the amount of times it'll move the cluster centers. These are all iterations. When you see the cluster centers moving right here, it's going through iterations. It chooses a random starting point, and then it moves the points. And this is one iteration. Well, it assigned the data, and now it moves the centers. So it moved the centers, then it reassigns the points, and it moves the centers again, it reassigns the points, and it moves the centers again. So this one only went through three iterations, I think. So does everyone understand what an iteration is? And you're saying, how many times will I allow it to max iter before it reaches convergence, or I say, or it reaches max iterations? It'll either reach the maximum amount of iterations, which is how many times you'll allow it to keep moving the cluster centers, or it'll reach convergence, which means it doesn't get to a better answer. Convergence means the answers, how many points have we looked at? Oh, wait, Jordan died. Sorry if I missed that. My brain jumped. But maximum iterations is how many times it'll move the cluster centers, trying to reassign the points and create the k-means of whatever the k is. So maximum amount of iterations is the maximum amount of time it'll move the cluster centers and reassign the points. Does that make sense what max iterations is? An iteration of it moving the points is it starts with this, and then it moves the cluster centers and reassigns the points. Moves the cluster centers, reassigns the points. And then it moves the cluster centers, reassigns the points until it reaches either convergence or it hits the maximum amount of times it can move the cluster centers and reassign the points. And then move to cluster centers and reassign the points. These are all iterations of moving the cluster centers, reassigning the points. Who's with me on that? Yes or no's? Does everyone understand that iterations are how many times it moves the cluster centers, reassigns the points, moves the cluster centers, reassigns the points? It's trying to just find where the centers are. It's trying to find where the point centers are. So I think hopefully people understand that. Doing good on that? Okay, good. So then what is end start? Well, end start is like you have to then completely restart the algorithm. Because how are these cluster centers chosen? How do we choose these cluster centers? How do we choose where these start out? Whatly? Man, I want to hit the button. We'll hit the rainbow button. Imagination. Wrong way. Imagination. SpongeBob right there. How are these cluster centers chosen? How do we choose where the centers of the clusters are? How do we choose where the cluster centers are? Any idea how we choose where the cluster centers are? We choose them whatly? Randomly. You got it right there. Randomly. 20 points, off-stars points. Everyone here, you get 20 so far. Up to 100 off-stars points. So, yeah. Yep. Jordan, 100 points, helping out. You get maxed out. Whoops. There you go. That's how you do the ideal one. And so these are chosen randomly. So why is end start in there? End start is the amount of times we will restart the algorithm choosing different random points because the points we choose control where the answer is. So you might choose two spots that are not the best two spots that don't minimize the within cluster sums of squares. So the end start you'll see right here is going to be how many times we will restart the algorithm and allow it to try to refine the best cluster centers. So it'll choose random points, iterate them, and then it'll restart the algorithm, which is the end start, and it'll iterate the points till it reaches convergence or max iterations, and then it'll restart the algorithm, and it'll iterate the points, then it'll restart the algorithm. Basically, this sounds like a what? Like, think about this. I want someone for 100 points. I want you to think what this sounds like. You've got right here that you start here, and then you iterate through. So your first end start, and then you do maybe 30 iterations here. Then you do this, and then you go to 30 iterations here maybe. Then you do this, and then you go to 30 iterations here. And you have to keep going until you reach 25 here, but you do this, then you go here. Then you do this, then you go here. Then you do this, then you go here. What does this sound like? Because look at what I'm showing you. You go here, then you... Sounds like a nested for loop. Because you're going to go through the max iterations, and if you look at how we look at it in the notes, the way it looks is you start by assigning the points, and then you iterate through, and you get to an answer. Well, then you restart the algorithm. And so this is now we've restarted. We go into another and then you go through here and you iterate the points. And then in the maximum amount of iterations will be the maximum amount of times it'll move the points around. And then you restart the algorithm and you choose what? Random starting points again. Now it doesn't show different points because I can't make the plot change, but you would choose different random starting points. And then you would iterate through till you reach convergence or max iterations. And then you restart the algorithm again with new random starting points. And then you iterate through until you get this. And what's your whole goal? your whole goal is to obtain the lowest within cluster sums of squares given your starting points, which your sums of squares you get for a cluster are going to be controlled by your random starting points. So when you're at 2 clusters, you might choose 2 bad starting points and get like a local minimum within cluster sums of squares. So it goes to the calculus, I guess, on it, because it's like in a multi-dimensional space, what is the minimum? What is the global min? So for anyone, if Nitin's still here, it's all about like global mins in calculus. Like you're trying to find the, like, but you're in this multi-dimensional space. So where's the global min? If Nitin is here, say hey, because that's I don't know how complex, like, it's the way we solve it. There might be a better way. And if you make these algorithms better, you write papers on it, write dissertations and all these things. But we do it through iterations. You know what it might be? The iteration process might be quicker and just as good as not doing it via, it's just like, there's a bunch of things like there's a bunch of things with mathematics that when you get to high dimension space get very troublesome. So I hope if Nitin chimes in, knows a lot about mathematics. Jordan's question, sorry, Jordan, let's hop to Jordan's question. Asked it a while ago. Jordan's question was, could you help with number 9 on homework 5? Let's do it. What's number 9 say? Number 9 says, which one is bound? 2 seconds, be right back. All right. I'm back. So question 9 reads, what's it read? Uh-oh, which computer? You all right? Okay. Question, wait, question 4. Question 4 is about, okay, question 4. Okay, here's question 4. Since there is no natural choice for the number of clusters here, let's choose k equal 3, run on Kroger scale with this. Print to the screen the contents of this right here. So, oh no, that's fine. Print to the screen the contents of round of this right here. So you have to have the this right here to see the location of the cluster centers and table of k-means of clusters to get a frequency table of how many individuals are each in cluster. Good, yeah. So right here, so then you just print these things out. So we should be good on this. Note that the labels 1, 2, 3 are identities. They can change each time you run it. So if you feel like the grader takes all points where they shouldn't. So print to the screen the contents of round digits 2. So there we go. Those are the centers right there. So I think it's chunk 16. Is it chunk? Am I on chunk 16? Sorry, I'm losing my mind. Chunk 16? Wait. Did I have the right assignment? There's no chunk 16 on mine. Is there... Do you have a chunk 16? It's about social networking right here, right? Okay. This is the one right here, right? Okay. Sorry, I lost my mind. Okay. So let's take a look. Poof. A different way to approach clustering. Social network analytics is a burgeoning, so you say that word, application of data mining. Let's make a social network of the individuals in spenders data frame. There's spenders. These are a subset of customers who have spent money on all 13 categories by connecting them if they have similar spending habits. So here we go. Just take a look, and there we go. Let connected be a matrix that initially contains all zeros and has 72 rows and 72 columns. Is that created for us down here? So we got to do a matrix. So connected equals matrix, and matrix, you can do NA, and then you can do, is it 72, 72? I think we can just do this. Let's try it. Is that going to do it? I think we just did it. Yeah, that did it. That looks to be correct. So I do, but I may have added an extra chunk somewhere. Oh, that's probably it. Yeah, no worries. I was like, what's going on? I was like, that's what I thought from. I was like, I think that's it. Okay. So the value connected ij will be if individual I and j are connected in the network and 0. Okay, so it's going to be ones and zeros. Let's come up with a way to determine if two shoppers are connected. Let xa be the value in the, so the whole point is we're going to store into here ones and zeros. Let xa be the value in the ith of spenders after using as numeric on that row to convert it to a vector of numbers. Okay, so we're going to take, so it literally says to turn a vector in spenders into numbers. So as numeric, and let's go here to spenders, and let's go here to row 1. Oops, I put a period. That didn't like it. So there we go. So there is the values for the spender, and right there, what it says, type double. I didn't like that. Too bad. And so let x be the values in the row j. Okay, and let's treat, okay, wait. Let us treat, values in row j. Okay, so then there's another row. So let us treat these shoppers as connected if the mean of this right here, cool. So here we go, we're gonna take this right here, and we need to go to here, and let's call this x sub a. Was that the way it was capitalized? It is. And here, let's put this in, and let's go here to x sub b, and let's go to row 2. What is Brian doing right here? Brian is trying to write out code for a, and this might work. There we go. So right here, we have the basis. Is this making sense, Jordan? We have the basis of comparing two customers, and we're trying to see if on average their difference is less than 30. So right here, we have the differences, and we're looking at just basically absolute values of their differences, and we're looking at the mean absolute value of their differences. So, and then Pmax, I'm trying to remember what that code does again, returns the regular or parallel maximum minimum of the input values, takes one or more vectors. So this code right here is basically saying, on average, do these customers have less than a 30% difference? Does that make sense? The code is basically saying, with the customers, with what they spend, on average, do they have less than a 30% difference? And I can tell where this code's going to go, because now we want to do it for all the customers. Makes sense, yeah. So now we go here, and this would be stored into position 1, 2. So that's going to be stored into position 1, 2, and I think that's basically got it. Use a nested for loop. Yeah. And then this code right here will fix it. You don't want to, yeah, so you'll run this after the for loop because you don't want to compare a shopper to itself. So this is after the for loop. And I think that's got it. And then convert with iGraph. It's in the and plot the social network. There's so much cool stuff you can do. I just kind of want to do this one. I might just knock it out right here. So because it looks kind of cool when you look at the network of people and how they're connected, because social network stuff is so big. And here's what people do. The whole point to finding out why people are connected is to, like, if you go to an influencer and, you know, just think about, we talked about Jenna Marbles last class, but if you go to like someone like Jenna Marbles and you get her to like mention a product, like what's the probability other people will buy it? So you can look at how influencers even influence influencers. And so the goal is you don't want to market to, you know, you don't market to 1 million people, you market to the people who influence other people. So you try to find these high impact people who can like influence other people to do things. So your money's better spent if you get the influential people to buy items. And so, you know, you could look at like the Kim Kardashian, Kendall Kardashian, I guess, Kendall Jenner, that's her name. I don't know. So, sorry, Ken, they don't watch this. But you go to the influencers and they're, you know, mentioning your product or using your product is very, very valuable. So it's very, very, you know, worthwhile money-wise, like to get influencers to do it. So that's what we're kind of looking at here with this analysis, is we're looking at like how are people connected. And so now the goal of this is to go to 4 and go to 4. Where you at, for loop? There we go. And we go to here. Let's fix these lines. Don't like it looking like that. And let's go to re-indent lines. I should just use Control I. And here, this is basically it. I mean, we're doing it through 72, right? So technically, yeah, it's like you should do this. Took me a long time. I used to make that error all the time. I think Matrix can take this still. You could put number of calls in here also, but it's, I mean, number of rows, but it's going to be number of calls better. This is I. This is J. This is I. This is Mr. J. And this is going to be I. This is going to be J. We're just reassigning things. And I think that's got it, unless I did something wrong. I think that's, oh, wait. This is false. So if, oh, and I don't have the store into. So let me do this. This is a bad idea. Eval, I mean, to code inside of here is a bad idea. Like you want to get your coding up before you go inside here. If eval, if it's true, then store into this 1, else store into this 0. I could have written the whole thing out, but does that make sense, Jordan? I could have done it on that line, but I'm kind of just breaking it apart. And so if eval equals to true, we'll store a 1 into that spot. And if eval is equal to false, we'll store a 0. How's that looking, Jordan? Does it make sense how I did this right here? And I think it'll work unless I broke it, and then I'll have to like work on my code. Would it not be? Oh, no, good point. So you could do that, but so you're gonna get, here, we'll show it. Let's see if it works. Cross your fingers, everybody. Here it goes. Up, matrix not found. Do we not make the matrix? Oh, we called it that. Okay, there we go. Okay. There we go. Okay. Well, took longer than I thought. Okay, so when you look at, okay, there we go. Good. It looks to be working to a certain extent. Let's do the sanity check here to see if it does work. Here's what it says I should be getting. And yes, we got the sanity check. Woohoo! Good. I was worried we didn't for a second. So this is correct. And do you see the diagonal of 1s we get? Let's look. Do you see the diagonals of 1s right here? Now, you're not supposed to get this diagonal of 1s. How do we fix that? We go right here to this code where you go to the diagonal of connected. The diagonal of connected is just all the values in the diagonals, which should just print out 1s. So if you go to diagonals of connected, you will just get all 1s. And guess what we're going to do? We're going to overwrite that with 0s. So now the diagonal of the connecteds is just all 0s. So that just takes the diagonal vector, and now it's all 0s. Yeah, sure. This line of code with the if else right here, I'm storing eval. Like eval is just going to be, and it was the last thing I did, it's a true. So eval is whether or not the difference, the typical difference between them, the average distance between two customers and what they bought is less than this. Does that make sense what eval is? Does that make sense what eval is? Eval is just whether or not their typical difference is less than 30%. Does that make sense what eval should hopefully make sense? Like, do these customers have a difference between what they bought that is less than 30%? True or false? Like when you look at the average amount of the difference over their customers, and we're looking at the mean absolute value. Cool. Like on average, their difference is less than 30%. Now we get to this right here. So let's break this apart. Let's just first look at the if. If it was true that their difference was less than 30%, we're going to store into the matrix where customer 1 is and customer 2 is a 1, meaning that that's basically a true. We could have probably just stored the true in there also, and trues and falses are 1s and 0s. But if it is true, because if this came back true, we're going to store into that position in the matrix a 1, and the else will only happen if it's false. So if this was false, then we will run this code. Does that make more sense, Jordan? Like, if it was true that their difference was less than this, we will store into the matrix for the position of those two customers a 1. Else, we'll store in the position of the matrix for those two customers a 0. Yep. So hopefully, yeah. And then we should be able to make the visualization of this, right? Here's the graph. Cool. Sanity check for value of connected. For the mean value, yeah, we can just do mean of connected. Should do it. Yay, we did it. We got it. And could not find graph from adjacent matrix. So this function right here is in the what package. What package is this in? Why do I not have this package? Probably says it somewhere else earlier in the assignment. It says, download this package. You need another package. What? Is it in iGraph? What is it called? What package is it in? iGraph. Yeah, it's iGraph. That's, I just said that earlier. So install.packages. iGraph, please still be available. Looking like it's available. Looking like it's available right here. There's iGraph, and before we use it, we need to go here and go library. When I reinstall, I'll lose everything. There we go. We're gonna make it, well, that won't display it. iGraph, and there's the graph. Set seed, and there's the plot iGraph. Cool. Whoa. Does iGraph have ggplot? Please tell me iGraph has ggplot. That's not that interesting. It's how the customers are connected. And you can look at like the social network groups. It doesn't look as good. It'd be better if I had better dots in it. And Dr. Petrie did something super cool with this a few years back. Let me see if iGraph has ggplot. Ggplot for iGraph. Ooh. Plotting iGraph objects with ggplot 2. An older thing. Whoa. Okay, this is the last thing to look at right here. Okay, oop, here we go. Oh, that's a lot. That's a lot of... No one's created a quick function for this. This guy's got some really cool graphics for it, and they look way better for social network plots. But it's going to take me more time than I want to do it. But I wish someone just had a quick function for it. So why is it a circle? It's the customers. So let's talk about what this graphic represents right here. And you can barely see the numbers. Like that says 16 right there, and that's what I'm not happy about with this plot. Let me save as PDF, and let me go to, because you can keep the original, that's going to keep the aspect ratio, right? Or not? Sure. Then this will be 18. And this will be cardar plot 4. And let's see if it looks, okay. There we go. Okay, I mean, this looks better now. I'm still not, I like better graphics than this. I mean, it's all right. But you can see the social networks of things. So these are the interconnectedness of customers. Like you've kind of got these customers hanging out by themselves over here. Like they would influence each other. And then you've got, oops, I wish I could pan around over here. You've got these social groups. You've got a little social group of 4 right here. So if you wanted to get into this market, you would need to influence one of these people. So this is like a social group right here of these customers that influence each other. They're connected in their buying habits. And then you've got this huge network. So you've got a big network here of people connected. Just think about like friend groups. And like this is like a connectedness of friend groups. You could even, look at who's kind of connecting. Like these 4 people over here are connected with this person right here. So like this person's a good bridge between like, this, I'd call a person like a bridge because they're going to connect. Does that make sense what this is showing you? It's like showing you the connectedness of customers who have similar buying habits. And then you get like, ooh, this person's a really high value customer. They're very interconnected to a lot of individuals. So you can see like who's connected to who. And Dr. Petrie did a really cool analysis of this with the graduate students. I think he does it like after the first semester, and he asks them like who they study with and stuff like that. Like, who do you study with? And he'll create like these social networks of like who's influential in the graduate students. And I think he's used it to be like when he needs to disseminate information, he'll go to like this person right here. And then he'll maybe go to like this person right here because they'll disseminate out and they're connected to like all these groups. And he'll, figure out who is the influencers in these social groups and who is the one like, so it's pretty cool. You can use this analysis for a lot of stuff. But we kind of just did that whole question. It's a tough one. I mean, it's really a nested for loop question, having you look at this in a different way. But I like that a lot. So, whoa, this is the graphic you should turn in. You should turn in that graphic right there. It's a horrible graphic. once again, if you zoom out on the plots, you can make them look better. So that's what I did right there. Well, there's more questions. There's more questions. Good question there, Jordan. Pretty fun one to do. Pretty interesting output. I vanished on the screen. Q2A, Sarah. Q2A. Let's do Q2A for Sarah right here. Q2A. I should use this every time. Q2A. Okay. So Q2A. Where's it at? Responses right there. Cool. Oh my gosh, so much to read. In the global environment, you will find a function called scale data frame, which takes a data frame as an argument. It outputs the data frame with each numeric quantity scaled to have a mean of 0 and a standard deviation of 1. Left arrow are the results of scaled data frame with taking the log of it plus 0.01. And so I want to pause right here. And these are some good questions for the test because clustering is on the test. Why in the world are we adding 0.01 to this? I would love this as a written response because these are the amount people are buying of items. So why are we adding 0.01 before doing this? Like, you should know why you do something. We're adding 0.01. Why are we doing that? You could add 1. The problem is people might spend 10 cents on an item, so adding $1 is kind of a big shift. And you can see something. If you go here and you go log 10, now the minimum in this data set is going to be this, and it should be -2. Wait. Oh, that's E. Whoops. There we go. That was log of base E 0.01. It's because many things at the store are 99 cents, and by adding 1 cent, it rounds it up. Close. Well, so watch this. If someone spends 0 on an item, if someone spends 0, can't take a log of 0. Yep. We get negative infinity. So now if someone spent 0, it's going to be 0 plus this, and we get that. And the issue, too, is that we don't want to add too much to it because people might spend very small amounts. And if you go here to the min of the Kroger, data frame is 0. If we go to sort, I've never done this before. I'm wondering what's going to happen. Yeah, it doesn't like that. It'll want let's go to the column 1 and let's report just the first 5 items. First 50 items. Jeez. Whoa, what you doing? There's so few. Really? There we go. We finally see some now. Yeah, look. Vajrana. So 100 points right there. Logs are still like my final boss list. So the reason we do logs is there's a big thing right here. And this is definitely, I have to write these test questions later, which I'm finishing up. I've been writing test questions so much, it's driving me mad. So I don't understand it. If they don't buy anything, then why is there even a 0 for them in the data frame? Because we're looking at, here, let's look at the Kroger data frame. We're looking at how much people spend on like baby items. So this is right here, customer number 1 in their like monthly spending spends $43 on alcohol, $1 on baby items. They bought a pacifier, it seems. $555 on cooking, $309 on drinks. But there's people who spend like 0 on baby items. Customer 5 spent $90.76 on alcohol, $0 on baby items, $854 on cooking. So this person really likes to cook and drink, and they just spend a lot of money, but they don't have babies. You can go to your alcohol. Whoa, holy mackerel. Look at that. That's crazy right there. So that person... This person spent $13,000. Does it make sense what this data frame is? It's the amount of money that people are spending on their Kroger Plus card. And this is actual real Kroger data. So this Kroger Plus card had $14,000 spent on alcohol. And then you could look over here at their other items. And then they bought meat. So this was like a huge, these people like to grill out and buy really great alcohol. So there you go. You could go to the health food people and just look at them. These people buy a ton of health food. Or like these people are more interesting because they're really buying health food. They buy cooking and health food, and then they're fruit and veggie. So, which makes sense. You'd expect that. You could go to grain. There's people not buying grains, but does it make sense what these values are? And then the most important thing, we have this question right here, is why are we log 10ing something? Yeah, awesome. It helps to like look at the data and be like, what does this mean? Like, what did we collect? And if you collect data yourself, it makes more sense. Why are we log 10ing this? To make the data what? What's the point of log 10ing something? What is the point of logging a data frame? to make the data what? It goes from this to this. What is the point of transformations? Normal, Casey, 100 points right there. Get those 100 office hour points. It makes it normal. Yep. So the point of transforming is to get normality, symmetry, and that's what normality is, unimodal symmetric distribution. And then what's the point of scaling it? What is the point of scaling it to put it like with a mean to turn it to z-scores? What is the point of scaling it? So what's the point of scaling the data frame? What is the point of scaling the data frame? What is the point of scaling it? Okay, that runs. Running into Kroger scale. There we go. Make sure I get the name of it. It's going to make life easier. Copy paste your best friend. Autocomplete your second best friend. Standardize, put it all to the same playing field. Yep. Puts everything on an even playing field. This will add a penny. Hit apply. And then apply this to verify. Okay. So all these are going to do is we should see zeros and ones. If you see things that are slightly different, I mean, just change this. And so I've had people say this to me before. People say, wait a minute, I'm not getting 0. These are basically 0, and those are all 1. These, it's just decimals. It's 0.0000000000000019169. So literally this number right here has this, what you're seeing, because it's e to the negative 16, just so everyone knows. This number right here is 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and that's the 16th 0 over here. So that is this number right here. It's basically 0. For all intents, it's just the decimals. We couldn't, R could not carry enough decimals, and that's one of the bigger ones. Everything else is that size or smaller. Like this is even smaller. Don't look at the first number here because it's confusing. People think the mean is 5, but it's scientific notation. You can confirm this by saying 5 e to the negative 4, and then you get this, or let's have it display it. There you go. So you can see, you can count it up, and that's what it's showing you. So should be very clear on what this is showing you right here. I've seen a lot of people say, but wait a minute, it's not showing 0. It basically 0. We've done it. Provide a histogram of cooking as well as kernel density estimates, a smooth, continuous version of a histogram. So that's all the kernel density estimate is. And then there it is right here. So let's go to the plot. And let's look at it. Okay. So, boom. Cool plot. So what this is going to show us right here is, and you know what we could do? Watch this. Ooh, we're going to do something cool here. I think if we do this, let me do something. Parm. What am I thinking of? mflow. Parameter. No. mflow. Oh my gosh, how do I not know this function anymore? Show 2 plots in R. 2 seconds. I want to do this. Show 2 plots in window in R. It's like paramflow. I know it is. It's paramflow. Where is it? No. Par. It's par. It's par. Par. There you go. M. Oh my, this is going to drive me nuts if I don't. 2 seconds here. Sorry for the pause, everyone. I really want to plot these side by side to show it visually what's going on right here. Why is it not paramflow? There it is, paramflow. There it is. Okay. Yeah, it's that. It's not going to autocomplete. Par. M. Oh, I guess it doesn't autocomplete. And then, do we not need to do two? That's not going to work. Yeah, you got to concatenate it, right? Or am I totally going mad today? Okay, that worked. Okay. Now, let's try this. Let's see if I get the visual I want to show, because this is an important visual to see. Plot, got it. Okay. Oof. Yes, yeah. Good. That's, okay. Oh, and I did 2 by 2. We want 2 rows, 1 column. So 2 rows, one column, get them stacked. Okay, fix that. And then this right here, we want for the first graphic, we want the first graphic to auto do its limits. The XLim on the first will auto do, hopefully. Plot new too big of margins. Okay, let's try it again. Oh, really? What is the scale on that? What is the scale of cooking? Kroger cooking. Oh, it goes to like 2000. So 0 to 2000. Will it not let me display that? Too big? Really? Let's hashtag this out. Well, that's such a bummer. How about 10? Too big. Is it really the... Maybe it's the... Let me try this. Okay, that works. It was that. Okay, that's doing that. That's doing that. My limbs have to be off. Is it because of this? Now we're seeing it. Now we're seeing it. There we go. 0 to 1500 or so. And can I not do this? There we go. Whoa, it goes outside the box? That's not what I want to happen. Oof, don't like that it does that. That's so weird. I've never seen it do that. That's so weird. So that goes... Is there negative? There can't be negative on that. I've never seen... It looks like a graphical issue to me. So let's put that to -5. And let's put... Okay, let's try this. So -5. And... Okay, that's looking better. And then this needs to go to 3000. There we go. Okay, now we're getting somewhere. Oop, calm down, code. Okay. Okay. 3500. Okay. Where's 3500 at? Sure, whatever. I'm just going to ignore that. Okay. Let's see how chat's doing. So this took me so long. Okay, for everyone watching in here, this was a very important graphic for me to make. I'm going to disappear. We still see some skewness to it due to probably these low values down here. And I guess there might be negative values for cooking, which doesn't make sense to me. This graphic might not be displaying properly. I'm a little bit confused by that. I could just run min of cooking to check that out, but it's a little bit something weird with this graphic going on. I'm wondering why that's weird. But if you notice right here, this is the, it says scaled cooking right there. So we got to just change one thing. Kernel density of cooking. And we want this graphic to look proper. And there it is. Okay. So here is the kernel density of cooking, and here's the kernel density of scaled cooking. So this has been all turned into z-scores. And if you notice, this has a humongous skew. This is the original data, and this is the data after we transform it. And aside from this, it's almost a really good normal curve. It's got this good bell shape there, and it goes down. If it were to just bevy out here, if it were to really start to go down here and get very flat, it'd be great. But it's just a little heavy in this tail. And we could also view this other ways with like a QQ plot for normality. And, you know, since we said it, we got to do it. It's very easy to make this. A QQ plot for normality, we're just literally going to take 2 of these and put them side by side right here. And we can just do the following. But this is the kind of things we want to be thinking about, like, why do we do this? And now we're getting, we need reg class. Do we not have reg class on? So, and there we go. Now's our QQ. Whoa, what's going on with my plot windows? I think this is something I did to R with, yeah, the plot windows are having problems. Oh, they're both still, wow, they're both still, the scaled still looks like that. Wow, this is data that's very hard to fix. Made it look better, but wow, they're both still really bad, even the scaled. Well, that's a bummer. The density plots show it off a lot better, though. And I'm going to try something real quick. I'm going to save this. I'm going to close out of R. Don't save. because I've seen that graphical error. Now that I remember, I'm going back in time in my brain right now, and I've seen that graphical error, and by resetting R, I think it fixes the windows. I don't think it was the par inflow that did that. Usually I don't see par inflow doing that. Did I lose it? Oh, wait. Homework 6 clustering. Let's run all the code above right here. Okay, I think we loaded the values. We haven't loaded it. Let's load the environment. Downloads. Homework 6 clustering, R right there. And there's this, there's this, there's this. Ugh, you see it was the... And there we go. So you can look at the two different graphics right here. And so this tells the story really well now, and it was the graphic window got messed up. I've seen R do that. We definitely get a little bit better normality. It was very skewed to start, and now we get better normality. And the QQ plot I'm actually fascinated by, that it's still really bad. It's just these low values down here. And yeah, I mean, it doesn't have that extreme one, but it's got these. Is that the, yeah, I don't know. Hard to fix data sometimes. So the question, although not every column looks perfectly symmetric, we're much better off. Yep. And then response, what is the question that it asked? Comment on why it's necessary. There we go. We did that. Next question. Sorry I went off such a big tangent, but this is the kind of things we should be thinking about, like why do we do this? And how will the data look? And then what are better ways to display the data? So we could take another column here. Someone asked the next question. I might go back and look to see what else people asked. But we could run this same thing like on a different column right here. And what was another column possible in here? We could run it on drinks. And so probably best if we do the QQ plot. We do the QQ plot. Does drinks look way better? With QQ plot for drinks, yeah, it looks way better. It's still got problems down here on the low side, but yeah, it's just got this and this compared to that. So let's see, what were the other questions? And the other questions were, I'm scrolling back up. Q2D. We didn't do Q2D for Kelsey yet. So let's see, Q2D. Is it the elbow plot one? No, it's Q3. Q2D. Wait. 2D? There's no QD, right? Am I going mad? I think it's Q3, right, Kelsey? I see Kelsey's. We'll see if Kelsey... And then we've done that one. 3A, elbow plot, we did Madeline's, and I think that's got it. So Kelsey, was it Q7. Thank you, Jenning. Q7, hierarchical clustering results. Okay. So, wait, 2D or... Wait, I'm so confused. Is it this one right here? There's no extremely long, uninterpreted set of vertical lines, so there's no obvious natural choice for the number of clusters so that reflecting underlying structure. When this is the case, we choose a small value of the clusters and interpret them, then we add another cluster, and we see if it brings new interpretation. So we're going to look at the fraction scaled into fraction scaled with ID and assign cluster IDs to it with the cluster IDs. Sounds good. Using the aggregate, find right here, and it gives you the aggregate right here with the different clusters. So we need to have our different cluster schemes created. You can't run, oh yeah, I think you might email me with this. And so we need fractions scaled with ID. So is this from a dendrogram? I think this is from a dendrogram, right? No, this is from k-means. This is from k-means. So we have to do fractions scaled. Okay. So I'm going to kind of do a little bit of work right here. Here's the fractions. There's a sanity check. And so we have to do fractions scaled, right? So we've created our Kroger data frame right. Is that got cool? And then remember, delete the code out of the chat. I'm going to grab that here in a second. Well, you can keep that in the chat. That looks it's in quotes. Don't do this. The issue might be that your code's in quotes. Just don't do the code in quotes. So here's my Kroger scaled, and then we want to do fraction. So when you do the fraction, what you can do to get the fraction, so I'm doing where you have to find the fraction of the Kroger data frame. So we want to do Kroger scaled and do a fraction, right? So you want to go to the first row, which is an individual. This is what the first person bought. And you want to take and you want to divide this by the sum of the Kroger scaled in the first row. Does this make sense right here? This is the fraction of what this first person bought. And now we want to store in here to fraction scaled. And we want to store into here for the first person. What have I just written right here? What did we just write by writing this line of code? What did I just write by writing this line of code? This is on the test. I'm dropping test hints right now. What did I just write by writing this line of code right here on the screen? Writing this line of code is the what that I'm going to use, because I just did it for the first person. So I just found the first person's, scaled values. So I just created the first person's scaled values. What does this have right here? I think it says to store this right here. So there we go. Oh, what's going on? What's going on? Incorrect number of matrix. Oh, oh shoot! I might have broke my thing. I think I broke it. Okay, I broke it. And then let me put my param flow back. All right, then fraction scaled. Oh, is this the one that wants us to do it? Why am I going crazy? Didn't one of them say find the percentage, or am I going nuts? I might be going crazy. That's my skeleton. 3D. You got it. We'll go back to 3D. You got it. Sandy checks. Copy Kroger whose contents should have modified since the data was read into the column, then write a for loop that goes through each fraction to find the fraction. Yeah, this is it's fraction scaled. Cool. It's fraction scaled. And we're writing that code right here. So this is Kroger scaled. And Kroger scaled is going to go into fraction scaled. There we go. Okay, that worked. And this is the skeleton right here. So we're going to take our skeleton. We're going to copy it. We're going to go back here. We're going to go 4. We're going to drop this in. We're going to go variable I, placeholder. We're going to go 1 through the number of rows in Kroger scaled with I scaled. And then this becomes I right here. So this is our skeleton. We always write that first. Hint, 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 hint. And that runs, and then we look at fractions scaled afterwards to confirm. Now, don't leave this in your output, but that certainly looks like it. Now, there's ways to check this, which it says with like apply, and we're going to apply on all the rows, and we're going to do the sum of all the rows, and they all equal up to 1. So everybody here has been checked to make sure that every row has a total of 1. So when you do this right here, it does the sum of every row in this data frame. And so this is we know this accounts for 100% of the items people bought. So this code is on the screen right now, and now we do have our fraction scaled, which we can do for number 7, I think. So number 7 wants us to do the hierarchical clustering, right? Was it hierarchical? I have to check. Okay, it's hierarchical. So instead of running k-means, let us try the hierarchical clustering. So once again, we're going to go back to the notes, which are a huge help. And we're going to go here to hierarchical. Let's go to dendrogram. It's going to be our quickest way to find it. So here we are with the dendrogram. And here is the code to get your hierarchical clustering right about backwards. There it is. Age clustering your data, distance equals data. And let's go here. Let's drop it in. And now Kroger scaled. No. What is it called? We just saved it. Fraction scaled. Fraction scaled. And then we're going to use what method? Ward's distance. And then we can plot it. We should get the plot. Woo! Crazy plot. we got a lone customer out there. So if you look at this, what clustering schemes look valid? Remember, this is on the test. This is a great review. How many clusters would you go for here? How many clusters would you go for? Any ideas on how many clusters you'd go for here? Who has an idea? And there might be one you think about pretty quickly, and I'd be like, well, 4. Yeah, 4 seems pretty good. Great job, Madeline. 100 points right there. 4 would be going across here. 1, 2, 3, and that's the 4th. 3 or 4, yeah. 3, you might be saying, wait, Brian, if you go this way, wouldn't you just be cutting 2? This person extends all the way down. It's hard to tell, but this person's an outlier. they're doing their own thing. So if you only do 2 clusters, you only get this person right here by themselves. Is this the dendrogram? This one looks a little bit weird to me. Is everyone getting this dendrogram? That person's there all by themselves. Did everyone else get this picture? Am I getting the same picture as everyone? Maybe I should have ran sets. No, set seed won't matter for this because it's doing the distances. So it'll get the same result every time. You get a different one. Dun, 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 dun. So distance, fraction scaled with methods word D. Am I using the same data frame as you? You're getting a different one? Yours looks different? Yeah, I thought this one looked weird. Because I was like, so what did I do? Are you running it on fraction scaled? Are you running your data on fraction scaled? Is everyone using this code? Drop your code in the chat. Yours looks different. I think it's because we got fraction scaled by different way. And let's see. Unexpected backs. Oh, that thing. And then we just plot it. Oh, you're supposed to do it by Kroger? Haha, ha 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 ha. That's what happens. So let's fix it. Let's fix it. Uh-oh. Uh-oh. That's why we check. And so it should be Kroger. Yeah, that sounds right. The question will tell you what to do. Okay. Now, let's rerun this. That'll recreate it. This is the right answer now. Great job, everybody. Helping Brian out. Let's go here. Let's run this with Kroger. And here's our dendrogram. Are you getting this one right here? I was like, I don't remember seeing that dendrogram before. What looks to be the right amount of clusters? This should be what everyone's getting. What is the right amount of clusters right here? So we're just doing the, we turned it to percentages, what each customer spends percentage-wise. And we're not using the Kroger scale, we're just doing the Kroger. So it should be Kroger. Because I was like, I don't remember I've done these types of things before. And I was like, I don't remember looking like this. That one person was hanging out there by themselves. Is this what everyone's getting? We'll see what people are saying in the chat. What? Did I use words? What is going on? What is going on? Kroger, some Kroger, fraction scale. Oh my gosh. Wait, but that shouldn't. Let me double check. Let's see what's going on right here. You didn't fix one? What did I do? What did I do? That shouldn't change anything right there. Da, 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 da. And this is this. That's looking good right there. What did I not fix? Help me out, everyone. What did I not fix? Sorry, jumping around the assignments is not the way to do it. Up, 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 up. So how's this looking? Third try is a charm. Third try is a charm. Is this? I don't think this is based on randomness. It shouldn't be. Again, same thing now. We should calculate fraction first and then scale fraction as fraction scaled. Oh, really? Sorry. I should read the assignment. So calculate fraction and then do fraction scaled. So wait. Sorry, everybody. I'm jumping through the assignment and then, so you're saying fraction. There we go. Okay. So here is, so there's fraction, and then we need I should read what it says. It says fraction scaled. That would make sense, right? Okay. So now we need to do scale data frame. And I don't think we're adding anything to this. What's the function called? Scale data frame. Scale data frame, fraction. There's that. Okay, good. That ran it. And now we go here to fraction scaled, and we do this. That would make sense. So we're finding the fraction and then scaling the fraction. So right here, that's what we need to do. This line of code right here does not need to exist. And then that just confirms that we have, well, that's now z-scores. So we can confirm after we could run this code right here on fraction. And this will all be ones. That'll all be ones, and then this is all z-scores now. So we have the customers who spend like on average more, on average less. And because we now scaled everybody based on different things, and that's running it across all the rows. Okay, so there we go. There we should be good. And now for the 4th time, let's go down here. Let's check it out. So what happens when you skip through an assignment? Don't do it. Don't skip through. Do it in order. Where is it at? Where's plot at? Here we go. 4th time's the charm. Got our fraction scaled data frame up. How's this looking? How is this looking? How are we looking? Pretty good. How is this looking right here? Is this looking like everyone else's? Yes, no? Hoping it's yes. So now we should have done it because we did the fraction and we did the scale. If there's no, I'm going to be like, no, what's going on? How are we looking? Still different. Still different. Let's see. I might need to just go. I might need to go. Let me double check. I'm gonna go do something real quick. I'm gonna go. What have I done? Why don't I get the same? It could. No, we're not using randomness procedures. So let me check. Because now I'm thinking I don't know where the error is at. Sorry, my brain shut off after 4.5 hours. And so let me look at something right here. So where is it? I am going to double check. Let's find out. Let's see what the answer is. Let's find out. And we will know the answer coming up right here. Let me take a look. Oh, man. And we are down further here. Wait. I think it's the same. I think I've got it now. I think because I was like, I don't see where the error is. Let me check. The answer should look like, I'm going to take a picture of it. Here's what it should look like. And let's look at our picture. Let's zoom in on this. Here is our answer that we have. That's our answer. And here's the answer in the key. It is different, isn't it? Is it? Yeah, it's got that separation. Is this what you're getting right there? I'll check my work here in a second. You're probably getting, oh my gosh. Why didn't I do that? Because we're doing it with this. Oh my gosh. 1,000 points, correcting Brian. The problem tells you how to do it, and I'm not following the steps. I am not following the steps that we want to go right here, and that should do it. 1,000 points, correcting Brian. And now, let's take a look. What? What is going on? Log 10, fraction, scale data frame of fraction, log 10, apply. Let me check. That's the picture you're seeing. The picture I show you right here is the picture that you get, right? That picture is the picture you get. Yep. And then let me think. So let me double check. We're finding the fraction, just one thing, but different with the answer you just showed. Like, this is the answer this is the right answer right here on the screen. Blah, we want to go away from it. Taking the fraction of each row, and then, which question asks you to do this? Let me read the question, or I think that's where let me look through here. Because let me see which question asks us to do this. Okay, it looks like the question right before. Okay, let me see. I'm going to just grab the code. Because we're like literally right there, and just one thing's off, and one thing off destroys the code. Oops, where's this breaking? Okay, it's no longer breaking. Okay, so let's find out where the error was at. The error, let's see. Store into we're just creating here this. Number for 1 in n rows, fraction is equal to fraction. Oh, because fraction was originally that. Yeah, you can do it that way. Is it going to get mad? It's not mad if you should not care either way. And then let's run the dendrogram on it. See if that fixed it. I don't think that'll fix it. Like if that fixes it, then I'm a little bit confused. And I want to know why. Really? No, that didn't fix it, did it? Tell me it didn't. Okay, good. If that fixed it, I'd have been... Wait, did it? No, because this is... That might be. It's so hard to tell. No, this says at 40. No, because this one right here, that's at 45, and that's way higher. Okay, so that didn't fix it. Good. If that fixed it, I would have been very confused if that fixed it. I would have been like, I don't understand why that fixed it. Then here's where the error must be. If the error is not in there, it's going to be over there, because here's the right work right here. This is removing... Oh, no way. Really? And I'm sure it says this in the instructions. So literally, we had it now, because I was like, I couldn't... It says in the instructions, probably null that out. So now it's going to work. I was like, I don't see. And now let's take a look at the answer. Yeah. Okay. So now this has got it. So the whole thing was, if you're wondering, and I was just so confused because I was like, at that point, I don't know what I'm doing because we've... does this make sense here, Jinning? That we... yeah, so it's wards, and you see it down here in the code. But does this make sense right here that we had to null out a column? And I'm sure I just didn't read that part. That's why jumping around the assignment, like I didn't follow the steps it said where like, then do this by this. So since we didn't null out the column, it was using clustering schemes, and that was the issue. Good question. Let me see. I'm sure it says like a bit in here about like why you know it. So, okay. Then null out the other column for fraction. One of the 13 columns is now redundant since the values in a row add to 1. So, so the column other, one of the 13 columns is now redundant. Oh, yes. And I'm wondering, because it changes the answer a little bit. So this actually goes to mathematics. And the reason you would do this a lot of times is because imagine if I say to you, there's... we have freshmen, sophomore, juniors, and seniors in our class. We're gonna no graduate students. Oh, sure, we have graduate students too. We have freshmen, sophomore, juniors, seniors, and graduate students. If I tell you how many freshmen, sophomore, juniors, and seniors there are, then could you figure out the percent of graduate students? If I tell you like there's 10% freshmen, there's 20% sophomores, there's 20% juniors, and 20% seniors, could you figure out the percent of graduate students in our class from that? If I tell you the 4 groups, could you figure out the 5th? So if I say there's this, and this group, could you then figure out the 5th, which is the only remaining group? So there's 5 groups, and I tell you 4 of them. And so what we're doing is a lot of times with the algorithms, if you don't have to give it the information, you limit the information you give it if it's redundant information, because the algorithm is not going to learn anything new, because the algorithm, it could deduce that, and it already knows, like, the information would be... linearly dependent. So this goes to mathematics. The information would be linearly dependent on the other rows in the data frame. So or other columns rather. So we're removing out one of the columns, and it shouldn't change the answer, even though it does a little bit. So we're removing out one of the linearly dependent columns. There's only one linearly dependent column. Like how much people spend on other depends on how much they spend on all the 12 other items. So you could literally deduce how much people spend on other by knowing their 12 other items, so it doesn't add new information. And what is our point in statistics? To explain variation, and the variation in other is explained by the 12 other variables. So the 12 variables explain the variation in the 13th, because then if you know people spend this. Yeah, no, great question. That's a really great theory question. Like, why would we do this? Always ask those questions. As you can tell, you have to know the theory and you have to know the code. Like, why do we do this? Why would we null out a column? It's to give it a less laborious procedure, because especially when you get to higher order data sets, the more things you know to limit what you have to do, the easier it is for your code to run. And we are finally up to cutting the tree. So now we're going to cut the tree, and we see right here, where's the cut tree? So we can copy the cut tree code. Let's go to where we cut the tree. So here's the hierarchical clustering. Let's go look at some cut tree code. And here we go with the cut tree. Cut tree takes the tree, cuts the tree at a height. And we're going to cut with clusters, though. We're going to cut with, right here, So it gives G two identities, cut tree with how many clusters. That cuts out a height, that cuts out a cluster. So let's go back here and let's cut the tree. And so this should, we called it HC, right? Okay, perfect, perfect. Okay, so this created a vector of data for us. We've got the Kroger scaled, and we need to go here, and we need to go to Kroger. Which one are we working with right now? Fraction scaled with ID. So fraction scaled with ID. So I'm just overwriting a data. I'm creating another data frame. I'm taking my original data frame and writing it into another data frame. And now we're going to store in here to, I don't know if it wants K2. There's K2. There we go. And this will be K3, 4, 5. K3, 4, 5, not 25. And there we go there. And uh-oh, K3 not found. Let's see, where did I... Oh my gosh. Whoops. It's always something small. This will actually create it now. If I am correct, yeah, it did create it. Okay, cool. So see what happens when you break down K3. So it wants us to look at K3 right here. And we get the first row. So it should be the same. Oh, it's rounded. Good. Yes, it's rounded. So we can round this to make it easier to look at. Round. Maybe Jinning, did that help you right there, Jinning? Did you find where your issue was? Oh my gosh. So hopefully that caught, I don't know, maybe you didn't save them. There we go. And let's report just the first row so we can just view the first row of it. There it is right there. And we see the output wrapping around the screen a little bit. So we can confirm our answer right here on the screen. Let's get them, both of them right next to each other. And we did it, it looks like. Tell me it's all correct. Yeah, it looks all correct. Works now. Was it the creation of these right here? You just have to cut the tree. You can tell the tree to cut at a certain height, or you can just tell it to cut to a certain amount of clusters. So this tells it to cut to so that there are 2 clusters, and it can figure out when there's 2 clusters. And then this right here literally just assigns the like in order of like everything. Yeah, it's just something so small. Don't worry, Jinning. 1,000 points, Jinning. I'm throwing some crazy. I really appreciate you staying and asking these big questions. And the smallest thing with code makes everything explode. Like you just make one error and it's like, well, what's the problem? And then your brain starts going, well, I can't find it. And like you can know how to run the code and you just make one error and then everything's like, and it's funny because I laughed because I stored everything into fraction with ID. And if you're wondering why did I not have to rewrite this code, it's because I stored into here. And then when I ran this code right here, it overwrote fraction scaled with ID with where I just stored everything. So I made a data frame, stored into my old data frame, rewrote my old data frame into my new data frame. So it was a very backwards way of doing it, but it worked. And now you can just run this code in order. I mean, it's already stored in there, but it's got it now. And then here's the, you can see these people, we can turn to z-scores and everything. Looking at the cluster center, so you can see has a value of 2 because these are z-scores. And so you don't have to worry about the k's at the end of this. So which cluster scheme? Looking at the cluster centers for the 3 cluster scheme, there's obviously, okay. So let's look at not just the one. Okay, so here it is. And I've got it pretty small. Let me vanish. Boop. Here. These are your baby people. These people buy baby items. Don't worry about this stuff over here because this is just the cluster ID is based on. Would you know what's interesting? This tells a story that, and you can probably see it in the dendrogram, but cluster 2 and 3 in the 2 cluster scheme merge together. So you can see that 2 and 3 will merge together, and cluster 1 is the cluster that stays by itself. So cluster 2 and 3 will merge together in the 2 cluster scheme, and doesn't matter what ID they are, but you can tell. It's hard to tell here. And ooh. So you can see the 4 cluster scheme, what happens. And yes, this is actually all of cluster 5. And then there's, this is where cluster 1 gets broken apart. Cluster 1, we could look at how many there are in these clusters. So you could, if you want to see how many there are in each cluster, you would just go to, you go to table, you go to a table of cut tree. So if you want to see how many there are in each cluster for this 3 cluster scheme, you could do that. and that'll tell you how many there are in each thing, because that's how many IDs there are. I mean, you could also do it for the Kroger, the fraction scaled with ID. Like, you don't have to use this because you've already stored it. So you go here to fraction scaled with ID K3, and you'll get the same output. So because it's already, we stored it in the data frame, and it looks like at the very end here, 2 stays 2 and 3 becomes 5. So if we go to the 5, 2 stays 2 and 3 becomes 5 and 1 gets broken apart. So if we look at the dendrogram on this, we'll see the story of the dendrogram here. So where's my oh, there's the dendrogram. And is that the right dendrogram? Where's my dendrogram? There it is. Okay, let's see if it's the right one. Yeah, here we go. Here's cluster 1, and this is 1 and 2, 2 getting split apart into 2, 3. And then, no, wait a minute. This is cluster 2, 3 gets split apart. So cluster 1 is the one that keeps getting split. So cluster 1 has to be this. So this is cluster 3 over here. And this is, yeah, because this one stays the same as you go further down. This one stays the same. Then this becomes, yeah. So this looks to be cluster 1, which keeps breaking apart, because cluster 1 breaks apart here into 2 clusters. And then cluster 1, let me look at the 2 cluster scheme. 13, so these, that's slightly confusing me right there. Well, time to go. I'll see everybody later. Bye.